Hello, I'm Greg. Welcome to my channel, Midnight Oil Software. In this video, we're going to be diving deep into building one of the most iconic arcade games of all time, Asteroids, from scratch in Unity. We're not just going to slap some objects together and call it a day, though. Now, we're going to build this game with an architecture that will scale, and more importantly, teach you some solid design practices that'll be invaluable when you take on bigger, more complex projects. I'm going to break down some of my design decisions, explain why I'm organizing the code in a certain way, maybe talk about what design patterns I'm using and how you can apply these principles in your own games. So this won't just be a tutorial on Asteroids. We're going to talk a little bit more about the how and the why behind making games. From using an event bus to decouple components and keeping things clean, to object pooling so we can handle hundreds of objects without a performance hit, even a pooled timer factory that will allow us to handle all kinds of delays in our game without having to worry about coroutines and that sort of thing. By the end of this tutorial, you'll have a much deeper understanding of how to develop games in Unity. We're also going to develop a basic UI for keeping track of the score, the number of lives left, handling player settings, saving high scores, letting you remap controls, because let's face it, not everyone likes my default key bindings. We'll even cover saving and loading those settings along with audio preferences. And it doesn't stop there. We're going to build a WebGL version of this game, and we're going to publish it to itch.io so you can share it with your friends. And if you want to play this on another device, like an Apple or an Android, say your iPhone or iPad, we're going to make mobile controls for it too. So some of the patterns I'm going to show you might seem like overkill for a small project, but trust me, they're going to pay off big time when you start working on larger, more complex games. So whether you're here just to learn how to make Asteroids or to learn principles that will make your future games even better, this is the place to start. So if that sounds like fun, grab your favorite beverage, pull up a chair, and let's fire up Unity and get to work. Now, the first thing you need to do if you want to make games in Unity is create an account with Unity, and it's free to do so. And you need to install the Unity Hub, which will allow you to install the Unity game engine on your computer. So first of all, if you go up to unity.com/download, you can go up here, and on the upper right, if you click this little icon here, you can say create a Unity ID. Now, I've already done that, so I just need to click sign in. And now I am signed into the Unity Hub. Now, on this same page, if you look down here, there's download the Unity Hub. And I'm on Windows, so I'm going to click the download for Windows link. And it is downloading the Unity Hub setup. Now, if you are new to Unity, this is definitely valuable material, and I recommend you follow these steps all the way through. We're going to download the hub, we're going to install it, we're going to install the Unity game engine version we're going to use for this project, and we're going to import all of the assets that we're going to be using in this game. Now, if you're experienced with Unity and you already know how to create a project and import your assets, you can skip this step and just go to my GitLab repository. I'll put a link in the description. And you can clone the quick start branch from that repository. And that will give you the project that's already created. We've already imported all of our assets, and we're ready to go start creating our project folder structure, which is going to be at the next timestamp in this video. So this has finished downloading, so I'm going to click Open File and agree to the terms of service, tell it where I want it to install, and have it go ahead and run it now that I've installed it. Now, because I had already installed it previously, it remembered all of the projects and stuff that I had already created. Yours is going to be blank here. And you're also going to have to install, go down to the Installs tab, and you're going to want to install an editor. So I have currently several Unity versions installed. I have the Unity 6 preview here. I've got Unity 2023.23 F1. I have a couple of Unity 2022 LTS versions. And actually, there is a newer Unity 2022. So we're going to go ahead and go through this process. I'm going to click Install Editor, and we're going to pick Unity 2022.3.47F1 LTS and click Install. And we're going to pick, we want Android build support, we want iOS build support, WebGL, and Windows. So I'm just going to leave all of those checked and click Continue. Yes, I've read and agreed to the above terms and conditions. I haven't really read them, but I'm going to go ahead and click that and click Install. And this is going to take a while, so I'm going to go ahead and pause the video, and then we'll resume it after this gets done. Okay, our installation has completed. So the next step is to actually create our Unity project. So I'm going to come up here and I'm going to click New Project. And there's going to be a number of templates that we can choose from. I'm going to choose Universal 2D Core because we're going to be using the Universal Render Pipeline, and it is a 2D project. And all this template controls is what Unity modules will automatically be added to this project when we create it. You can always add or remove modules afterwards, but this will go ahead and get us started with the modules that we know we want for this project. Now you can give your project a name. I'm just going to call mine Asteroids. And you can browse to what location you want to install it on. I'm going to put it on my SSD drive here. And then your Unity organization, which you should have created when you created your Unity ID. And you can uncheck this Connect to Unity Cloud because we're not going to be using any of the cloud services. And if you want to use Unity's version control, you can check this. I am going to be using Git and GitLab for my version control, so I'm going to leave that unchecked. When you're ready, go ahead and click Create Project. Okay, after your project is completed, you should see this view here. And I'll just give you a quick tour of what you're going to see here if you're not familiar with Unity. This over here is your scene hierarchy for the currently open scene. So we're currently in the sample scene. If you go into the scenes folder here, you can see there's this sample scene. I'm going to take this slider and just make it so we have a list view instead of the big icon view like that. This view down here is our project hierarchy. So currently we have an assets folder with a scenes subfolder and a scenes subfolder, and then there is a packages folder. And these are all those Unity packages that were included based on the template that we selected. This here is our game view. This is what we would actually see if we were to play the game. And I'm going to go ahead and change this here where it says free aspect to be full HD. This is our scene view. So if we were to add some elements to our scene, like say I wanted to add a circle sprite, okay, that would show up here in our scene view, and then we can use these controls here to move it around or scale it like so, right? So I'm going to go ahead and delete that. You can see that it's given us a camera and a light. And anything that we select over here, you can see that it is giving us details in the inspector. So this is our inspector view. Down here, if we select one of these, this gives us the contents of whatever folder we have selected here. So if we wanted to add a new scene, we could go into the scenes folder and we could right click and we could say create scene. And if we want to create anything inside a folder, that's basically how we would do it. And finally, this is our console view. This is where it's going to log any warnings or errors or just console messages so we can debug. And there's lots of other windows that we could open up in here, like if we wanted to have an audio tab for our audio mixer. We can always dock different tabs to these different views, and we'll get into that later on when we actually start writing our game. But the very first thing we want to do here is we want to import the assets that we need for our game. So I've created this little README file that has a list of the resources that we're going to be using for our game. First, I want to start with by importing the Unity registry input system package. So if we go back into Unity and we do window package manager, you can see that we have a drop down here. These are the packages that are in our project. We can look at the Unity registry, which is where we're going to pull in that Unity input system. And then there are also my assets. So these are assets that I have purchased from the Unity asset store. And I have bought or gotten free tons of assets from the Unity asset store. So we want to select Unity registry here. And then up here in this little search box, I'm going to type input. And we're going to select input system. And we want to install it. And when it gets done installing, it's going to have us reboot or restart Unity so that that change can take effect, because we're telling it we want to use the new Unity input system. And so here it is. The project is using the new input system package, but the native platform backends for the new system have not been enabled in player settings. So if we want to go ahead and enable that, we just click yes, and it will do that and then restart the editor. And I'll go ahead and save my sample scene, even though I really didn't change anything. And there it has restarted. The next thing we want to do is we want to install the packages that we need from the Unity Asset Store. Now, these are links that I put into this README file, but I'm also going to put these links in the video description. So if you want to get these assets and you don't already own them, and by the way, these are all free assets. I'm not making you pay for anything. So if we click this link, it's going to take us to the Unity Asset Store. And I'm already logged in, and I've already added this asset to my asset. So it just tells me open in Unity. But if you were not logged in, or if you were logged in and you didn't already own that asset, okay, so yeah, if you are not logged in, or if you're logged in and you don't already own this asset, you're going to see this add to my assets. Now I'm going to go ahead and log in. And so if you did not already own it, you're definitely going to want to click that add to my assets. And you're going to want to do that for every asset in this list. So these are all assets that we're going to be pulling in from the Unity Asset Store for this project. After you have added all of them to your assets, you want to go back into Unity and open up the package manager again. But this time we're going to select my assets. Now I'm going to take this window here, I'm going to move it to my other monitor so I can just go through these things one at a time. So in your little search box, you're going to type in 2D Space Kit. Make sure that's selected, and then you're going to click download if you haven't already downloaded it. And then after the download is completed, you're going to click import. And this will pop up a dialog that will let you select which assets in this pack you want to import. And we're just going to go ahead and select everything in this package. So I'm going to go ahead and click import. So you're going to want to do that for every asset in that list that I showed you. This is basically telling me that this some of the project source files in this asset pack refer to APIs that have changed. And it wants to know if I want to update these. So I'm going to go ahead and say, yeah, go ahead and do this. And let it go ahead and make that change. So Unity is smart enough to know that the code in these packs are referencing APIs that have changed in this version of Unity, and it wants to make sure that it fixes those differences. So I am going to fast forward through importing all of the other packages that we're going to need. So we're going to go ahead and turn off the mic here and just go ahead and fast forward through all of those. It's telling me that this asset package has a Unity Package Manager dependency. I can just skip that. I don't need to upgrade. Say import. Now, DoTween is a tweening library we're going to use, and there is a pro version, which I own, but we are going to be using the free version here. It looks like there's an update available, so I'll go ahead and do that, and then import it. And after this is imported, it's going to pop up a dialog, and it's going to want us to set up DoTween for this project. So we're going to go ahead and do that step here. And there's that dialog. So we want to say open the DoTween utility panel, and we can always get to that thing from this tools menu up here. And we're going to say set up DoTween. And DoTween is going to give you the option of what components you want to be able to do tweening for. So tweening is like animations. And so we can animate audio, physics, sprites, and UI elements. And I'm just going to go ahead and let it install for everything. We're really only using it to animate UI elements. Specifically, we're going to be using it to fade things in and out. But we're going to go ahead and let it enable it for all of this. I'm going to click apply. And I'm going to have it create an assembly definition file. And the reason is I'm going to create an assembly definition file for our scripts so that when we make code changes in our scripts, it doesn't recompile all the other scripts for the assets that we pulled into the game. So I want to keep our stuff in a separate assembly. But because I'm doing that, I have to have an assembly definition for DoTween as well. So I'm going to click OK here. And there we go. So we have imported all of the Unity Asset Store assets that we are going to be using in this game. After we've imported all of the Unity Asset Store packages, we still need to import some assets that aren't part of the Unity Asset Store. So in my README file here, I have this section that says Other Assets. And if we open up all these links here in our browser, you'll see we've got this particle pack by Kenny. We have a sound effects pack with a bunch of sounds from Asteroids. And I will say that I do not know what the licensing status of these sounds are. I don't know where these people got these sounds. So I definitely would not distribute a commercial game with these sounds in them. Same with this arcade font that I'm getting from 1001freefonts.com. It says free for personal use. Now I have reached out to the author to ask if I can buy a license for this, or if he can give me some documentation granting me permission to use this. But in the meantime, keep in mind this is free for personal use. This video game power-up sound I got from upbeat.io, and they do have some assets that you can use for free. I'm using this one, and I'm using that for when I get an extra life. And then this jetpack sound that I'm going to play in a loop whenever you're holding down the thrust key, that I'm getting from freesound.org. So you can download all of these assets from these various sites. Now, some of these things, like these sounds for Asteroids, they're going to be zip files. And there is an idiosyncrasy with Unity where you cannot drag from a zip file directly into Unity. But what you could do, like say we create a folder for sounds and we wanted to copy something into that folder, if you were to right click and say show in Explorer, so we could open that up in Explorer and we could go into whatever folder and we could drag from a zip file directly into this folder here in Explorer. So that's not an issue there. So before we actually import these assets into our game, we're going to want to create a folder structure for our game. Now, one thing I don't like is that when we imported these assets from the Unity Asset Store, it put them all under our assets folder, and it's really cluttering up my hierarchy. So if that bothers you, you could create a subfolder, maybe call it asset packs, and you could drag all of those things into that folder. One possible gotcha, though, is if this author was to push any updates and you went and re-imported those updates, it would put them back up at this root level, and then you would have to copy them back down under your asset packs folder. And another thing to keep in mind is if you create any prefabs from any of these assets, all of these assets, when they are imported, if we were to look at this in the inspector, Unity creates a meta file for each one. And that meta file basically assigns a unique identifier to this. And if you create a prefab, it's going to be using this unique identifier. And so if you were to re-import this asset, it would give it a new meta file. And then if you copied that meta file along with the asset into this folder, your prefab would break. So you can get around that by importing these just the asset itself without the meta file into this folder and then deleting it from your root level. But that's a lot of headache. Only go through that trouble if it really bothers you having all this clutter at your root level. Now, one thing I like to do under assets is create a folder and put an underscore in front. And you can call this project, you could call it Asteroids, you can call it whatever you want. I'm just going to call it project. And these are going to be anything that's specific to my project. These are scripts that I create. This is anything that I actually create that's specific to my project. And what I like about it is it puts it up near the top of the hierarchy here. Now, unfortunately, 2 comes before underscore, so this 2D Space Kit is going to show up ahead of project, but it is what it is. So if we go in here, we're going to build out our project structure. So the first thing I want to do for our folder structure is I want to drag our scenes folder underneath of our project folder, which makes sense because that is internal. These scenes are internal to our game. It wouldn't make sense for them to be outside of it. The other thing we're going to do is start creating several subfolders. So in here, underneath project, I'm going to right click and say create folder, and I'm going to type animation. So I have an animations folder. I am going to create a fonts folder, and I'm going to create an input folder. So just to explain a little bit of what I'm doing, there are many ways you can organize your project. For a game the size of Asteroids, it really makes sense to organize your folders according to type. So I'm going to put animation files in here, font files in here, things related to the input system in here, and you'll get the point as we keep going. Now, the next folder I'm creating is music, and I'm going to create some subfolders underneath of that. So I'm going to double click to go in there, and I'm going to create a folder called music clip groups, and I'm going to create another folder called music mixes. And going back up in the project, we're going to create a prefabs folder. And I'm going to double click to go in there, and I'm going to create subfolders for Asteroids. And a subfolder for UI. So if you're not familiar with prefabs, prefabs are prefabricated components that we can just instantiate into our game. And then UI stands for user interface. So anything that's in the UI folder are going to be prefabs that are related to the user interface. We've already got our scenes folder. So now let's create a scripts folder. And this folder is going to have several subfolders. So I'm going to right click in here, and I'm going to create a subfolder for audio scripts, effects, an event bus folder, which is going to hold our event bus code and our event classes that we create. a folder for input scripts, manager scripts, scripts related to the player, spawners, which are scripts that are going to spawn objects into our game, like asteroids, bullets, things of that nature. We're going to create a UI folder for UI scripts and a utilities folder for just general utility scripts. Finally, I want to create a settings folder up here under projects. So settings, spell it correctly, and sounds to put our audio files. All right, so one thing I want to do immediately is go into our scripts folder, and I'm going to create an assembly definition file. Let me just go ahead and say I want to save our project. I'm going to right click in this scripts folder, and I'm going to create an assembly definition. Now, the reason I'm doing this is because Unity will, whenever you make a code change in one of your scripts, it will recompile all the scripts in the assembly. And by default, Unity is lumping all of the scripts from all of these asset packs and everything together into one assembly. What I want to do is group our scripts into its own assembly. So when I change a script, it's only going to recompile our scripts, not all these other scripts. So I'm just going to call this Asteroids. And if we look at this in the inspector, you'll see that we can add assembly definition references. So let's let that go ahead and think for a second. All right. So what we're going to want to do is we're going to want to create references for assemblies that we know we're going to want to pull in. So because we added an assembly definition file, if we don't pull in these other assembly definition references, we're going to get errors in our script. So I'm just going to click this and I'm going to select Text Mesh Pro. So we want Unity Text Mesh Pro. We're also going to want to use the Unity input system. So I'm going to type input, and then we want Unity input system. And finally, the doTween module. So you remember when I installed doTween, I had it generate an assembly definition file, so we can pull that in here. And if I don't know why it keeps doing that. I'm going to scroll down and click apply. And I think it's doing that because it thinks I'm in this untitled scene, and it thinks when I hit Control S to save that I want to save that scene. So let me just open up this scene here. And while I'm in here, I'm going to rename this Game. So we are going to have 3 scenes in our game. We're going to have Game. We are also going to have Menu, which is the start menu. And we're going to have a settings scene, which we're going to load additively whenever we want to pop up our settings dialog and let the user configure settings. Now what we can do too is we can go up here into File, Build Settings. And right now you see there's only the game scene. So I'm just going to select both of these guys and drag them in there. And we're going to make this one, we're going to move it to the top. So that will be our default scene. So when the game starts, if we hit play, it will open that scene first. And I'm going to go ahead and save my project. So we want to start copying in some of those assets that we downloaded. You remember we downloaded a font called Arcade Font. I'm going to copy that Arcade font from where I downloaded it to into this folder here. So this is what's called a true type font. It's a TTF file. It doesn't actually, it's not something we can actually just use directly in our game. We need to create a Text Mesh Pro font from it. Now, one thing I want to do is just temporarily here, I'm going to create under UI a Text Mesh Pro object, and you'll see it pops up this little dialog here so we can import the Text Mesh Pro Essentials and any Text Mesh Pro examples and extras. I'm just going to go ahead and import them. We probably won't end up using most of that, but I just want them to be here in the project. And I'm going to go ahead and close that. And so you can see that this text element here has new text. And it's using the Liberation Sans font, which is one of the built-in fonts that we got when we installed those TMP Essentials and Extras. What we're going to do is in this fonts folder, we're going to select our arcade font. We're going to right-click, go up to Create, and we want to scroll down to Text Mesh Pro and select Font Asset. It has just created a Text Mesh Pro font asset from that TTF font. So if I was to go back into this text field here and hit this little target thing, I can select Arcade for our font. So now we've got an arcade font that we can use in our game. I'm going to go ahead and delete this element here because we don't need it right now. So let's pull in some other things that we know we're going to need in our game. In particular, there are a number of sounds that we downloaded that we're going to want to copy in. So as you recall, we downloaded a bunch of assets, and some of them were in zip files, some of them were just straight up MP3s or whatever. I have extracted them all into a folder, and I'm just going to drag them into here. So now we have all of these sounds that we can use in our game. All right, nice. Okay, so before we actually get to building out our game, I want to organize things a little bit. I want to take our game screen and dock it side by side with our scene view. And then I want to take our inspector and I want to dock it underneath of our scene hierarchy. And then I want to take our project tab here and I want to dock it to the right of this and then bring this tab up there along with it. So now these guys are down here. Actually, I want this to be docked there. So now I've got my game view, my scene view. I've got my scene hierarchy, my project hierarchy with my console next to it so I can switch back and forth. And I've got my inspector. So if I select something here, I got it right here in the inspector. I don't have to go all the way across the screen and find what I'm looking at. Now let's start organizing things a little bit more. I'm going to create an empty game object. Dash, dash, dash. I'm going to call this background. Dash, dash, dash. And I'm going to go ahead and drag all this junk in. Actually, that's not what I want to do. I want to create one called camera and light. I got ahead of myself. And I want to drag all these guys into there. And then I want to just collapse them. I'm going to move background down underneath of them. Now in background, we want to create a sprite image that we can use for our space background. So I'm going to right click here and I'm going to go to 2D object sprites square. All right. And if we go into our assets down here in our project hierarchy and go into this 2D space kit and look at backgrounds, you can see there's a number of images here. And I kind of like this one. If we were to zoom this in a little bit, you see what that looks like. But there's a bunch of different ones here. We could choose whichever one tickles your fancy, or if you want to pull in a different image, that's up to you. I'm going to take this one. And when I select this guy here, I'm just going to drag that right into there, and that becomes our image. Now if we zoom out, change this over here to full HD, this little white rectangle represents our game view, right? So even though that image is filling up all of this space here, this is what's actually visible in the game. And if I wanted to, I could come in and I could shrink this thing down so that we get more of that image in there. It doesn't really matter, but that's what we're going to do. I'm going to rename this to be space background. So now we've got a nice space background for our game. Oh, one adjustment I want to make to this space background is I want to come down here to the order and layer, and I want to make that -15 so that other elements can show up in front of it. Because that is the background. Another thing I want to do is come up to our camera here and I want to change this solid color to be black. All right, and now let's go ahead and drag in a sprite to use for our player ship. So here under 2D Space Kit, we got ships and stations. I like this Fighter 1, so I'm going to drag that in. You can see it shows up here in our game view. I am going to rename that to PlayerShip, and I want to make it 1.5 on the x-axis in scale and 1.25 on the y-axis, just to make it a little bit bigger. Okay, and we're going to want to add some components to that. For instance, I want to add a polygon collider. Polygon collider 2D. Okay, so if we were to double click this, you can see it put this polygon collider around it. Now, polygon colliders tend to be less performant than just like a box collider or a circle collider or capsule collider, that sort of thing. But we're not going to have that many elements in our game. We don't need to worry about this. And this will give us the most accurate collision matrix that we want. I'm also going to want to add a rigid body 2D. And we want to set some things on here. We want to constrain it so it doesn't rotate on the z-axis. Basically, I don't want collisions. We're going to control the rotation of the ship through our controls, and we don't want it getting knocked around, its rotation getting knocked around when it collides with things. We're going to also want to add some linear drag and angular drag. So if we're thrusting and then we stop thrusting, it should drift a little bit and gradually slow down. We don't probably need the angular drag, but I just want to make sure that we have some. And let's see, is there anything else I want to add here? I want to put it on a layer. So right now, it's on the default layer. So we drop this down, you can see that there's a few layers that Unity gives you by default. We're going to click Add Layer, and we're going to add a player layer. And while we're in here, let's go ahead and create all the other layers we know we're going to want. We're going to want an enemy layer. We're going to want a player bullet layer. We're going to want an enemy bullet layer. And we want to have an asteroid layer. And I want a layer for waypoints. So the enemy ships are going to navigate across the screen through a series of waypoints that we're going to assign them randomly. We want to have a spawn point layer for where things can spawn in off screen. And then I want to have a settings layer, which is going to be used for our settings UI. Okay, so moving back over here, I just want to look at this. Forgot to change it to the new layer. So there we go. So now this is on the player layer, and any new child components that I add to this will inherit that layer as well. Now, one thing I want to do before I actually get this ship moving around, every Asteroid tutorial I've ever seen, the way they handle the expanded universe. So expanded universe is the concept where if an object goes off one end of the screen, it just comes back in the other side. So if we go out this side, we come back in the left side. And this was actually first seen, the first time I ever saw it was in a game called Space War, which was a really cool multiplayer arcade game where you each controlled a spaceship and you would dogfight each other. And there was like a gravity well in the center of the map, and there were lots of different options. But it had the option of either using expanded universe, or you could just kind of like bounce off the walls. You'd hit the edge and bounce off. So every Asteroid tutorial I've ever seen, the way it works is as soon as the ship reaches the edge, it jumps completely to the other side. But that's not the way I want to do it. So what I want to have happen is when the ship gets to the edge, it should be able to partially peek over this side and then be peeking in on that side. And so the way we're going to do that is we're going to have ghosts that surround the ship. So a ghost is basically just going to be a duplicate of the ship, and there will be 8 of them. right? So we'll have one. So this one is, we look at our transform here, we're going to just switch it to negative on the Y, right? And so you can see it's peaking up that way and peaking down that way. So if I pick both of these and I move them, right, you can see how that works, right? It'll peak over one side and peak in the other. And there'll be 8 of them, like I said, and they'll be exactly a screen's width apart. And they will have a script on them that will, every frame, get the position of the parent, the player ship, and they will update their position based on their direction, whether they're in the upper right, middle right, lower right, and so forth. They will update their position to always be exactly one screen's width away on the appropriate axis. And they will also match the rotation of the parent. And initially you might think, oh, I could just make this a child of the parent. So then whenever the parent moves, it'll move with it. And you would think, oh yeah, that'll work great. Well, the only problem with that is then if we rotate the parent, the child rotates around it instead of actually just matching the rotation of the parent. So no, that won't do. So what we're going to do is we're going to create a script for this guy called Ghost. And because not only ships will behave this way, but asteroids will behave this way as well, it's going to be a generic component that I can plop on anything. I can plop it on an asteroid, I can plop it on a ship, and if there was ever any other components I wanted to add that would behave this way, I could plop it on them. And then anything that can be the parent of a ghost, I'm going to create a script called Ghost Parent. And we're going to have a spawner class called Ghost Spawner, which is going to actually have an object pool for our ghost prefabs that will spawn them so we can reuse them. So we're not creating garbage on the heap. So that's something we can talk about later, but it's a performance benefit. If you're continually creating and deleting objects on the heap, you're creating garbage. And the garbage collector will have to go periodically reclaim that and clean up that garbage, which can cause little performance hiccups, especially on low-end devices. So we use something called object pooling that basically keeps any unused objects around so we can reuse them instead of creating new ones. So we don't destroy them, we just disable them and add them back to a pool. And then when we want to create a new one, if there's any in the pool, we just grab that first instead of creating a new one. So let's go ahead and do a little bit of programming, and we're going to create a couple of scripts. So in our project folder, we want to go into scripts, and right here at the root level, we're going to right click, create C# script, and we're going to call this Ghost. And then we're going to also do create C# script, wait for Unity, and type Ghost Parent. Now I have my configuration set up to use JetBrains Rider. So when I double click on this, it's going to open it up in JetBrains Rider. You may be configured to use Visual Studio Code or Visual Studio. I will be using some features with JetBrains Rider that I really like. There are equivalents to all of these in Visual Studio and Visual Studio Code, but I don't always remember the keystrokes, the hotkeys off the top of my head. But anyway, if I double click this, it's going to open it up. It gives me a little dialog here, asking me if I want to trust and open it. I'm going to say, yeah, trust and open. And then it wants to know if I want to open it in a new window, and I do. That's because I have another editor window open off screen. And so here we go. It opens up our project, and we have a little explorer over here that I can just go ahead and collapse. This was the README file that I showed you earlier where I have all of our links to our assets. And then this is a new script we just created called Ghost. Now, one thing I'm going to do is I'm going to select everything and I'm going to paste in our Ghost script. So first of all, starting up at the top, I have an enumeration that's going to represent all of the positions the ghosts can occupy relative to the parent. So if the ghost is in the middle, if the parent is in the middle, there could be a ghost in the upper right, in the middle right, the lower right, the lower middle, lower left, middle left, and upper left. So basically surrounding the parent. All right, so then we also are going to get references to our collider and our renderer, and we're going to get our parents transform. We're going to actually get the ghost parent script off of our parent, and we have a little enumeration here, our ghost position enumeration is going to be our position, and we cache our own transform. And this is something I do out of habit. I've been told, and actually had a whole video about this, that there's really no benefit to caching the transform, but I still do it anyway. We're going to create an interface called iCollisionParent. So let me go ahead and bring that in. And so one thing you can do, and go to the bottom of your file, and we can just say public interface collision parent. I'm going to get rid of this. And I can put my cursor over here and hit Alt-Enter, and it might be Control-period in Visual Studio, and I can tell it to move this to its own file. And there we go. And it's asking me if I want to add it to source control. And I'm like, sure, let's do that. All right, now you'll notice it's referencing a class that doesn't exist. This is called Viewport Helper. Viewport Helper is a little helper class that I created to get the bounds of the viewport, you know, what the camera can see. And we're going to use this to determine if we're actually visible on the screen or not. I'll go ahead and we'll create that as well. But that's going to go in our utilities folder. So coming back up to here, if we go into utilities and we say create C# script, and I'm going to call this viewport helper, and make sure you name this correctly. Double click that. I'm going to Control A to select everything, and I'm going to paste in the code for my viewport helper. Now there's some other things. It wants to pull in references for things that it needs. So I hit Alt-Enter again. I think it might be Control-period in Visual Studio. And that pulled in all the things that it knew about, but it also wants this singleton mono behavior class. So that is a class that I created to implement the singleton pattern. So the singleton pattern basically ensures that you only have one instance of something at any given time. And so for something like this, we only ever want to have one viewport helper in our game, and we want to be able to access it from anywhere. And so we're going to create a singleton for it, and that way it will always exist, and we can always access it from anywhere, and there'll never be more than one. So we're going to go ahead and create this in the same folder, in our utilities folder. So I'm just going to paste in the code for the singleton mono behavior, and I'm going to move that into its own file and add it to source control. So let's look at this class real quick. So this is introducing a concept called generics. So this T can be any kind of type as long as it derives from mono behavior. So what this will do is we can have any kind of game object or something that inherits from mono behavior, and we can create a singleton version of it. And then we can access it through this instance property here. So we have a private instance variable, but we have a public property to access the instance. Now, the first time we try and get it, it's going to check and see if it's null. And if it is, then it's going to go and look for an object of that type using the find object of type, where T is whatever type it is. And then if it's still null, we're going to go ahead and instantiate a new one, right? And then we're going to call don't destroy unload on it. So even if we change scenes, this thing will hang around. Otherwise, we already have an instance. We're just going to return it. And then this code just checks to see if the application's running. So in onDestroy, if this is the instance that we've saved off and we're destroying it, then we want to say is application quitting equals true. So in the awake method, we're going to check to see if instance, we're going to actually assign instance to our local variable instance. And then if instance is not us, so if instance was null, we're going to save it as this. So we're the first instance. But if it's not null and it's not us, well, somehow a second instance of this class is being instantiated. Let's just destroy it. So we're only ever going to have one of these guys. Okay, so going back to our viewport helper, let's explain this code. I want to get the bottom left, top right coordinates for what the camera can see. And we're converting those from the camera's viewport to world points, to actually what they would be in the Unity world space. Okay, and then we're going to, so we have a width where we're going to take the top right and subtract the bottom left. I could have just as well subtracted the top left, but basically I'm subtracting the left from the right to get our screen width. And then I'm doing the same thing with the top and the bottom to get our height. And then this function is on screen. We're going to basically check the bounds of our viewport and compare it to whatever position we pass in. So I'm going to ask this, am I on the screen? I'm going to give it my position, and it's just going to see if we're within the left, right, top, and bottom bounds of the coordinate system. And this is a function I added, so if I want to randomly spawn something at a random location on the screen, like when the player hits hyperspace, we're going to make him disappear and reappear somewhere randomly. We're just getting a random range on the X and Y axis within our bounds of our viewport. So that little helper function is going to be used throughout our game. Now I will point out that the renderer class has an isVisible property on it. We'll basically do the same thing that we're doing here, but there's a gotcha with that. If you are actually debugging this or testing this in your editor, in the Unity editor, isVisible, the renderer isVisible property will return true if it's visible to any camera, including the scene view camera. So like say this player ship, let's say this ship was off the screen as far as the game view is concerned, but it's visible in the scene view, isVisible will return true, and that would mess with our logic. So I wrote my own little isOnScreen function to handle that so we don't run into that little gotcha. So going back to our code, we're going to go back to our ghost class. Let's go back to the top. So we have an init method. So this public init method is going to be called by the ghost spawner whenever we spawn a ghost. We're going to pass in the ghost parent, and we're going to pass in this ghost position. And you remember the positions are upper right, middle right, lower right, and so forth. So we're going to save off the ghost parent. We are going to try to get the collision off of that guy. And then we are going to save off the transform of our ghost parent. We're going to save off our position, so our upper right, lower right, middle right, or whatever. And then we also want to match the parent scale, just in case, for whatever reason, the parent object has a different scale than the prefab for the ghost had. I just want to make sure that we match that. And then I'm going to call a function called repositionGhost. So this is where the magic happens. By the way, in the awake method, this is where I'm grabbing our transform, our sprite renderer, and our polygon collider, just so we can use them as we need them later. When this thing is first enabled, we're going to enable various components on this ghost, and I'll explain that later. Because like when the ship first spawns, we want the ship to be invulnerable for a few seconds. And not only does the ship need to be invulnerable, but its ghosts need to be invulnerable. So any asteroid ghosts that are out there, if they happen to hit the ghost, we don't want that collision to count and kill the player if he's supposed to be invulnerable. So we'll disable his collider and things like that. That's what enable components and disable components is doing. But the reposition ghost, which we call when we first are initialized, and we also call it every frame from update, that's where all of the magic happens. And I'm passing on any collisions that our ghost gets to the parent. That's the main reason we need the parent, is so we can tell the parent, hey, something collided with us, therefore it technically collided with you, so you need to handle that collision. All right, so enable components turns on our collider and our renderer. Disable components turns them off. Reposition ghost. This is where we're going to do our magic. First of all, if we don't have a parent transform, just return. We don't want to try and reference something that doesn't exist. Otherwise, we're going to set our position and rotation to be our parent's position plus our offset, which is going to be based on our direction, like upper right, lower right, middle right, and the screen width. And we're also going to match our parent's rotation here. So ghost offset, we're basically doing a switch on the position. So again, middle right, middle left, or whatever. So this is a really cool syntax here where I'm basically saying if our ghost position is middle right, or it's lower right, or it's upper right, then we just want to take the viewport helper screen width. So that's going to be our offset. So if we're on the right side, our X offset is just going to be the screen width. And then if we're middle left, lower left, upper left, this is going to be the negative screen width. So that's the little negative sign here. Otherwise, we're just going to take our default that we assign here to be 0, which this should never happen, but I always like to have a default when I do a switch. Same thing for Y, on the Y offset. If we're in the upper, we're going to use the screen height. If we're on the lower, we're going to use the negative screen height. And we're going to return a vector 3 with those values. X offset, Y offset, and 0 on the Z-axis because this is a 2D game and we're not moving on the Z-axis at all. So that is our ghost class. So the next thing we want to do is code our ghost parent. All right, so let's jump back into Unity. And we want to go up into our scripts folder. So we've got our ghost script here. We want to select the PlayerShip ghost and drag the ghost script onto it. All right, so now this script has a ghost script. And it can behave as a ghost to the PlayerShip. And while we're in here, let's go into our prefabs folder. And we are going to drag PlayerShip ghost into there and create a prefab from it. So when we actually build out our ghost spawner, it can use this prefab to create a ghost. Now, if I was to come in here and make some changes to this guy, like say I wanted him to spawn somewhere off the screen, and I want him to initially spawn with his renderer and collider disabled, and I make those changes, I can come up here to overrides and I can apply those. And so now if I was to drag in a new one of these and look at him, he would inherit those values. So now I can go ahead and delete this from our scene hierarchy because we've got a prefab that we can use to create new ones. Now our PlayerShip is actually going to use the ghost parent script. So we go up to our scripts folder, I can drag the ghost parent onto there. And I want to show you a couple of different ways you can open scripts. I can double click this to open it up in the editor, or I can jump over into my editor and I can either go into our Explorer here and I could navigate down into project, scripts, expand that, and I could double click this to open it. Or let me go ahead and collapse that. I could, within the editor here, I could hit Control, comma, and just start typing ghost. And then I could double click this to open it up in there. Now I'm going to, once again, Control A to select everything. And then I'm going to paste in a whole bunch of code for our ghost parent. So let's start walking through this code. This is going to take that ghost prefab that we had. So what we're going to do is, this is a serialized field. Now a serialized field is an attribute that you can apply to a property or to a variable, a member of a class, that tells it that this should be exposed to the inspector, to the Unity inspector. That means I can go into the inspector and I can access this field through the inspector. So I'll be able to drag that prefab onto this field in the inspector. And in this swap delay variable here, it's a float, I can actually adjust this value in the inspector as well. I added a public property here. This is what is called an expression body method. This little syntax here, that's going to return the value of this, and it's public. So this is private. It can't be accessed outside the class, but I'm passing access to this guy through this public property here, ghost prefab. there's a public method called enable ghost. It's going to iterate through a collection of ghosts, which I create down here, and it's going to set them to be either enabled or unenabled. So it's going to set the active flag to be either true or false based on what I pass into this value here. So some private variables I've got, I have a list of ghosts, which I instantiate as an empty list. I have a reference to the main camera. I cache our transform. I cache our renderer. I cache our collider. And there's a class we have not created yet. There's a timer. So I'm going to introduce the concept of using timers to handle any kind of delay that we want to have. Now, I explained how the ghosts are going to work, where the ghosts are positioned around the parent. There's 8 of them. There's one in the upper right, middle right, lower right, etc. And as the parent moves, the ghost will update its position to stay exactly one screen width or height away from the parent and match the parent's rotation. But what happens if the parent moves completely off the screen? Well, now the ghost that is on the screen needs to become the parent. And all the other objects, including the original parent, need to orient themselves around that one. Actually, I mean, it's just the positions that I'm switching. But what we're going to do is we're going to make it so that we can continuously, like say I just kept flying straight. You know, I fly up past the top of the screen. I want to swap the parent's position with the ghost position, and all the other ghosts will then orient themselves around that new parent position. And I can keep doing that indefinitely. And so it's just, I need to handle that swapping, but I wanted to have a delay, because what if you like just approach the edge and I swap, but then it says, oh, you're off the screen again. I'm going to swap back. And it will swap back and forth and back and forth. You can get caught into some thrashing there. So if I add a little bit of a delay, that won't happen. So that's what that is. But in the old days, I might have started a coroutine. A coroutine is like a function that gets called every frame, and you can do a yield return until some delay is met. Another option is I could just have a float variable like next time, like next swap time. And then in update, I can increment that time and see if time.time is greater than that delay or whatever. But another way to do this, the way we're going to do it in this tutorial, is we're going to use a timer class. So I'm going to create a timer, and I'm going to start the timer, and it's going to actually call back to essentially a delegate when that timer has elapsed, when that countdown is completed. And I'm going to use that to set these booleans, like can I swap on the x-axis? Can I swap on the y-axis? And we'll walk through all that code. So when this ghost parent is enabled, I'm going to create all the ghosts. So we're going to create one for every ghost position, upper right, middle right, lower right, etc. I'm going to set the can swap x and y to true. I'm going to create my timers, and I'm going to enable all the components. And so let's walk through what all these look like. So create ghosts. I'm going to iterate through all of our ghost positions. And remember, that's that enumeration, upper right, middle right, lower right. And for each one of those, I'm going to instantiate a ghost. All right. And I'm going to pass it this as our parent. And I'm going to pass it our position from this ghost position that we're getting from this collection here. So there's a collection of values in that enumeration that we're enumerating through. And I'm going to pass in upper right, middle right, lower right, whatever. Now this class doesn't exist yet. We're going to have to create that. And then I'm going to add the ghost that we just created to our collection of ghosts. Now release ghost, I'm just going to iterate through all the ghosts in our collection, and I'm going to tell the ghost spawner to release that ghost. All right. And then I'm going to clear our collection when I'm all done. So we're going to be using object pooling, and we're going to release that ghost back into an object pool so we can reuse it later. Create timers. I'm going to create a new timer manager, and I'm going to create a countdown timer. So I'm really excited about this. This was my own invention. I will say that the actual timer class itself, I borrowed heavily from another YouTuber called GetAmend. He's got a fantastic channel where he goes into more intermediate to advanced topics around design patterns, coding standards, and things of that nature. And he has a timer implementation that I thought I could leverage in this tutorial. But this timer manager, this generic manager that I will show you that pools timers, is my own invention. And I'm going to subscribe to the onTimerStop method on both the X and Y timers. So I have an X timer, a Y timer, and I'm going to subscribe to their onTimerStop. And they're each going to call, when they finish their countdown, they're going to call this function, swap X timer stop on swap Y timer stop. Release timers is going to unsubscribe from those events, and I'm going to tell the timer manager, hey, release these timers. So what do I do when I get my on swap X timer stop event? I just set the kin swap X to true or the kin swap Y to true. Enable components is going to enable our renderer and our collider. So when I first spawn the ghosts, I want these to be disabled because I don't want to have a collision that happens off screen, or maybe the last position of the ghost happened to be on screen. And so if I spawn it and it's enabled, it might trigger a collision that I don't want. But I want to turn them on at some time. So I have this enable components and I have disable components here. Handle screen wrap is where I check to see if we are on the screen. So this is the ghost parent. If the ghost parent is on the screen, then we're just going to return. We don't need to do anything. But if we moved off the screen, if we're no longer visible, we want to swap with the ghost. And then swap with ghost is going to basically determine which ghost we need to swap with based on where we are on the screen, right? And it's going to find the appropriate ghost to swap with. And then all we're going to do is set the new position to be the ghost position. And we're going to set this kin swap X to false, and we're going to start that swap X timer. So we're not going to be able to swap again on the X axis until that timer fires. Same thing on the Y axis. We're going to find the appropriate ghost by the ghost position, and the ghost position is determined by whether we're off the right side of the screen or the left side of the screen. And then if we get a ghost, we're going to set the new Y position to be that ghost Y position. We're going to set this kin swap Y to be false, and then we are going to start the Y timer. And then we're going to set our position to be the new position. So if we move off the screen, we're going to set our position to be whatever the appropriate ghost is. And then each ghost in their update method, they're going to reposition themselves around our new position. All right. I'm not even using these functions anymore. This is something I was doing when I was diagnosing an issue, so I can actually just delete these functions because they are never called. So before we jump back into Unity, we're going to want to add implementations for these other classes in order to fix these compilation errors. So we're going to want to create our timer class and our timer manager. And then we're also going to want to come back and work on our ghost spawner to actually spawn ghost and release ghost. So let's go ahead and start work on that now. So I'm going to jump back into Unity, and I'm going to go into our scripts utilities folder, and I'm going to create a C# script, and I'm going to call it timer. And I'll double click that to open it up in the editor. And once again, I'm going to paste in a bunch of code. So this is a abstract class of timer, and I'm going to derive a couple of other classes from it. And this is, again, borrowed extremely heavily from Git-amend. I got to give him full credit for this idea. This is not a mono behavior. Okay, these are just pure C# classes. So basically I have a time property that's a float. I have a Boolean that says whether or not the timer's running. I have a float that gives us our progress, which is the time divided by the initial time. And then there are a couple of delegates here, basically events, on timer start, on timer stop. In the constructor, we set is running to false. And then there's a public method to set the initial time. And it's just an expression body method that sets this initial time variable, which is a private, or actually it's protected because I need to access it in derived classes, but I don't want it to be public. And then there is a public start method. You can also pass in an optional initial time property here. And if that's not null, we will set that to the initial time. And then we will set the current time to be initial time. If we're already running, I just return. Otherwise, I set is running to true, and then I will invoke the on timer start event. And I just realized that I probably should make sure that that is not null. Although it's not actually necessary because we are instantiating it as an empty delegate here. All right. There's a public stop method. If we're not running, just return. If we are running, set it to false and invoke the on-timer stop event. There's also public methods to resume and pause. I'm currently not using them. And then there is a abstract method that's public called tick that needs to be implemented by the derived classes. And that takes delta time. So you can tell by the fact that it's taking a delta time parameter that is probably going to be called from the update method of some mono behavior. Now the first timer class, in fact the only timer class we're going to use in our game, is a countdown timer. So it has a constructor that just calls the base constructor. It doesn't do anything. I could delete this and it wouldn't care. There is the override for the tick method. Basically, if we're running and time is greater than 0, then we want to decrement time by delta time. So however much time has elapsed since the previous frame, we're going to decrement it from our current time. And then if we're running and time is less than or equal to 0, we want to call the stop method. There's also a Boolean called isFinished, and that's just going to return true if time is less than or equal to 0. There's the reset method that is overridden, and all we're doing is setting time equal to initial time. And there is reset, which will reset the time and call the reset method. There's a stopwatch timer, which we're not using, so we don't really need to talk about that. Now, there's another thing we need to create. If we go back to our ghost parent, even though we have now created a timer, which fixes this compilation error, we still need to create the ghost spawner and the timer manager. We're going to do the timer manager next. And there's another thing. I've got this safe get by index. This is an extension method that I created, and I just realized I want to use that here as well. So let me just copy this and paste it. So basically what I want to do is I don't want to try and dereference that array if there isn't something at that index. So I'm going to create an extension method called safe get by index. And what I'm going to do is I'm going to go back up to my timer class, which, as you remember, we put in the utilities folder. So I'm just going to come down here and I'm going to want to create a function, actually a class called helper functions. So I'm just going to paste that there. And then I'm going to move that to its own file and add it to source control. So this is just a static class of helper functions that I can call from anywhere in my code. The first one we're not going to use in this project, but I use it often if I'm doing coroutines and I want to create a wait for seconds, like if I want to do yield new wait for seconds, 5 seconds. I don't want to be creating garbage on the heap. So I just have a dictionary here where I can cache my wait for seconds objects, caching them according to the amount of delay. And that's what this does, but we're not going to use that. But this, we are going to use this. It's a generic safe get by index where I basically have a list of type T. So T can be, again, any generic type. And all I'm checking to see is if the index is greater than or equal to 0 and less than the number of items in the list. And if it is, I'm going to return the item at that index. Otherwise, I'm going to return default, which is most likely going to be null. So in Ghost Parent now, I have satisfied that compilation. I fixed that. So we can now use this safe get by index to get the ghost at that position. If it's null, I'm just going to return. All right, so now we need to work on our timer manager. And this is actually going to go in the, not in the utilities folder, but it's going to go into the managers folder. So if we go back out into Unity and we go up to scripts, managers, I'm going to right click, create C# script, and I'm going to call it timer manager. And we're going to double click that. And I'm going to select everything and I'm going to paste in the code for my timer manager. All right, so we're pulling in the Unity Engine pool namespace, which is going to allow us to use Unity's built-in object pooling system that they introduced a couple versions ago. So I'm creating a dictionary that has a dictionary of type, so I can create different types of timers, and each of those entries in that dictionary is going to have an object pool of type timer. So this is our abstract base class, and then I'm just instantiating that to an empty dictionary. And then I also have a list of timers, which I'm instantiating to an empty list. So I have this generic method. So we're definitely making heavy use of generics in this project. So I'm taking a generic type, and this might be countdown timer, stopwatch timer, or whatever. It's always going to be countdown timer in this game. But you can use this class in any of your projects, and if you want to have different kinds of timers, you can add as many as you want, and you can use the same timer manager for all of them. So I'm going to say create timer. The first thing I want to do is get the timer pool for that type. So I want to get the countdown timer pool. And so let's go look at what that does. I basically get the type of T, and then I check to see if any of my pools, if my pools dictionary contains that type. And if it doesn't, I'm going to instantiate a new pool. And I also want to call activator.createInstance on that. So when you create a new object pool, the object pool constructor takes a number of optional parameters. Well, there's one mandatory parameter and then there's a bunch of optional parameters. So you see the first parameter that's mandatory is a create func. So whenever I create an object using this pool, it's going to call this function. And I'm just basically inlining this function here with this lambda expression. So create func is going to use activator.createInstance to create an object of type T, whatever this generic T is. In our case, a countdown timer. So we're going to create a countdown timer and cast it to timer, and we're going to return that whenever we create an object for this pool. And then I am just going to return the item from our pool. So I'm adding to our dictionary this pool's type. This is indexing into the dictionary and setting the entry at that position for that type to be a new object pool of type countdown timer with a create func that's going to call create instance of type whatever. And then we're going to return that pool, right? So we already had a pool of that type. We're just returning that pool. So there we go. We're creating a pool of type T. Then we are going to use the pool.get to get a timer from the pool. If there is no existing timer in the pool, it's going to call this create func and it's going to instantiate one. Otherwise, it's just going to get one from the pool. We're going to call the setInitialTime method on our timer, and we're going to add it to our list of timers, and we're going to return it. So that's how we create a timer. So this is where we get a timer from the pool. So again, if the pool doesn't contain an object of that type, then we're going to create one and return it. Otherwise, we're going to do it. Now, in update, so this is a mono behavior, and it's actually a singleton mono behavior. So there's only ever going to be one instance of the timer manager in our game at any given time. All right, so we're always going to have that static dictionary of timers that we can pull from. So no matter where we are in our game, we can get a timer using this pool, using this manager. So every frame, we're going to go through all of the timers in our list. And for each one, we're going to call their tick method so they can count down. All right. Now, when we release a timer from our pool, okay, we're basically going to get the pool and we're going to remove the timer from our list up there so that we don't continue to count down on them. And we're going to tell the pool, hey, release that timer back to the pool so we can reuse it later. So that's all there is to this timer manager. So going back into our ghost parent, the only thing left to get this working is our ghost spawner. Now I could jump back out into Unity and navigate over to the spawners folder and right click, create new script and all that. But I'm going to show you another way we can do this. We can just stay right here in our editor. So if you're in Writer or Visual Studio, you can go to your Explorer and then you can go from scripts, spawners, and you can right click and say add. In my case, I'm going to add class interface and I'm going to call it a class. I'm going to give it a name, Ghost Spawner. And we are going to add that to source control. Now I'm going to select everything and I'm going to paste in all my code. So it's just another way we can just stay in our editor. We don't have to jump back out into the Unity editor. So let's look at this. This is another singleton mono behavior of type Ghost Spawner. So there's only ever going to be one of these. And we can access it from anywhere through the instance property. We have a couple of serialized fields that we can set in the inspector. One is the initial pool size, which is 8, and the other is the max pool size, which is 8. And I could just as easily hard code these or make these constants because it's never going to change. But I thought, well, I'll just make it a serialized field. Why not? We're also going to be able to assign the parent transform. The reason I'm doing this is because when I spawn my ghost, I want to put them under a node in the hierarchy so they're not cluttering up my hierarchy. And I'll show you what I mean after we start actually using this. I want to have a dictionary of string to object pools. So depending on the type of ghost we're spawning, I want to use a very particular pool for it. So this ghost spawner is going to allow me to spawn pools for my ship. They're going to allow me to spawn ghosts for my ship, but they're also going to allow me to spawn ghosts for asteroids. And not just any asteroids, but small asteroids, medium asteroids, large asteroids. So I want to have different pools for different types of ghosts. All right, so now there is a prefab that is a private variable, which we're going to assign when we want to spawn a ghost. And I'll show you why I'm doing that later. And then I also wanted to have a vector 3 for what off screen is. So you saw me, I think in the inspector, when I edited the prefab, I actually changed the default transform position to be off screen. Well, when a ghost is added back to the pool, I think I want to move it off screen so the next time I use it, I don't instantiate it on screen. I just want it, because I had a weird thing when I was testing this where you would briefly see a ghost flash on the screen and then disappear. So that's all this is for. So we have a get pool method. This is a private method that is going to get the pool for whatever ghost prefab that we're trying to spawn. So I'm going to look at my ghost pools dictionary. I'm going to try and get value with the name of that prefab. And if I get it, I'm going to return that pool. All right. Otherwise, I'm going to say pool equals get pool. That doesn't take a parameter. And then I'm going to add that pool to our dictionary. All right. Now, let's go ahead and look at what that get pool does. So get pool is going to instantiate a new object pool. And I mentioned before that the constructor for the object pool takes one mandatory parameter and then a bunch of optional parameters. You can see there's create func. There's an on-get action, there's an on-release action, there's an on-destroy action. There is a Boolean for collection check. There is a default capacity, and there is a maximum size for the pool. So I'm actually specifying all of these parameters. So I have callbacks for the create func, which is initiate ghost. We have one for when we take a ghost from the pool, when we return a ghost to the pool, when we destroy a ghost outright. I set that collection check to be true. And then our initial pool size and max pool size, we're using our serialized field values there. So that's what get pool does. We create one and we return it. All right, so now spawn ghost. What does that do? Well, we're taking in our ghost parent and we're taking in the position for this ghost. And remember, this is an enumeration, upper right, middle right, lower right, and so forth. We are going to save off that prefab, and then we are going to call get pool. So why did I save off this prefab? Well, you remember get pool set up a create func, right? So when we instantiate the pool, we had this instantiate ghost. Well, this is where I have to actually instantiate the prefab. And so I need to know which prefab to instantiate. So I just assigned it to a private member variable. And then I also use the parent transform that we saved off. So that's why I'm doing that. All right, so let's go back to spawn ghost. So we're going to get a ghost from the pool, which is either going to get one that we've already created and released, or we're going to create a new one. And then we're going to call init on that ghost. And so you've already seen that function when we went through the ghost code. And then I'm going to return that ghost. Conversely, release ghost. We call it with a ghost. We are going to deactivate it. We're going to move it off screen, and then we're going to tell the pool, release this ghost back to the pool. So when we take a ghost from the pool, I want to make sure it's inactive initially, and I'm setting its transform position to be 0. When I return it to the pool, I set it to be inactive, and I set its position to be 0. I probably should be setting it off screen. And then when I destroy it, I just destroy it. So that is the ghost spawner in a nutshell. So let's jump back out into Unity. And we're going to want to create some things in our hierarchy here. Let me go ahead and collapse this and collapse that. And I'm going to right click and I'm going to say create empty. And put my 3 dashes and I'm going to say spawners. And I'm going to right click here and I'm going to create empty and I'm going to call it ghost spawner. And we're going to go into our scripts spawners folder and we're going to select that and drag the ghost spawner onto there. Now we also want to have a parent transform for where we want our ghost to spawn. So I'm going to create empty again and I'm going to call it ghosts. And then we're going to go to our ghost spawner and I'm just going to drag ghost into there. So now any ghost that this spawn will spawn under here, and then I can collapse it just like I can collapse this, and they're not going to be cluttering up my hierarchy. Let's go back and look at our PlayerShip, who's a ghost parent, and expand that. And we want to add in our ghost prefab here. So if we go back into our prefabs folder, we want to drag PlayerShip ghost into there. Now I'm going to go ahead and hit play and just see what happens here. I want to turn off gizmos though. Gravity is obviously on for my ship. And so you see that my ship was falling as soon as I hit play. So let's go into our rigid body 2D. And under gravity scale, we want that to be 0. I cannot believe that I missed that. We want to do the same thing for our ghost prefab. So in here, we want to say gravity scale 0. Let's go back out here again. And I'm just going to take our PlayerShip and I am going to put him at 0, 0, 0. So he's in the middle of the screen and hit play again. So take a look at this. There are 8 ghosts surrounding my PlayerShip. And if I was to move my PlayerShip, you see the ghosts are moving with them. And as I approach the edge, you see that? He's halfway up the front, halfway in the left. And if I was to rotate him, you can see that the ghost matched his rotation. So now if I move him over here and I come off this side, you can see he's peeking in that side. So there you go. I think the next thing I'm going to work on is handling player input and getting the PlayerShip moving around so we can fly around the screen. And then you can see how it works when the ship flies out of view and then swaps with one of the ghosts and having all the ghosts reorient around his position. So let's start working on our PlayerShip a little bit. We go into our project scripts player folder and I'm going to right click create C# script and I'm going to call it PlayerShip. I'll select our PlayerShip, Wait for Unity to do its thing. And let me just minimize all these things. And we're going to drag the PlayerShip script onto the PlayerShip. And we're going to double click that to open it up in the editor. And I'm just going to clean up this stuff a little bit. Now, when I first started working on my prototype for this, and I got it in a decent working shape, I put it in front of my friend Jason Story to get his opinion on it and ask him what he thought I could do better, what he thought he would do differently, especially since I was doing this for a tutorial. And he had some very strong opinions about how I implemented my PlayerShip. So originally, and what I usually do with a game of this scope, is I'll have something like the player class, PlayerShip class. I will have it handle input, respond to input. Like, you know, if a certain key is pressed, I'll thrust. If another key is pressed, I'll fire, that sort of thing. He felt pretty strongly that I should move that functionality out of this class and treat the PlayerShip as more of an actor that just follows directions. And those directions could come from anybody. In his case, he was recommending something like a brain, have a player brain, and there might in the future be an AI brain or some other kind of brain that would control the player. And then that brain could take input from whatever source, and then decide, based on that input, decide to tell the player to do something. And I really like that idea of making the PlayerShip basically an actor that responds to directions. Instead of having a brain, though, I'm going to have something called a PlayerDirector. It's going to direct the player, and it's also going to deal with some input, but it's not going to actually handle the input directly. Well, we'll get to that. Well, first of all, what I want to do is I want to expose some public methods in this class that our director can call. So I want to have a rotate that's going to take a rotate amount. And then I also want to have a set thrust. And that's going to be a bool that's going to determine whether or not we are thrusting. And then down the road, enter hyperspace. So these are going to be some public methods that our director can call. So I'm going to call this rotation input, I think, because I want to declare a variable in here, which is going to be the rotation input times our turn speed times time.delta time. And I'm going to go ahead and create a field for that. And I want that to be a float. Now, this is going to be a serialized field so that we can set it in the inspector. And I'm going to default our turn speed to, say, 200. I'm also going to declare one called thrust speed, and I'm going to default that to 120. But I can override those in the inspector. So in our rotate method, we're going to take that rotation amount. We're going to calculate it by taking the rotation input times our turn speed times time.delta time. And then we're going to apply that to our transform. And I'm actually going to do it that way, except this does not have an underscore. So that should handle rotating. Now thrusting, all we're going to do is set a thrusting variable. So I'm going to go ahead and create a field for that. And then for enter hyperspace, you remember the helper class we created? All we're going to do is set our transform position to be viewport helper.instance.getRandom visible position. So this will just randomly teleport the player somewhere on screen. All right, it might be in front of an asteroid or on top of an asteroid. We don't know. It's very dangerous to go into hyperspace. The original game would also, there's a random chance, even if you teleport it to empty space, there was a chance you would blow up on re-entry. I'm not going to do that. In the future, we're going to have methods to fire, bullet. We're not going to do that here. Now, how are we going to handle our thrusting? Well, we're going to use fixed update to handle thrusting. So there's a number of callbacks on mono behaviors that Unity calls. We're going to use fixed update. Now, if we hover over this, frame rate independent mono behavior, fixed update message for physics calculations. So Unity is going to call this, and this is the place where you want to handle anything that's going to manipulate your physics. So we're going to be manipulating our rigid body. So that means we need to actually get our rigid body. So another callback that we get from Unity is awake. Okay, so let's hover over this. It says awake is called when an enabled script instance is being loaded. So when this script is first being loaded, this is going to get called. And so what we're going to do in here is we're going to say that rigid body equals get component rigid body 2D. And we're going to create a field for that. All right. So this is going to get our rigid body. And then in fixed update, we're going to say handle thrust. Oh, we need a function called handle thrust. I'm going to come down here and make a private function, handle thrust. And what do we want to do in handle thrust? Well, basically we want to check and see, are we thrusting? So we're going to say if not thrusting, return. All right. Otherwise, we want to say thrust amount equals thrust speed times time.delta time. This makes it frame independent. Technically, we probably should do fixed delta time. All right, because we are dealing with fixed update and physics. The other thing we want to do is we want to calculate force from that. So we want to say force, and we're going to use transform up for the direction we want to apply that force. And then we're going to apply that force to our rigid body. So now we can rotate and we can thrust. So I think that is good enough for now for this class. The next thing we need to do is work on our PlayerDirector. So I'm going to go to the bottom of my file here, and I'm going to say public class PlayerDirector, if I can spell, and that will be a mono behavior. And then I am going to move this to its own file and add it to source control. All right, so now we want to have a serialized field for our PlayerShip. Okay, so we definitely want to be able to have access to our PlayerShip. Now there is something else we're going to need, and that is some input, which does not exist yet. We're going to get to that. Now, in our awake method, which I mentioned, this is one of the callbacks that Unity will call, and this gets called when a script first wakes up. We are going to, if we're on an iOS or an Android, we're going to add a player touch input. Otherwise, we're going to add a player keyboard input. So that's going to be a type of player input. But again, we will get to that. So the next thing we want to do is in the update method. If I can type again. There we go. So what I want to do in update is I want to say, well, first of all, yeah, if player input is null, GitHub Copilot kind of already figured out what I want to do. If player input's null, I'm just going to return. Otherwise, I want to handle rotation input and I want to handle thrust input. So what do we do in handle rotation input and handle thrust input? Well, we're going to get our rotation input from our player input. And then if it's not zero, or I'm sorry, if it is zero or approximately zero, we're just going to return. Otherwise, we're going to call the PlayerShip's rotate method with that input. And for thrust, we're just going to call set thrust on the player ship with the value of get thrust input from the player input. So this is the start of our PlayerDirector. We will be expanding this class to handle some other things. We're going to be turning the ship's invulnerability on and off. I guess we should handle hyperspace too, now that I think about it. Let's say handle hyperspace input. And you can pretty much guess what's going to happen here. Now this, I'm going to add a little to-do here. We're going to use a timer to toggle when we can enable hyperspace. Now, did our player ship enter hyperspace method, did I not make that public? It is, but I think I wanted it to be with a one-word hyperspace. I didn't want camel case in the name of that. There we go. That fixed that problem. All right. So handle hyperspace input. That looks good. So the only thing wrong with the PlayerDirector now is we don't have any input. So I'm going to go ahead and get rid of this and this. And let's start working on our input. So like we did before, we're going to expand our Explorer. We're going to go up into the input folder and we're going to right click and we're going to say add class interface. And we're going to call this player, get my hands on the right my fingers on the right keys, player input base. All right. And add that to source control. And that is going to be a mono behavior. All right. And I don't want it to be in a namespace. Rider automatically put it in a namespace for me, but I don't want it to be in a namespace. Then I'm going to come down here. I'm going to say public. Actually, I want this class to be abstract. So basically, the abstract class can't be instantiated. You have to instantiate a derived class. And the methods that are going to be on this class are get rotation input, get thrust input, get fire input, get hyperspace input, and check to see was there any input of any kind in this frame. All right, so these functions have no implementation. They're all abstract, so they will be implemented in our derived class. So we're going to create a derived class. We're going to call it player keyboard input, and that's going to implement player input base. And I'm going to move that into its own file and add to source control. And then I'm just going to paste in all this code. So let's take a look at what we got in here. So we have a public property called rotate left key. So what we're going to do is we're going to actually assign these keys in the inspector. And later on, we're going to add some settings, ability to allow the user to customize these settings at runtime and persist them. We're going to use something called player prefs to save the user settings. So they'll be able to remap the keys if they don't like our default key mapping. Now, the key mapping that I like to use for Asteroids, it closely mimics the buttons on the actual arcade cabinet. I use Z and X for rotate left and right, N for thrust, and M for fire, and then space for hyperspace. All right, so these properties here are the keys that we're going to look for to see, are we rotating left, are we rotating right, are we thrusting, firing, or hitting hyperspace. Some private variables here are going to be our rotation input, and this will be -1 to 1. Thrust input is true or false, fire input is true or false, hyperspace input is true or false. All right, now this Boolean here, any input this frame, I'm basically checking to see if our rotation is not 0 and, or these are all logical or. So if any of these conditions are true, this is going to be true. So if our rotation input's not 0, or if thrust input is true, fire input's true, or hyperspace input is true, if any of those things are true, then any input this frame will be true. And I'm going to use this. When I first spawn the player ship, he's going to be invulnerable for a few seconds unless he presses some input. So if he tries to move or shoot, boom, he loses his invulnerability immediately. He doesn't wait for the timer to complete to lose the invulnerability. Now, loading key bindings is going to come later because that is going to use our settings manager, which we have not written yet. So I'm going to add another to-do here, implement load key bindings. All right. Let's see, save key bindings, same thing. And we don't need any of this stuff yet. All right, so get rotation input. I checked to see, was the rotate left key pressed? If so, we want to set rotation input to -1. Was rotate right key press this frame? Yes, then set rotation input to 1. And then I checked to see if they were released, and if either one of them was released, I'm setting this input to be 0. And I return that rotation input value. So whenever like the player director says get rotation input, it's going to be -1, 1, or 0. Same thing here, get thrust input. If I press the thrust key, it's true. If I released it, it's false. And I'm setting this variable here so that will, if neither of these conditions is true, it's just going to have whatever value I assign to it, and I'm just returning that value. So this is a member variable here. Get fire input checks to see key was pressed this frame, fire key. And then get hyperspace input says key was pressed this frame, hyperspace. And then there's this generic key was pressed this frame, which I'm calling here and here, which I'm using the keyboard.current to get the keyboard input. If that's not null and that key was pressed, I look at it as was pressed this frame value. So this is something that the Unity input system gives you. We get the current keyboard, and then we index into that by whatever key, and then it has a property was pressed this frame. So this is how we can check to see if a particular key was pressed or released this frame. So there is our player keyboard input. So now let's go look and see what our player director is complaining about. Handle hyperspace input. So I'm guessing this is another case. Yep. All right. So now all of our compiler errors have been corrected. So let's go ahead and apply this script to a game object so that we can use it and assign and map our keys so we can test this out. Actually, one thing I need to do, I just realized, since we're not loading these from settings, I want to go ahead and assign these, giving them their default values. There. All right, so now we've got some default key bindings for our keyboard player input. Now we want to jump back out into Unity, and we're going to want to create a player director game object. So I'm going to say create empty, and we're going to call it player director, and we're going to drag our player director script onto that. And we want to drag our PlayerShip, actually make it a child of this. And then if we pick our player director, we can just drag this guy right into there. So let me just give this a quick test and see if it works. Okay, the only thing is I'm rotating in the wrong direction, but my thrust is working. And I'm going to hit space, and it teleported me. So let me just fix that rotation. Let's see if that doesn't fix it. There we go. So let's fly off the edge of the screen. And you see how the ghost swapped with the parent? Smooth as butter. Works vertically too. And hyperspace. Woohoo! Okay, so we have player input and movement working. The next thing I want to do is add some exhaust to the ship when it's thrusting. There's going to be a visual effect with a trail renderer and particles, but there's also going to be an audio clip that will play on a loop whenever you're thrusting. So we want to go down into the 2D space kit, and we want to look at their demo scene, their example scene. So we're going to double click demo here. And you can see it's got this nice elaborate scene here. And there's the same fighter that we're using in our game. And if we expand this foreground environment and select player, this is the object that we're going to be stealing from. So we can have basically an exhaust or an engine. So if we expand this player, and you see there's something here called engine, and you can see it's got a trail renderer, and that trail renderer has this smoke trail material. All right. So basically all we're going to do is we're going to come up here to this engine. We're going to right click and say copy. And then we're going to go back into our project scenes, into our game scene. And we want to pick our player, and we want to right click and say paste as child. So now we've got an engine child component that's going to have that same trail renderer with that same material that we had. Now I'm going to actually rename this to engine exhaust. All right. Now this is not positioned exactly where we want it for our ship. So if we look at our transform here, we're actually going to move this to negative 0.177, and everything else will stay the same. All right, so now if we were to hit play and thrust around, we should see that trail renderer. The only problem is we're showing it constantly whether we're thrusting or not. So what we're going to do is we're going to add some code that will enable and disable this component based on whether or not we're thrusting or not. So by default, we're going to say that this guy is not active. The other thing that we're going to want to do is we're going to want to add an audio source to this guy. So let's collapse all this stuff. And we're going to come in here and type audio source. All right. And then we're going to want to add an audio clip to it. So if we go down into our sounds folder, and there is this jetpack sound loop, we're going to drag that in to our audio clip. We want this to play on awake, and we want it to loop. All right. And we want to turn the volume of this guy way down. I'm going to say 0.1 actually. Now, we're going to want to create an audio mixer, and we want to route this audio source to our sound effects mix. So we want to come up here to Window and Audio Mixer, and you can see it created a new window here called Audio Mixer. So we've got a new tab, I should say. So we have our Project tab, our Console tab, and an Audio Mixer tab. So we want to create a new mix here, and I'm going to call this Main Mix. All right. And then under groups, we've got a master group. We want to create another group here. And we want to call this one Music. And then underneath of that, we're going to create a track A. And then we want to create a track B. And we'll explain this later when we get to our music manager. Basically, we want to be able to fade between two different tracks, have a nice little crossfade effect. Up here under master, we want to create sound effects. All right, so we're going to have a music group and a sound effects group. And we're going to want to create a couple of snapshots. So basically, we want to be able to switch between different snapshots depending on our, in order to do our crossfade between track A and track B. So I'm going to rename this to be snapshot A. And then I'm going to duplicate that. And I'm going to rename it to snapshot B. All right, and so snapshot A, track A is going to be all the way up, and track B is going to be all the way down. Snapshot B is going to be the opposite. So we're going to do a crossfade between those two snapshots. Now we're also going to want to expose some parameters. We're going to want to expose something called our master volume, and we're also going to expose our music volume and our sound effects volume so that we can access them via script. So we come in here and we look at this in the inspector, and I right click on volume. I can say expose volume of master to script. And if I drop this down, you can see this here, and I'm going to rename it master volume. I'm actually going to take the space out of that. All right. And then if we pick our sound effects here and right click on volume, expose that. And I'm going to come in here and I'm going to rename it to SFX volume. And then if we click on music and I right click, expose, edit, rename music volume. So now later on, when we want to actually control these levels via script, we have these parameters here we can use. And we're going to do that in our settings manager that we're going to set up later. We're going to allow the user to configure their mix, their audio mix. All right, but now we've got this sound effects group here. So if we come back to our engine exhaust and we look at our audio source, we can pick sound effects. So now whenever this thrust sound plays, it's going to play to our sound effects group. So let's test this. We're going to hit play. Right now, there's no audio playing because this guy is disabled. I'm going to come in here and enable. And there you can see the thrust visual effect and you can hear the engine exhaust. And you can see it's playing in the sound effects group, which is underneath of the master mix. The next thing we need to do is modify our PlayerShip script to actually turn that exhaust component on and off. So we're going to double click this to open up our PlayerShip script. And we're going to add another serialized field script here. And this will be a game object because it doesn't really care what it is. And GitHub Copilot already knew I wanted to add an exhaust component. Now, as you can imagine, we're probably going to want to turn this on and off in the handle thrust method. So let's jump down here. So right now, if we're not thrusting, all we're doing is just returning. We're not doing anything. What we actually want to do if we're not thrusting is make sure that that exhaust object is disabled. So we're going to set its active flag to false. Now, if we are thrusting, we want to set it to true. And then we'll go ahead and apply all of our force and stuff to the ship. So let's jump back out into Unity. And we're going to hit play. And let's fly around. And guess what? It's blowing up. Who can guess why it's blowing up? Unassigned reference exception. And by the way, when I say blowing up, that's sort of a programmer term for it's crashing with an error. So we were getting an error and I couldn't thrust. And the reason is we never assigned the exhaust field on our player ship. So if we look at our player ship and we come down here and look at the script, you can see there's this exhaust that is none. There's no game object assigned. What I need to do is drag my engine exhaust down to here. And now if I hit play, it should work. So right now there's no exhaust. I hit thrust. All right, so that looks pretty nice. That sounds pretty nice. I think the next thing we're going to want to do is get this guy shooting some projectiles. Okay, so if we want to add projectiles for our ship, we're going to need to bring in some assets that I actually forgot to import after I downloaded them. So I'm going to go over here to my project folder, and I'm just going to go into our assets. And then I had downloaded this Kenny particle pack, and I am just going to drag Kenny assets, that whole Kenny particle pack right here. And we're not going to use most of these. In fact, we're hardly going to use any. We're going to go in here though, and in this PNG transparent, we're going to use this Circle 5 sprite. But if I was to drag this into my scene, it's way too big for a projectile. So what I'm going to do is I'm going to change its pixels per unit to be 2000. I'm going to scroll down here and I'm going to apply. And so now if I was to select that and then just move it up here, you can see that that's more appropriate size for a projectile. And I'm going to go ahead and rename this to be Player Bullet, and we're going to add a rigid body 2D. Now we don't want this guy to have any linear drag or angular drag or gravity, and we want collision detection to be continuous, and I want to set it to interpolation for its updates during the frame updates. It will just make it smoother with less jitter, and the continuous collision detection will help prevent us skipping over a target if the bullet's moving really fast. We're also going to want to add a collider to this. In this case, we're going to use a circle collider 2D. And if we expand this collider here, you can see it's a lot bigger than the actual sprite. So what I'm going to do is I'm just going to shrink this down to match more accurately the shape of our bullet. I think that's pretty close to what we want. Let me just zoom in a little bit. Okay, I'm happy with that. All right, so now we've got a bullet that will start to serve as our bullet prefab. We're going to write a script for that, and then we're actually going to use inheritance. So we're going to have a base class, a bullet base, and then from that we're going to derive classes for things that are specific to the player or the enemy, because the same basic functionality of a bullet will apply to both, but there are some things that are specific. One thing I want to do on this is I want to put it on the player bullet layer. So I did mention earlier that, you know, we created all these layers. And then this child here also needs to go on the player layer, and all his children. But one thing we never did is we never actually set up our collision matrix. So it's very important that we actually set up our collision matrix. Otherwise, things are going to collide with things on layers that we don't want them to. So if we go into project settings, and here under physics 2D, we've got this collision matrix, layer collision matrix. What we want to do is disable everything. So right now, nothing is going to collide with anything else. And let's look at the player. So we know the player should collide with enemy bullets. We know the player should collide with asteroids, and they should collide with enemies. But we don't want them to collide with spawn points or waypoints or their own bullets or any of these other. We definitely don't want them to collide with themselves or UI. And some of these things just don't even apply. All right, now we also know the enemy should collide with asteroids and player bullets. the enemy should also collide with waypoints. So the way the enemy ship is going to work is there's going to be a number of waypoints that I'm going to arrange throughout the screen, and the enemy will come in at some random point, and then it will move to a series of random waypoints and then off the screen. So we want to make sure that they will be triggered by those waypoints. The only other thing we want is for the player bullet to also collide with asteroids. And really, I guess the enemy bullets should also collide with asteroids. So there, asteroids will collide with players, they'll collide with other enemies, they'll collide with the player bullet and the enemy bullet. I think those are all the types of collisions we care about in our game. All right, so we've got our player bullet class here. It's got a, well, not we don't have a class, we have a game object with a sprite, a rigid body, and a collider. So we're going to want to start writing some scripts for this. So if we go into our project folder and we go into scripts, we want to create here at the root of our scripts folder a C# script, and we're going to call it BulletBase. And I'm going to double click to open that up and select everything, and I'm going to paste in all our code. Now there's some stuff in here I'm going to comment out initially. When we want to get to where we actually score points, we're going to have the notion of a scorer. So basically what I will do is this guy will have a script on him called scorer, and he will have a function that will check to see if the thing that we hit is a scorable. And so that scorer script will check to see if the thing we hit is a scorable, and if it is, we're going to determine how many points we get for it, and then we're going to tell the game manager, hey, add that many points. But we're not to that point yet, so we are just going to comment all of that out. So let's start walking through this code. We are going to have an event here called onBulletDestroyed. And onBulletDestroyed, basically our PlayerWeapons class is going to subscribe to that. So we can know, hey, this bullet that we spawned has been destroyed. The enemy ship is also going to subscribe to that, because there are some things that they're going to want to do when a bullet is destroyed. Mainly, they're just going to deactivate it, and they're going to tell the bullet pool, hey, release this bullet. So that being said, we are going to have a couple of serialized fields here. One is going to be for an effect that we're going to play when we first fire the bullet. And then the other is going to be an effect that we play when the bullet hits something. And we have a couple of floats here. One is going to be the speed of the bullet, and the other is going to be how long this bullet will live. So if it doesn't hit anything, we still want to get rid of it. Some private variables here. We're going to cache our transform, our rigid body, and the camera. We have a Boolean to say whether or not we're swapping on the X and Y axis. Now, unlike the player, bullets will not have ghost. If they go out the top, they're just going to come right in the bottom. So we're going to swap them on the Y. They go out on the right, they're going to come in on the left, so we're going to swap them on the X. We're going to have a Boolean that says whether or not we are destroyed, and we want to have a timer that we're going to use to determine if it's time to get rid of this bullet. So in the awake method, we're going to cache our camera, our transform, and get the rigid body, and we are going to create the countdown timer that we need to determine when to destroy this bullet. And on enable, we set our destroyed flag to false. We add the force to get it moving. We subscribe to the on timer stop event so we know to destroy the bullet. And then we want to call start on that timer so that it can then call destroy bullet when it's time. In update, we basically check to see, hey, are we on the screen? If not, or if we are on the screen, then we want to make sure that swapping X and swapping Y are false and return. Otherwise, we want to handle our expanded universe swap. So let's take a look at that. If we are already swapping on both the X and Y axis, we just want to return. Otherwise, we want to get the viewport position for this bullet, and we want to get the new position, which is initially going to be our current position. And then depending on whether we're swapping X and we're off the right or left side, we're going to set our new position to be the opposite of whatever the X position is. So our position on X basically times -1. We're just going to make it a negative, which if it's already negative, we'll make it positive. So we're going to switch from this side to this side or vice versa. And we want to set that flag, swapping X, to be true. If we're not swapping Y and we're off the top or bottom, we're going to do the opposite. We're going to switch the Y position to be either negative or positive, depending on what it currently is. And then we're going to take that new position and assign it to our current position. So pretty much like we did with the ghost, when we swapped with the ghost, we're just doing the same thing there. If we get a collision, we want to handle that collision by calling destroy bullet. So in destroy bullet, one thing we want to do is unsubscribe from the timer on stop. I actually should probably go ahead and tell the timer to stop. Doesn't really matter since we're unsubscribing from the event. And then we also want to invoke that event that we declared up at the top, so hey, this bullet has been destroyed. We're setting this flag to true, so if for some reason this gets called twice, like maybe it collided with more than one thing, we only want to execute this logic once, so if we're already destroyed, we just return. So that's pretty much it for the BulletBase class. So let's go ahead and jump back into Unity. And on our player bullet, we're going to drag in that BulletBase script. And you can see it wants our muzzle flash and hit effect. So I'm going to lock this in the inspector here. And I'm going to, under 2D Space Kit, prefabs, I'm going to drag in muzzle flash and explosion. And actually, with some experimentation, I think that I want this to have a speed of 3 and a duration of 1.5. So I think that will work pretty good. Now I'm going to go up to our prefabs folder, and I am just going to drag player bullet right into there. So now I have a prefab that I can spawn whenever I want to have the ship fire a bullet. Now, I want to have the ship fire bullets from a muzzle position. So what I'm going to do is I'm going to, on my player ship, I'm going to right click, create empty. I'm going to call this muzzle. And I want to move this forward on the y-axis 0.26. So this is the point at which I'm going to spawn the projectiles. I think that would look pretty good. Now we're also going to want to have something that will control firing weapons. I don't want this to be part of the player ship. I want to have basically a weapon system. So what I'm going to do is I'm going to create another empty game object, and I'm going to call it PlayerWeapons. All right. And we're going to go ahead and open up, we're going to create a script for that. And that script is going to live underneath of the player folder under our scripts folder. So scripts, player, we're going to right click, create C# script, player weapons. And let's go ahead and double click that up to open it up in our source control editor. Select everything and paste in our code and go up to the top of the file. Now, we haven't got to our sound effects manager yet. This is going to be treated a little bit differently than the thrust sound, because the thrust sound is just something that plays when something wakes up and it plays on a loop. And so it just made sense to make that part of an audio source on the engine itself. One-off or one-shot sound effects are different. And we're going to actually use a sound manager to handle that. And there's some pretty cool things we're going to do there. And we're going to get to that later. So I'm going to comment that out. And I'm going to comment that out. All right. So that's all we need to comment out for this. So let's look at what we got here for our player weapons. We have serialized fields. We want our bullet prefab. We want the transform for our muzzle and for the bullet's parent. Now, why do I want this? It's because just like the ghost, I want to put them under a node in the hierarchy so it doesn't clutter up our whole hierarchy. So we can just collapse that so we don't see our hierarchy filled up with all these bullets. We don't need to worry about this yet. This is going to be the volume at which we play that sound effect. We want to have a pool for our bullets. So we are going to pool our bullets, and we want to cache off our rigid body. So this fire bullet method, so we're going to get a bullet from the pool, and this will, by the way, instantiate a new bullet if there aren't any in the pool, and we'll see that later on when we actually create the pool. And we're going to set the bullet's position and rotation to be our muzzle position and the ship's rotation. We are going to subscribe to its destroyed event, and we are going to set it to be active. And of course, when the bullet becomes active, it's on enable, it's going to fire, and it's going to go ahead and add force and start moving. All right, now we want to get the bullet's rigid body, and we want to add our velocity to the bullet. So if we're flying forward and we shoot, we want to add our velocity to it. So if you're actually moving backwards, like you can thrust backwards and then turn around and you'll keep drifting backwards and you shoot, I want your bullet to move a little bit slower. But if you're moving forward really fast, I want that to be added to the velocity of the bullet. Otherwise, it'll look really weird. It'll look like you're almost going to run into your own bullets and you're kind of keeping up with them. In the awake method, we create our object pool, and then there's going to be a spawn bullet method that will get called when we want to create a new bullet, and then there's some things we want to do when we get a bullet, release a bullet, destroy a bullet, and so forth. And our pool size initially is going to be 10 with a maximum of 20. We should never have more than 20 bullets in our pool because we can't shoot that fast. And then we want to set our rigid body to this variable here. So spawn bullet, we're going to instantiate a bullet using that prefab at our muzzle's position, matching our rotation, and we're going to set its parent to be that bullet's parent that we set in the serialized field at the top. When we get a bullet, we basically want to try and get its rigid body, and if we get it, we just want to zero out its velocity and angular velocity. So it should not be remembering how it was moving before it was destroyed, before it was added back to the pool. We want to start fresh. And then on release, we just want to make sure it's inactive when we add it back to the pool. We don't want to do anything special when it's destroyed. And this is our destroy method that gets called when the bullet is destroyed, and we are unsubscribing from our destroy bullet event that's on the bullet itself. We're deactivating the bullet and we're releasing it back to the pool. So that is it for player weapons. So let's go back out into Asteroids, into Unity. And on our player weapons, we want to drag in that player weapons script. And we want to drag in our muzzle. And we want to have a bullet parent here. So let's go ahead and at the root of our scene hierarchy, we want to create empty. And I like to put our 3 hyphens in front, and we're going to call this bullets. And I'm going to drag that up. I'm going to select their player weapons, and I want to drag that into there. And I'm going to just move this up above the PlayerDirector there, so it's just up there in the hierarchy. So now any new bullets that get spawned are going to get spawned under here. Before we can get our player weapons firing, we actually need to write some more code. So we're going to go into our PlayerDirector here, and we're going to double click the PlayerDirector script. Let me just minimize that. So currently our PlayerDirector is handling rotation, thrust, and hyperspace. And we also want to enable this hyperspace enable timer so you can't just repeatedly hit hyperspace as fast as you can. And we're going to do something similar with fire. So that means we need to have a couple of delay variables. So I want to have some floats here. One will be a fire delay, and I'm going to default that to 0.15 seconds. And we're going to want to create a couple of timers for that. So I'm going to call that enable fire timer, and enable hyperspace timer. And I want to have some booleans for is fire enabled and is hyperspace enabled. Okay, I think that's good for our variables. I want to add an onEnable function. So this is another callback. It says here that this function is called when the object becomes enabled and active. And so when this becomes enabled and active, we want to create our timers. And in create timers, we want to create 2 countdown timers, one for enable fire and one for enable hyperspace. So in our update method, actually, let me move create timers down below our update. So currently in update, we're handling rotation input, thrust input, and hyperspace input. I also want to handle fire input. All right, and I'm going to have it create that function for me. And I want to move that down below where we handle thrust input. So what do we want to do in handle fire input? Well, we want to make sure that we set, if fire enable is not enabled, we just want to return. If we didn't press the fire key, we just want to return. Otherwise, we want to disable fire, and we want to tell the player ship to fire their bullet. So first of all, let's come up here and create a void method called disable fire. And in disable fire, we want to, as you might imagine, set the fire enabled flag to false. We want to subscribe to the on timer stop for our enable fire timer, and we want to start the enable fire timer. So we want to have an enable fire method that sets the flag to true, unsubscribes from the on timer stop, and stops the timer. Okay, so now we need to tell our player ship to fire a bullet. But before we do that, let's handle our hyperspace input stuff here. So we want to add a couple functions to enable hyperspace and to disable hyperspace. So they're going to behave just like we did for enable fire and disable fire. And then let's get rid of this. Let's uncomment that. All right. And then if we enter hyperspace, we want to disable hyperspace. Okay, and when we first start, I want to go ahead and say enable fire and enable hyperspace. Okay, so now let's go ahead and implement this fire bullet. Create method, player ship, fire bullet. So what we're going to want to do in here is pass this on to our player weapons, which does not exist. So we're going to actually assign this in the inspector. So just like we did with the exhaust, we're going to add a serialized field. We're going to call it player weapons and call it player weapons. There. So now let's jump back out into Unity. And looks like there's no errors. So if we look at our player ship now, you can see it wants this player weapon. So I'm just going to drag that right there. And if we go look at player weapons, you see it's got all those fields there. Oh, we need our bullet prefab. All right, so let's go into project, prefabs, and drag player bullet into our bullet prefab field. Okay, and again, looking at our PlayerShip, that looks good. If you look at our PlayerDirector, now we got this fire delay here. I think all of that looks good. Let's just hit play and see if we can shoot some projectiles. Yep, I can fly around. I can shoot. The bullets go out one end and come in the other, just like the ship. All right, so we are able to fire projectiles. I think the next thing I want to do is start adding the ability to play sound effects. So like when we fire our projectile, I want to play a one-off or one-shot sound effect. This is going to be a little bit more advanced than what you might be used to in a beginner tutorial. We're going to create something called a bootstrapper, which is going to, when the game first loads, it's going to load up some persistent objects that's always going to be available no matter what scene we're in. And one of those things, one of the children of that thing is going to be a sound effects manager, which is what we're going to use to play sound effects, because we're going to want to be able to play sound effects from the start menu, from the game scene. We want to be able to play them from anywhere in the game. So what I want to do is I want to create an empty game object here, and I want to call it managers, and I want it to be surrounded by those triple dashes. And I want to, underneath of that, create an empty game object and call it sound effects manager. And we're going to want to create a script in our managers folder. I also want to create a timer manager, by the way. So let me go ahead and do that. Create empty timer manager. And I'm going to drag this timer manager script onto that. So this is going to get loaded up by our bootstrapper, and it'll be available in any scene. Currently, it's being created when we first try and request an instance of it. But now we're going to actually create it during our bootstrapper process. Now I want to go in here and right click, create empty, or create C# script. And I want to call this SFX manager. And I want to double click that to open it up. We're going to select everything and paste in the code for our sound effects manager. So, like our other singletons, this is a singleton mono behavior of type SFX manager. We have a serialized field with a list of audio clips. These are going to be our sound effects clips. And we're going to have an audio source. So in the awake method, we override awake. We call get component to get our audio source, and we save it off. There's going to be a public play clip method that's going to take an enumeration with a sound effect clip that we want to play. So we're going to actually, for every audio clip that we add here, there's going to be a corresponding enumeration for it. So we want one when we fire a bullet, when the enemy fires a bullet, when we play an explosion, and when we get an extra life. There's not a lot of sound effects in this game. So that's it for our sound effects manager. Now, in order to boot this guy up, we need to create our bootstrapper. So let's open up our Explorer here, and we can go into Scripts, Utilities. And you remember, we have a few things in here. We have our helper functions. We've got our singleton mono behavior, our timer class, our viewport helper. We're going to create a new class, and we're going to call this bootstrapper. And by the way, I first learned of this technique from TerroDev on his channel. I'm going to select everything. I'm going to paste in our code. So let's look at what this code is doing. First of all, there's this attribute, runtime initialize on load method. So this attribute is going to make sure that this function gets executed before the first scene loads. So the runtime initialize load type is before scene loads. There's a number of different types that we could choose from, but this is the one we want. So when this method gets called, we're going to go look for that managers from the resources folder. So I'll show you that in a minute. If we found it, if we didn't find it, we're just going to return. But if we found it, we want to instantiate that object, just like we were instantiating a prefab. And then we want to set its name to be managers. And we want to set the don't destroy unload on it. So it will live forever as long as the game is playing, even when we change scenes. All right, so now let's go and look at how we can add that to the resources. So we've got this managers object up here. If we collapse project and we go down to this resources folder, right now the only thing in there is the do tweens settings that got created by the do tween package when we set it up. We're just going to drag managers right into there. And now I'm going to delete it from here. So if we hit play, we should see a managers object appear here under the don't destroy unload node. So under don't destroy unload, managers, and underneath managers, we've got a sound effects manager and we've got our timer manager. So if we look at our sound effects manager, we currently don't have any script on it. So we want to go ahead and add that. So let's double click this again and select the sound effects manager and go back up into our managers folder under scripts and drag the SFX manager script on there. And I want you to see it immediately created an audio source. We don't want it to be play on awake, and we want the output to be sound effects. Why did it create that audio source? Well, if we go back and look at our script again for our sound effects manager, you see this require component type of audio source. So by virtue of that require component attribute, as soon as we applied that script to a game object, Unity immediately saw, oh, there's no audio source, I need to add one. And then we're going to grab that audio source in our awake method here. So I thought you all would appreciate knowing how that works. We still need to create our sound effects clips in this array here. So you remember we had that enumeration with all of those different values for our different sound effect clips. Well, that means that the clips need to be added in the exact same order as those enumerations. So if we go back and look at that script, and we look at that enumeration, we want our bullet fire, enemy bullet fire, so player bullet, enemy bullet, explosion, extra life. That's the order we want to add those scripts in. So we go into our sounds folder. So for the player bullet, I know that I want to take that from the laser weapon sound pack that we had downloaded. And I think the one I wanted to use was Light Blast 5. Okay, so that's the one I want to use. So I'm going to go back up here to our sound effects manager, and I'm going to drag Light Blast 5 into that. So that's our player bullet. For fire, I want to go back up to our sounds folder, and I've got this fire that I took from the Asteroids sound. So this is going to be our enemy ship's fire. Okay, and then for distant explosion, I want to use this one here that we got from freesound.org. And I want to use this one here that I got from that Fascinated Sound site for our extra life sound. So now our sound effects manager has all the clips that we want to use for sound effects in our game. All right, so let's go ahead and modify our code to actually play those sound effects. So where do you think we're going to do that? We're going to want to go into our PlayerWeapons class and go down to where we fire a bullet, and we're just going to uncomment this. We do need to tell it what fire sound we want. And so we are defaulting to the player bullet fire from our sound effects clip enumeration. So let's just jump back out into Unity, play. We'll fly around and fire some weapons. So now we've got thrusting sounds and we've got fire sounds. All right. Well, I think it's high time we actually get around to adding some asteroids to our game. So the first thing we're going to want to do is bring in the asset that I want to use for one of our asteroids. So you remember we have this 2D space kit. And we go in there is an asteroids folder. And so there are 6 different types of asteroid images in here. We're going to bring in asteroid 4. And I'm going to rename this to large asteroid 1. All right. And that's going to be one of our large asteroids. And some of these asteroids are smaller than others. So when this guy gets busted up, basically we're going to spawn 2 smaller ones. These other guys, there's some that are medium in size and there's some that are small in size. And so when this guy gets shot, we're going to dispose of it and we're going to spawn 2 medium-sized asteroids. And then when a medium-sized asteroid gets hit, we're going to dispose of that and spawn 2 small asteroids. And I've got 2 different medium asteroid images we're going to use and 3 different small asteroid images. But we're going to start with just the large asteroid. Now, the large asteroid, in addition to having a sprite, we're also going to want to add a rigid body 2D, and we're going to want to add a polygon collider 2D. Now, when this thing first spawns, we do not want the renderer or the collider to be enabled, because we want to make sure we put it in the right position before we actually turn it on. Let's go ahead and take a look. One thing we want is we want to put this guy on the asteroid layer. All right. And let's take a look at our rigid body. We know that we don't want any drag, and we know we don't want any gravity. And I think everything else looks good there. And that polygon collider fits around there nicely. Okay, so we're going to want to also create an asteroid script for this. But before we actually write the asteroid script, I want to write a script for asteroid settings. So I'm going to introduce a concept called scriptable objects. So what are scriptable objects? Well, a scriptable object is a data container that you can use to save large amounts of data. It's not going to be that much data in this case. Independent of class instances. One of the main use cases is to reduce your project's memory uses by avoiding copies of values. So basically, every asteroid is going to have different settings associated with this, and we can store those settings in a scriptable object. And then every instance of that asteroid can just take one of those, take those values as a scriptable object, and that's going to be the settings for that asteroid. And there is a method on there that you can add, create asset menu attribute, will allow you to right click and create an instance of this. And so we'll have settings for, large asteroids, settings for medium asteroids, settings for small asteroids, and so forth. And then the way we would use it is we just have an instance of that as a property or a member of our class. So that's exactly how we're going to use it in our game. So in our scripts folder, I'm going to right click, I'm going to create C# script, and I'm going to call this asteroid settings. And we're going to double click that to open it up, select everything, and we're going to paste in our asteroid settings code. So our asteroid settings is a scriptable object. We've got the asteroid size, which is an enumeration, small, medium, or large. We've got the minimum speed and the maximum speed. So the larger asteroids are going to move slower and rotate slower, and they're going to get gradually faster as they get smaller in size. And then, depending on the size of the asteroid, it's going to be worth a certain amount of points when you destroy it. So the large asteroids are only 20 points. The medium ones are 50 and the large ones are 100. And so by default, the large asteroids, they move pretty slow and they don't rotate all that terribly fast. So that is our scriptable object for asteroid settings. Let's also create a public class called Asteroid, and that's going to be a mono behavior. And let's move that into its own file. And once again, we are going to want to copy and paste our asteroid code. Now, there are some things that we don't need quite yet, like the scorable. That's basically going to say this is something that you get points for destroying. We're not going to implement that just yet. There is currently no asteroid spawner. By the way, I want to show you something kind of neat. You've noticed I put in some to-do statements in our code. Well, if we were to actually go up to View and look at Tool Windows, and I'm not sure where this would be in Visual Studio, but in Writer, you can see there is To-Do. And so it's going to search through our project, and it's going to find all of the to-do items in our code. So it found 79 of them. Here's one in Asteroid, to do implement asteroid spawner. So this way we can keep from losing anything that we know we want to come back and implement later. I'm just, to satisfy this compilation error here, I'm going to go up into Unity. I'm going to go up into our spawners here under scripts, and I'm just going to right click, create C# script, asteroid spawner. And then go back into our code. And now that particular error should go away. Except I'm just going to go ahead and uncomment that. Let's see what we got here. We've got our asteroid settings, and that's a serialized field, and then we can expose those settings publicly through this property with this expression body method. We're going to cache our rigid body, our transform. There's going to be a Boolean saying whether or not this asteroid's been destroyed. We have our asteroid spawner, so we can tell the spawner, hey, we were destroyed. We want our collider, and we want our renderer. So there is a public initialize method that's going to take our spawner and the position at which to spawn this asteroid. So this is just a debug statement that was being logged in the console to tell me that this was spawned at the correct position. We're going to save off our spawner. We're going to set our position. We are going to set the destroyed flag to false, and then we're going to enable the asteroid and apply force to it. So we enable it after we move it to the correct position. The disable function is going to turn our collider and our renderer off. We're going to make sure we get rid of any velocity and angular velocity, and we want to disable the game object. If we collide with anything, we want to basically check to see, are we already destroyed? If we are, just return and do nothing. That's just in case we get called for multiple collisions. We're going to set our destroyed flag to true, and we're going to tell the asteroid spawner, destroy this asteroid. And then this public property here with an expression body method is just going to return how many points this asteroid is worth. In the awake callback, we want to cache our transform, cache our rigid body, cache our collider, and cache our renderer. In onEnable, we want to initially disable all components. So that's if we instantiate a new one of these, we want to make sure we turn off the collider and renderer. And in onDisable, we also want to make sure we disable those components. OnCollisionEnter is going to call collided. So that was that function that we were looking at up here. Disable components disables our collider and renderer and also zeroes out our velocity and angular velocity. Enable and apply force. We set our game objects active to true. We want to get a random position, so random inside unit circle normalized times our speed. So we're going to get the amount of force in a random direction times whatever our random speed is. So you remember we have a minimum and maximum speed in our asteroid settings. So we're basically going to have a function called getRandomSpeed that is going to take the settings minimum speed and the settings maximum speed, and we're going to add our GameManager's round times 0.01. So I'm going to comment this part out for now because we do not have a GameManager yet. Basically, this means the asteroids are going to get faster and faster every round. Okay, so the GameManager is what's going to manage what round we're on, and we just want to basically add an extra 0.1 per round to our maximum speed. And I'm going to add a to-do here. Uncomment when GameManager is implemented. So we don't lose that. We can go to our to-dos down here. And that gets added there. All right, so we get our random force, which is going to be a random direction times a random speed. We want to initially set our velocity and angular velocity to 0, and then we want to add that force in impulse mode to our rigid body. We also want to add some torque. So the asteroid is going to spin at some random speed, taking the settings minimum rotation and maximum rotation. And we're doing that using physics by applying torque to the object. And then we turn on the collider and renderer. So that is our asteroid class. So let's jump back out into Unity. And we want to select our large asteroid and go up to scripts. And we want to drag that asteroid script onto it. And then for our settings, what we want to do is we have a settings folder. We're going to right click here and we're going to say create asteroid settings. So this menu item was added by that create asset menu attribute that we put on our asteroid settings scriptable object. If I create that and I say large asteroid settings, you can see it's got a minimum speed, a maximum speed, a minimum rotation, a maximum rotation, and a number of points. And that is what we want. The only thing that's wrong there is we want this to be a large asteroid. So if we select our large asteroid here, we can drag that large asteroid settings into it right there. And so if we were to hit play, this asteroid should turn on and start moving and spinning. I'm going to turn off our PlayerShip though. And actually, I just realized I put that asteroid under the manager's object in our resources folder. We don't want that there. So let's go ahead and just drag that into the prefabs asteroids folder. And then we're going to delete it from here. So let's work on our asteroid spawner a little bit. So I want to add some serialized fields here for our asteroid prefabs, an explosion prefab, and some values for how many asteroids we should spawn, and then the minimum spawn distance from a player. I'm going to go ahead and import missing references. And once again, the number of asteroids that we want to spawn will increase as the game progresses and we advance through later and later rounds. So I'm going to temporarily comment this out. I'm going to add a to-do on comment when GameManager is implemented. Okay, so in our awake method, we are going to want to cache our transform. And then we want to have a spawn asteroids method. And we need to have a method to get our object pool. And there's going to be several functions that can be called back when we instantiate an object from the pool, or when we take an asteroid from the pool, or return one to the pool, or when an asteroid is destroyed. So let me go ahead and copy all of those and paste them in here. Now we need to have a function to get a random prefab. So if you remember, if we go up to the top of our file here, we have these collections of prefabs. We're only ever going to have one large one, but we may want to add some in the future. We're going to have 2 mediums and 3 smalls, and we want to randomly pick from those prefabs when we spawn them. So let's go ahead and implement a get random prefab function. All right, and then the only other thing we need to do is we want to get a random spawn point when we instantiate a new asteroid. And so we're actually going to take advantage of a function that we wrote in our viewport helper. I'm just going to temporarily set this to vector3.0. And I'm going to put it to do uncomment when GameManager is implemented. All right. So we're going to use that get random visible position from our viewport helper to get a spawn point. And we're just going to keep doing that until we find one that's at least 2 or whatever the minimum spawn distance is from the player's position. This is just to make sure we don't spawn an asteroid directly on top of the player. That would be a little bit unfair. So we still have some compilation errors here at the bottom. It doesn't like this random range, and that's because it's an ambiguous reference. We could be getting that from Unity Engine. We could be getting it from system. So what we're going to want to do here is we're just going to want to tell it which reference we want to use. We want to use Unity Engine random. Okay, so I think that looks good. The only thing we want to do now is I want to add a context menu attribute to this so we can test spawning our asteroids before all the other code that would orchestrate this is written. All right, so I'm adding a context menu called spawn asteroids, and we're going to go up into our Unity project, and under spawners, we're going to expand that. We're going to right click, and we're going to create an empty object, and we're going to call it Asteroid Spawner. And I'm just going to move it up above the ghost spawner. And we're going to drag in the Asteroid Spawner script onto it. And then we need an explosion prefab, which we don't really need that yet because we're not going to be destroying this asteroid. But if we want to go ahead and grab it, we go up into our 2D space kit, prefabs, explosion, and we can just drag that right in there. So we're going to drag in one of our large asteroid prefabs. So if we go down to our prefabs folder, asteroids, we're going to drag that one right onto the large asteroid prefabs collection. And so now we have a large asteroid. So you can see that when it does spawn an asteroid, it should not be on top of the player ship. And so I'm going to highlight our asteroid spawner. I'm going to hit play. And I'm going to right click on this. And I'm going to say spawn asteroids. And there you go. There are 4 asteroids. Of course, one of them went right over my ship. And by the way, they don't have the ghost parent script on them yet. And I haven't created any asteroid ghosts. So those guys are just going to keep going indefinitely and never stop. And we'll never see them again. So the next thing to do is we want to go ahead and implement an asteroid ghost for that asteroid. Make sure that we have a ghost parent on that asteroid prefab. And when we verify that that's all working, we'll go ahead and create our medium and small asteroids. Now we want to go ahead and enable the ghost for this asteroid. So I'm going to take this large asteroid, I'm going to duplicate it, and I'm going to rename it to large asteroid to ghost large asteroid 1. All right, now one thing we're going to do is we're going to take off the asteroid script because we don't want that. But we go into our scripts folder, we're going to drag the ghost script onto it. Actually, make sure we're selecting the right one here. Go into our prefab. All right. So yeah, we want to make sure we have that selected. Go into our scripts folder, and we are going to drag the ghost script onto it. So this is now a ghost. Now on our large Asteroid 1 prefab, in addition to the Asteroid script, we want to add the ghost parent script. And then for our prefab, we're going to add ghost large asteroid. So let's go back out here and hit play. And I'm going to select our asteroid spawner. Okay, and I'm going to right click on the asteroid spawner and say spawn asteroids. And so now you can see it spawned the asteroids and their ghost, and they are behaving like we would expect, right? They peek in one side, come out the other. And they are swapping with each other when they go out of view. So all of that is working nicely. Let's go ahead and create settings for our other asteroid types. So in our settings folder, we can actually just duplicate these. And I'm just going to rename this one to be medium asteroid settings. And then I'm going to rename this one to be small asteroid settings. And let's go into the medium here. And for our minimum speed, that can still be 0.1. Maximum speed can still be 2. We want our minimum rotation to be 5. And our maximum rotation to be 10. Our points will be 50. And the size will be medium. Let me go revisit our large settings real quick. I want our minimum rotation for the large to be 1 and the maximum to be 5. I don't want them to rotate quite as fast. And then for our small asteroids, I want the maximum speed to be 3. I want the minimum rotation to be 5 and the maximum rotation to be 15. And then the points are going to be 100. And of course, the size will be small. So we got small, medium, large. All right. So let's go ahead and create prefabs for the rest of our asteroids and also for their corresponding ghosts. So in our prefabs folder here, you see we've got one large asteroid and one ghost large asteroid. So we're going to use Asteroid 3 and Asteroid 5 for medium asteroids. So I'm just going to go ahead and drag in those two and rename them Medium Asteroid 1 and Medium Asteroid 2. And for the small asteroids, I'm going to use Asteroid 1, 2, and 6. So let's drag out Asteroid 1, Asteroid 2, and Asteroid 6. And that's going to be small Asteroid 1, small Asteroid 2, and small Asteroid 3. Now I'm going to select all of them, and I'm going to add a Polygon Collider 2D, and it's initially going to be disabled, and their sprite renderer is initially going to be disabled, and we're going to add a Rigid Body 2D. And we want to make sure that it has no angular drag and no gravity. Okay, so we also want to duplicate these because we're going to use them for our ghost. All right, so I'm going to come over here. I'm going to rename this to be Ghost Medium Asteroid 1, Ghost Medium Asteroid 2, Ghost small asteroid 1, Ghost small asteroid 2, and Ghost small asteroid 3. All right, so what we also want to do is for all of these asteroids, we want to drag in the asteroid script. Let me go ahead and minimize all these things. And the ghost parent script. Now for the medium ones, we want to pick our medium asteroid settings. And for our ghost prefab, we're actually going to have to create the prefabs first. For the small ones, we want them to have the small asteroid settings. Now, if we go ahead and select our ghosts, they are going to have the ghost script. All right, so now let's go ahead and drag these into our prefabs folders. So let's go ahead and drag medium asteroid 1, medium asteroid 2, small asteroid 1, small asteroid 2, small asteroid 3, ghost asteroid 1, ghost medium 2, medium, or small asteroid 1, ghost small asteroid 2, ghost small asteroid 3. All right, so now this guy we can use for medium asteroid 1. We can drag in ghost medium asteroid 1, ghost medium asteroid 2, ghost small asteroid 1, ghost small asteroid 2, and ghost small asteroid 3. And we can also override apply all. Okay, so I think we can now go ahead and delete all of these from here. And if we go into our asteroid spawner, we need to drag in the prefabs for those other types of asteroids. So we have our large asteroid prefabs. Let's lock that in the inspector, and let's select both of our medium asteroid prefabs and drag them under medium. So now there's 2 there. And then for our small ones, we can drag those under small, and we've got those. All right, so our spawner is all set up with the prefabs and their corresponding ghosts. The next thing we're going to want to do is write the code that we need so that the asteroids can be destroyed, and if they're big, they'll split into medium. If they're medium, they'll split into small, and so forth. Now, before we can actually destroy and split our asteroids, we're going to need to create a few more things. We're going to go down a little bit of a rabbit hole here. Under spawners, I'm going to create an empty game object, and I'm going to call it explosion spawner. And this is what we're going to use to spawn our explosion effects. And while I'm at it, before I forget, I'm going to create a script under script spawners called explosion spawner. Now, one thing you'll probably notice is I have a space in the name here, but not here. So it's perfectly okay to have a space in the name of these game objects, but C# scripts classes, they cannot have a space in the name. So I'm going to pick my explosion spawner here, and I'm going to drag that script onto it. Before we can even code the explosion spawner, though, I want to begin work on our event bus. So I mentioned in the intro for this video that we're going to use an event bus to decouple components in our game. We're going to basically be doing a variation of the mediator pattern, where we're going to have a generic event bus where we can subscribe to events and raise events. basically the listeners who are subscribing to events don't care who is raising the event. So that makes it a little bit different from just the observer pattern, where you're observing an event that can be fired on a specific object, and you're expecting that specific object to raise that event. With the event bus in the mediator pattern, anybody anywhere can subscribe to a specific type of event, and then anybody anywhere else can raise that type of event, and everybody that's subscribed to it will receive it, and they don't really care who fired it, who raised it. So in our event bus folder, I'm going to create a script called event bus. And we're going to double click that to open it up in Writer. And like before, we're going to select everything and we're going to paste in our code here. So let's go ahead and take a look at this code for our event bus. Like the other singleton classes, this is a singleton mono behavior of type event bus. So we can access it anywhere through our instance variable, and there will only ever be one of these at any given time in our game. We're going to have a read-only dictionary that's going to map from a type to a delegate. So a delegate is basically a callback function that will get called when this event is raised. And that's going to be initialized as an empty dictionary. The subscribe method is going to basically get the type of the event that we want to subscribe to, and it's going to check to see if we can add that to the dictionary. So we're going to do a, if not event dictionary, try add event type listener. Then we're basically going to use the existing entry in the dictionary, and we want to combine our listener to the list of listeners. So basically the way this is going to work is the very first time you call subscribe for a type of event, we're going to add it to the dictionary. All right. But if there's already an entry in the dictionary for that event type, then we're just going to grab that one and we're going to add our listener to it. So we'll be one of more than one listener, one of many listeners to that event. Unsubscribe, we're going to get the type. We're going to try and get the value out of the dictionary. If there is not a dictionary entry for that event type, we're just going to return and not do anything. Otherwise, we're going to remove our listener. And then if there are no more listeners, then we are going to remove that entry from the dictionary. Otherwise, we're just going to assign the delegate list back to that dictionary. Now, the raise event, we pass in the type of event and any arguments that that event might take, and we are going to try and get that event entry out of the dictionary, and then we're going to cast it as whatever type, and we're going to call invoke on it, passing in the event arguments. So this is totally generic. This can handle any type of event we want to. We can create events, subscribe to them, we can unsubscribe from them, and we can fire them. So in order to use this for our explosions, I want to create an event type to handle when an explosion ends. So what do I mean by that? Well, when we create an explosion effect, it's basically going to be playing an animation. And when that animation gets finished playing, I want to fire an explosion completed event, and I want to pass in basically ourselves, so that the explosion spawner can subscribe to that event, and whenever it receives it, it can basically release that event object to the pool. So we're going to use object pooling for these event effects, and there'll be multiple of these spawning at a given time. You can imagine you're shooting a bunch of different asteroids. Every time you hit an asteroid, you're going to spawn one of these explosion effects. Well, when those things get finished playing, we want to recycle them, put them back in the pool so we can reuse them. So what I'm going to do is down here at the bottom of the file, I'm going to paste in this explosion completed event, and it's going to basically have a public explosion effect that we're going to set in the constructor when we instantiate it. And that's all there is to it. It's just a struct. It's not a class. I'm using structs instead of classes because these will get instantiated on the stack, not the heap, so there won't be any garbage collection involved here. Now I'm going to go ahead and move this to its own file. And we're going to want to create the explosion effect prefab that we're going to use for this guy. So let's jump back out into Unity. And we're going to want to create a prefab for this explosion. So if we go into our 2D Space Kit prefabs, you can see there's this explosion prefab here. I'm going to drag this into our scene, but we don't want to use this exactly the way it is. So for instance, it's got a particle system. We want that, but it's also got this particle system destroy script. We want to get rid of that. But before we get rid of that, we want to unpack this prefab. We don't want to use their prefab. We're going to create our own. So we're going to say unpack completely, and then we are going to remove component. And we're going to be creating our own explosion effect script that we're going to add to this. So let's go down into our scripts folder, and under effects, we're going to right click, create C# script, explosion effect, and select our explosion here after Unity gets finished compiling. And we're going to drag that script onto there. Now let's go ahead and double click this to open it. Select everything, and let's paste in our explosion effect script. So we have a serialized field that's going to take a volume for how loud we want this sound effect to play for our explosion. We want the particle system. We're going to cache that in awake. And then this float completed time. So in onEnable, we're going to play the explosion sound effect using our sound effects manager. We are going to tell the particle system to play. And then we are going to set the completed time to be the current time plus this particle system main duration. And an update, we're going to just check to see if that time is greater than or equal to our completed time. And if it is, we're going to raise that explosion completed event. And you notice we're actually constructing a new one in this raise call here. So this is going to instantiate this on the stack, so we're not creating any garbage. And this will basically tell our event bus, hey, I want you to find the event in the dictionary. If anybody subscribed to it, I want you to invoke their delegate. Now, one thing you're probably noticing is we're not using a timer here. So I just wanted to show you how we would do this if we aren't using a timer. Now, I could refactor this to use a timer, but I don't think I want to do that right now. You get the idea. We go into our explosion spawner here. We're going to want to actually implement this script now. So select everything and paste in our code. So I added this preprocessor directive here. So if we're using the Unity editor, I want to have this using Unity input system. But I only want to do this if I'm in the editor. And the reason I did that is I want to have a little method here. If I'm in the editor, I want to add an update method where I check to see if I pressed the right button. And if I did, I basically want to spawn an explosion wherever I clicked. So I only want to do this if I'm testing in the editor. So I added a preprocessor directive for if Unity editor here, and I also added it up here, so I only include that namespace if I'm going to be doing that. All right, so let's look at our explosion spawner. We're going to take an explosion effect. All right, so that's that prefab that we actually we haven't created a prefab yet. Let's jump back out into Unity real quick. And we got this explosion here. It's got the explosion effect script on it. So we can go into our prefabs folder and we can just drag that right there. So now going back out into our code, we're going to basically drag that prefab into the serialized field here. We're going to maintain an object pool of explosion effects. We have a public spawn explosion method. It's basically going to take a vector3, which is where we want the explosion to spawn, and that's most likely going to be the position of an asteroid or the position of a ship. We're going to get an explosion from the pool, which will, of course, instantiate a new one if the pool is empty. We're going to set its position to be the position we passed in, and we're going to activate it. So this explosion spawner and its on activate, we are going to create our pool, and we're going to have callbacks for create explosion, get explosion, release explosion, and destroy explosion. And we want to subscribe to that explosion completed event using our handy dandy event bus. So in on explosion completed, all we're going to do is release that explosion to the pool. So you remember this is a struct which has a property called explosion, which is an explosion effect. So we're just going to get that explosion effect from this event, and we're going to release it to the pool. Now, I created a region here. This is something you can do in pretty much any source code editor. You can say hashtag region and give it a name, and then you can collapse that so you don't clutter up your code. And I put all the object pool related methods inside that region. So we create an explosion. We're going to instantiate it using our prefab, and we're going to give it our transform as our parent. So all explosions are going to be spawned underneath of this explosion spawner in our hierarchy. We're going to initially make sure it's not active, and then we are going to get the explosion component effect, the explosion effect opponent off of that explosion and return it. On get explosion, we're not doing anything special. When we release an explosion, we are going to set it to inactive. And if we're destroying it, all we're doing is destroying it. So here is our handy dandy, if we're in the editor update method, if I right click the mouse, I want to spawn an explosion at that point. So let me just come back into our game. And I want to select our explosion spawner, and I want to drag this explosion prefab into there. And I want to clear these errors. So good, we don't have any compilation errors now. So I'm going to go ahead and I'm going to turn off the asteroid spawner temporarily. And I'm going to hit play. I have an explosion that was already in the scene. That was what you just heard there. So everywhere I'm right-clicking, I am spawning explosions, and you can see them here. They're being pooled and recycled from our pool. Nice. So the next thing we want to do is to get our asteroid spawner destroying asteroids. So we want to add a public method right up here above awake. Public void destroy asteroid. All right. So you can see here that we're going to tell our explosion spawner to spawn an explosion at the asteroid's position. Right, that was passed in. We're going to split that asteroid if it's a large or a medium, and then we're going to release that asteroid to the pool. And then if asteroids.count is 0, meaning there's no more asteroids on the screen, we want to tell the game manager the round is over so it can spawn a new wave of asteroids. Obviously, we want to do this when the game manager is instantiated. So we have this commented out for now. So let's go down and look at our where we want to put this split asteroid at. I think we're going to put it right underneath of this get random spawn point. So what are we going to do? We're going to check the size of the asteroid, and if it's small, we're just going to return. So basically, this asteroid just was destroyed. We're not splitting it up into smaller pieces. Otherwise, we're going to decrement the size by 1. So if we go and look at our size parameter here, you remember it is an enumeration. And it goes small, medium, large. So if we were large, we're going to decrement by 1. And so we want to basically spawn 2 mediums. If we're medium, we're going to decrement by 1, and we're going to spawn 2 smalls. So we're saying, hey, give me the object pool for the asteroids that are one size smaller than what this asteroid was. And then we want to basically spawn 2 of these guys. We want to tell that pool, hey, give me a new asteroid. We want to initialize it and set it to the position of the asteroid that was destroyed. And then we want to add it to our list of asteroids. The other thing we want to do is add a release asteroid to pool method. So we're going to pass in an asteroid. We're going to deactivate that asteroid. We are going to get the index of it from our collection of asteroids and remove it from that collection. And then we want to tell the pool, release this asteroid to the pool for whatever size asteroid that was. All right, so hopefully that all made sense. And that looks like all of those compilation errors have been fixed. So the other thing I want to do is, just like we did for our explosion spawner, I want to come down to the bottom of our file here, and I want to paste in some code. If we're running in the Unity editor and I press the left button, then I want to destroy all asteroids. And so what destroy all asteroids is going to do is it's going to make a local copy of our collection of asteroids. We're going to iterate through every one of those and call destroy asteroid on it. So that should display explosion effect. It should split the asteroid into 2 unless it's already a small asteroid. And we can test all of that functionality. Now, I had to alt enter to import the missing references. So now if we go up here, you're going to see that it pulled in system collections generic. We don't need this other system collections. And it also pulled in this Unity input system. And so we're going to go ahead and wrap that in a preprocessor directive so that it won't pull that in a regular build. So let's go back out into Unity. And we're going to hit play. And I'm going to right click on our asteroid spawner. And I'm going to say spawn asteroids. And so now I'm going to right click again and say destroy all asteroids. Check that out. Let's do it again. And let's do it again. All right, so that functionality is working. So we want to make sure that the player can shoot and destroy asteroids. So if we go back into our code and we go into our asteroid class, down in our public collided method, we had commented out this call because at the point when we wrote this, the asteroid spawner did not exist. So if we have a collision with another object, or if one of our ghosts have a collision and they call our collided method, we are going to tell the asteroid spawner to destroy us. And it's, of course, going to do what we just demonstrated. It's going to spawn an explosion effect. It's going to split the asteroid if it's a medium or large, release the asteroid to the pool. And then later on, if there's no more asteroids on the screen, we're going to tell the game manager that the round is over. So I want to just go back into Unity. And I want to look over all of our prefabs, make sure everything's on the correct layers. So if we look at our asteroids, they're on the asteroid layer. Oop. So this is wrong. We want this to be asteroid. And I'm going to double click this. So there's no child components we need to worry about. So let's look at this guy. Let's just select all the ones that are still on default. So it's pretty much everything except the large asteroid. So I'm going to pick all them. And change it to asteroid. Okay, so now Based on our collision matrix that we had set up, asteroids should collide with players, enemies, player bullets, and enemy bullets. So let's go look at the prefab for our player bullet. It is a player bullet. And of course, the player ship is on the player layer. So let's just see if we can fly around and shoot asteroids and if they break apart and get destroyed correctly. I had to click in there to get it to recognize my keyboard input. Oh, I'm shooting asteroids. Now the player ship will probably not get destroyed, but I should. He's indestructible and he can go pounding his way through asteroids by crashing into them. Because we have not implemented the player ship being destroyed yet. I want to shoot it through the expanded universe. Oh well. I'm a terrible aim. Okay, so we're able to shoot and destroy asteroids. So now I think we're to the point we want to start orchestrating things in our game. So we're going to want to create a GameManager class. And so for the GameManager class, I want to have, like right up here we got our spawners and ghosts and bullets. I want to create an empty game object. And I want to call it managers. And these are managers that are specific to the game scene. So unlike the one that we had, as you remember, in the resources folder here, these I want available anywhere, whether you're in the game or in the menu or whatever. But these here are only going to be available in the game scene. And under here, I'm going to create an empty game object and call it Game Manager. And in our scripts folder, under managers, we're going to right click, create C# script Game Manager. Let Unity recompile that. And I'll select our Game Manager here and drag the Game Manager script onto it. Now if I double click that to open it up in the editor, we're going to do like we've always done. We're going to Control A and Control V to paste in a bunch of code. All right, so this is a pretty big class. I don't think we need this namespace here. We're going to walk through this code a little bit at a time, and I'm going to explain everything that's going on. We'll probably comment some of it out and implement it as we need it. But as always, we've got a singleton mono behavior of type Game Manager. We have two serialized fields, one for the delay for spawning a ship, and the other is the number of points for an extra life, which is going to default to 10,000. Some public properties. The Game Manager is going to keep track of how many rounds we played, and as this increases, the number of asteroids that spawn will increase and the speed of the asteroids will increase. We're going to keep track of our score and the high score. And so these have public getters but private setters. That means I can access them from anything that has access to the Game Manager, but they're only set within this class. And then I don't even think I'm using this, but I have a public reference to our player ship, which we have down here. We may end up deleting that because I don't think I'm using that anywhere. The main thing that we're going to have, though, is our game state. So there's a number of ways you can handle state in your game. For a very simple game like Asteroids, I just have an enumeration called game state. And there's just a few states. We have start game, start first round, start round, ship spawned, player died, round over, game over. And they might not be the most elegant names, but they work for what I'm trying to do. In a more sophisticated game, you would probably want to use something like a finite state machine, and I have an example of how to do that in my Defender series. But in this game, we're just basically going to maintain a game state using that enumeration, and whenever the game state changes, I'm going to fire a game state changed event, so that anything that cares about handling certain state changes can subscribe to that event from our event bus and do things based on what state we just switched to. So we have private variables for the number of lives. We're going to save off the next extra life score, which initially is going to be this value here. And then every time we eclipse that and get an extra life, we're going to increment that by this amount here. Like I said here, we're going to save off our PlayerShip. And we have a couple of timers here. We have the next round timer and a spawn ship timer. So I have a public method here called restart game, and that's going to call a public method called start game, and we'll go over that in a little bit. So we have an override of our awake method we call the base class, and then we basically go find our PlayerShip. So we want to save off an instance of our PlayerShip, which, as you recall, is underneath of our PlayerDirector here in the game scene. So the start method, we're going to go out to our settings manager, which doesn't exist yet, and we're going to get the high score, and we're going to save it to our high score variable. So let's go ahead and comment this out and add a to-do, implement settings manager. All right. So we have this private method here called start first round. We're going to create our timers. We're going to increment round, which is initially 0, so this will become round 1. We are going to add points 0, and the only reason we're doing this is because this is going to fire an event, and we want to update our UI, which is going to subscribe to these events so it will display the score, and also the number of lives that the player has left. We want to set our game state to start first round, and then we want to start our spawn ship timer. So the ship won't spawn immediately, it will spawn after this initial delay has elapsed. We have a public round over function, which will set our game state to be round over, and we will start the next round timer. We also have a public player died function. This is basically going to raise an event, a stop all music event. So we want to make sure that any music that's playing stops when the player dies. And then if we have any more lives left, we're going to set the game state to player died and start the spawn ship timer. So we'll wait and spawn another ship. Otherwise, we just want to call game over. The start next round timer function basically just calls start on our next round timer with that delay there. Start spawn ship timer does the same thing, but for our spawn ship timer, and it uses the spawn ship delay time that we set up in the serialized field. Our game over function is going to release all our timers, set the game state to game over. It's going to fire a play music event with the game over string, so to tell it which music clip to play. So we have not implemented music yet, and we're going to set our high score to whatever the high score currently is. So right here, I want to add a to-do. Implement music manager and settings manager. All right. So we have a public add points method. We're going to increment our points. We're going to check and see if our score is greater than the high score, and if it is, we're going to assign it to our high score. And then we're going to fire this score changed event. And that's going to take two parameters, the score and the high score. And then we are going to check for extra life. We have a pause game, so we're going to set the time scale to 0. This will basically keep any Unity events from happening while we're paused. And we're going to actually call this from our settings manager, which doesn't exist yet, so that when we pop up our settings dialog, we can pause the game, and then when we close that dialog, we can resume the game. Check for extra life basically checks to see if we've exceeded the next extra life score. If we haven't, we just return. Otherwise, we will increment the next extra life score by that value in the serialized field. We will play a sound effect clip for an extra life, and then we're going to raise this event, player lives changed event. And this will tell our UI to update the number of PlayerShip icons that are displayed in the player lives portion of the UI. And so I'm going to add a to-do here. Uncomment when UI is implemented. So the create timers method creates our next round timer and our spawn ship timer and subscribes to their on timer stop events. Release timers will unsubscribe from those events and then release those timers to the pool. The start next round event will increment the round and then set the game state to start round. Start game resets everything. We set our lives to 3, our score to 0, round to 0. Next extra life goes to the default value that's in the serialized field, and then we call the start first round method. Spawn ship is going to raise an event, player lives changed event, and again that's going to be for our UI. So we will say uncomment when UI is implemented. We'll set our game state to ship spawned, and then we will play the music event game clip. Our set game state method sets our game state variable to whatever game state we pass in, and then it raises a game state changed event passing in the new game state. And this is our game state enumeration that we've already looked at. So we've got a few compilation errors here, and they're all because we don't have these events. So what we can do, we know we're going to want the stop all music event, and we're going to want the score changed event. Actually, we can comment this one out until we implement the UI. But we're going to want the play music event, which again, we can uncomment that when the music manager is implemented. But we do want the game state changed event. So we want game state changed. And well, we don't need this one either, do we? So really, the only one we need immediately is the game state changed event. So let's jump back out into Unity. And we want to go into our scripts folder, event bus. Event bus. We're going to right click, create C# script, game, fingers on the wrong keys, game state changed event. And let's double click that. Control A, Control V. So this is our game state changed event. It's going to have a public game state property that gets set in the constructor when we instantiate it. So go ahead and close that. And that should fix all of our compilation errors. Now let's just jump out into Unity and look at our GameManager. And you can see we've got our two serialized fields there. So one thing I know I'm going to want to do is I want to go into our PlayerDirector and open up his script. And we're going to have to make some changes in here so we can handle those events, respond to events, and do things like handle the game state changed event and so forth. So right now in onEnable, we're calling enable fire and we're calling enable hyperspace. I don't want to do that. I want to get rid of those. And instead, what I want to do is I want to subscribe to the game state changed event. I need to implement a method create on game state changed. And let's just move this down below our Unity callbacks. And I'm going to call this game state changed event. And I'm going to paste in some code here of what we're going to do whenever the game state changes. So one thing we're going to do is if it's start first round, we want to disable the ship. If a ship is spawned, I want to reset the ship to start position. I want to enable the ship's renderer, and then I want to enable invulnerability. Want to set fire enable to true, but hyperspace enable will be false. I'm going to start this timer, and then this will enable hyperspace. So I don't want the player to be able to go into hyperspace for a few seconds after it spawns. If the player died or the game is over, I want to call disable ship. So let's go ahead and implement disable ship. We're going to create a function. I'm just going to paste all this in there. Now, currently, our player is not getting any of that. So one thing we're going to do in our player in awake is we're going to want to get the renderer, the collider, the rigid body. So let's just go ahead and create these fields. Oop. Did not mean to do that. Alt enter create field. There we go. And also we want to tell our ghost parent to enable all the ghosts. Actually, in this case, to disable all the ghosts. So if the ship is disabled, his ghost should be disabled as well. And so once again, we're going to have to create that field. All right, now we have disable ship. I want to move these public functions up near the top, above our Unity callbacks, since they're at the top of the class. And I like to have the things that we can access publicly at the top of the class. I also want to add an enable renderer function. That's going to enable our renderer. I want to add that reset ship to start position and enable vulnerability methods. I'm just going to paste them in. Now I need to write a new function here called set shift alpha. So when the ship is invulnerable, meaning it can't be collided with, I want to render it with half or actually a quarter of the normal opacity. So it's kind of faded out. So I'm going to create this function. I'm going to paste in this code here. And I'm going to call this alpha. And get rid of this. And I'm going to move this down below our Unity callbacks. All right. Actually, I have some more public. Well, these are the. Yeah, I want to move these public methods up above our Unity callbacks. Doing a little bit of code restructuring, reorganizing here. All right, good. So let's go back into our PlayerDirector, and is there anything else it's still complaining about? Enable vulnerability. So we want to implement enable vulnerability on our PlayerDirector. Let's just put that down here. So we're going to want to have a flag called isVulnerable. So let me go ahead and create that field. All right. We want to have a timer for canceling invulnerability. So at the top of our class, let's just add cancel invulnerability timer. All right. And then we want to have an invulnerability duration, which I'm actually going to make that a serialized field. So that can be something that we can set in the inspector. And I'll default that to 3 seconds. And then we need to create a callback function for cancel invulnerability. And we're also going to want to create a cancel invulnerability method on the PlayerShip, which I'm just going to jump over to the PlayerShip and do that because I want that to be another public method up near the top, which I will paste in. So when we enable invulnerability, we disable the collider, we turn our ghosts off, we set the ship's alpha to 1/4 normal. When we cancel it, we enable the ghost, we enable our collider, and we set our alpha back to 1. All right. So that fixes all of those errors there. I want to make sure I'm not missing anything here. So on enable, update, on game state changed. So in the update method, I want to add something before I check rotation, thrust, and fire in hyperspace. I want to check invulnerability. Let's go ahead and create that function. And I'm going to move that down to where the other functions related to invulnerability are. All right, and so what I want to do and check invulnerability is I want to see, are we invulnerable? And if we're not, we just want to return. And then I want to see, did the player press any input? Did they thrust? Did they fire? Did they rotate? If they did, or if they didn't, I just want to return. But if they did, I want to cancel invulnerability. So we already have a timer that's going to cancel invulnerability. But I also want to cancel invulnerability if the player presses any input keys. So when they first spawn, maybe they want to get into the action right away. They don't want to wait until their invulnerability fades out. But if they do that, they lose their invulnerability immediately. So cancel invulnerability will basically tell the PlayerShip to turn their collider back on, put the alpha on, turn the ghost on, and it's also going to stop that timer if it's still running. Okay, I think that should be most of what we need here. So when this guy first wakes up, he's going to subscribe to the game state changed event. And then depending on the state of the game, we'll disable that ship initially. We'll handle the ship spawned event. I want to check and see if there's anything else I need to do in the PlayerShip class. Yeah, I want to add a public function to the PlayerShip called collided. And I'm going to add another to-do here. So we want to spawn an explosion at our position. We want to disable our ship. We want to reset our ship to the start position. Okay. And we want to add an on collision enter 2D method. So we have all our public methods at the top. We scroll down. We have awake, fixed update. We want to add on collision enter 2D. And it's going to call collided. All right, now collided is also going to get called by our ghost. So you remember we have this interface here on our class, iCollision parent, which has that collided, right? So we want to add that to our PlayerShip. All right, so we are implementing the iCollision parent collided method. And now our ghost can start to use that. So you remember our ghost will look for a collision parent on whatever it collided with and call collided on it. All right. So let's see what happens if we jump out into Unity and hit play. We should initially see a disabled ship, and then the ship should spawn. All right. And I'm not able to move or fire because I'm getting a bunch of errors here. So in create timers, we need to create our cancel and vulnerability timer. Go back out and try that again. Ship spawns, not seeing any errors. I can fly around, I can shoot. Okay, so the next thing we want to do is we want to have our asteroid spawner actually respond to those game state change events and spawn asteroids. So to get our asteroid spawner doing that, let's go into our spawner, asteroid spawner, open up the script. Let's scroll down here. You see I've got this to do, uncomment when GameManager is implemented. So let's go ahead and get rid of this comment and uncomment this code here. So now what this will do is our spawn count, the number of asteroids we're going to spawn for any given round, is going to take the current round that we're on into account. So we have our asteroids to spawn, which starts at 4, and we are going to add to it the current round minus 1. And you remember when we did start next round, we increment it round from 0 to 1. So initially this will be 0. So it'll be 4 plus 0 is 0. And we're taking a math.min of that. So we're taking the minimum of this or max asteroids. So we're never going to spawn more than 10 asteroids. And we also want to get rid of this comment here. And if we're out of asteroids, if the last asteroid has been destroyed, we want to tell the game manager that the round is over. Now in our awake method, we're currently caching our transform. We're also going to want to subscribe to the game state changed event. And we want to call the on game state changed method. And I want to add an on destroy here. And basically we're going to unsubscribe from that same event when this thing is destroyed. And I had this little null-interpolator here because it's possible that this event bus got destroyed before this got called, and I don't want to dereference a null instance here and get a null reference exception. So let's go ahead and implement on game state changed. So I'm going to change this parameter from obj to game state. So if we are starting the first round, we want to release all asteroids. That basically means we've started a new game, and I don't want any existing asteroids to still be hanging around. Otherwise, if it's start first round or start round in general, I want to spawn asteroids. So we already have our spawn asteroids method here. We want to create a release all asteroids method just beneath that. And so what we're going to do is we're going to iterate through our collection of asteroids. We are going to set each one to inactive. We're going to tell the object pool for that particular size of asteroid to release that asteroid to the pool, and then we're going to clear our collection. All right. Now, this here, we're currently just assuming that the player is at vector 3, 0. We don't want to do that. We want to actually get the player from the game manager and use his actual position. So right here we're saying game manager.instance PlayerShip transform position. If that's null for whatever reason, like maybe the PlayerShip doesn't currently exist in the game manager, then we're just going to assume vector 3.0. And remember, when we get our random spawn point, we want to keep iterating through this until we get one that's at least this minimum spawn distance from the player, which is defaulting to 2 units. So we don't want to spawn any asteroids directly on top of the player. So I think that's pretty much all we need. I did want to get rid of these functions down here that I had added to destroy all asteroids when I click. We're not going to need that anymore. And we also don't need the attribute that we added, the context menu attribute that we had added to spawn asteroids, because the game manager is going to handle spawning asteroids now on virtue of the game state changed event. So let's just jump out into Unity and let's hit play. You can see we've already spawned some asteroids. Our ship spawned in. I have to admit, I am pretty good at asteroids. All right, let's see what happens. And it spawned in some more asteroids after a delay. And I just want to hit pause here and see we've got 5 large asteroids. So the first round we spawned 4. The second round we spawn 5. The next round we'll spawn 6, and so forth, up until we get to the point where we're spawning 10 asteroids. So this section of the video I'm particularly excited about. We're going to get into adding music to our game, and we're going to do something that's going to be a bit more complex than you usually see in game tutorials of this scope. I actually covered this topic in detail in my music and sound effects series, but we're going to use basically the same pattern I use there for music in this game here. And it's going to involve a music manager, and it's going to involve a couple of different scriptable objects for music mixes and music clip groups. So we're going to start by creating our music manager. And so as you recall, we have this resources folder, and we have our managers here. And this guy, as you recall, gets loaded by that that attribute that we added to the parent script. That's actually going to load this when the game first loads. So every child of this manager object here is going to be available from the very first time the game is launched, no matter what scene we're in. And so, like sound effects, music is something we want to be able to start and stop from any place in our game, no matter what scene we're in. So we're going to add a music manager under here. So I'm going to create empty music manager. And we want to go into our scripts managers folder, right click, create C# script music manager. And we'll double click that to open that up in the editor. And we're going to select everything, and we're going to paste in a bunch of code. So let's go take a look at this code. We have 2 serialized fields here. One for a list of music clip groups, and the other for a list of music mixes. Now these don't exist yet. These are going to be created with a scriptable object, 2 different scriptable objects. And this is, again, a singleton mono behavior, so there's only ever one instance of this available anywhere in our app. We have some private variables. We have our current music mix, which is going to be an index into this. And we have our current music group, which is going to be one of these. We have a timer, which is going to be to start the next track. So basically what we're going to do with this music manager is we're going to shuffle between tracks in any one of these music mixes. So like on the menu, we might have 5 or 6 different audio tracks that we want to shuffle between. And so we're going to set a timer based on the duration of these guys to know when to start the next track. And we're actually going to do a crossfade between the different tracks. So we can have a nice smooth fade out from one and a fade into the other. And so I have some public methods here to play menu music, play game over music, and I added a context menu here. And the only reason I have these here is just so I can test this in the editor. This is very non-generic and very hard-coded to a specific type of music, which we don't really want this music manager to behave that way, but just so I can test it within the editor, I've added these methods here. So going down to the actual implementation of this, we have a play music method that's going to take the name of a music group. All right, and we're basically going to find that music group and assign it to our current music group variable, and then we're going to tell this manager to play the next track for whatever the current music group is. We also have a method here to stop all music. So we're basically going to stop whatever timer is running to play the next track, and we're going to unsubscribe from its play next track, from its on timer stop event. We're going to loop through all of our music mixes and make sure they're stopped. The play next track method is going to get the next music clip for the specific current music group. So this is going to be an extension method that I'm going to create to allow us to do that. We are going to toggle our current mix, which is going to do that crossfade. We're going to toggle our current mix, which is basically just going to flip this index from 0 to 1, because we know there's only 2 of those. And then we are going to tell the current mix to play whatever clip we got from our get next music clip call. And then we're going to start the timer to play the next clip. So music clip group, get music group, we're basically going to look it up by name from our music clip group. So this is a link call, first or default, where the group's name equals the group name that was passed in. So we're either going to find it and return it, or we're just going to return null. This function here is going to initialize all of our music mixes. I'm going to iterate through all the music mixes in our serialized field, which is a collection of music mixes, and we're going to call initialize on them. And then we're going to tell our audio settings to load the audio settings. Now we have not written this yet. This is what's going to allow us to customize our music and sound effects mix and save it to persistent settings so they get reloaded when the game loads. So when this script starts, we're going to create our next track timer. We're going to subscribe to different events, and we're going to initialize our music mixes. When this guy disables, we're going to unsubscribe from any events, and we're going to release that timer. So the create next track timer just creates a countdown timer. When we start that timer, we're going to basically subscribe to the play next track, to the on timer stop event, in which we'll play our next track. And then we're going to get the length of that clip. And I just want to subtract 10 seconds from it because these things tend to fade out already. And I don't want to wait till it completely fades out before I switch to the next track, because I want to do a crossfade between these things. So I just subtract 10 seconds from whatever that clip length is, and I use that for our timer. Subscribing to events, I'm going to create a couple of events here. We're going to have a play music event, and we're going to have a stop all music event. They're not going to take any parameters. Basically, all they're going to do is tell the music manager that we want to play some music or stop playing music. And unsubscribe events is going to unsubscribe from them. Releasing the track timer, we just unsubscribe from the on timer stop event and then tell the timer manager to release that timer to the pool. The on play music event that we subscribe to up here is going to play whatever music group was specified in that event. All right, so let's go ahead and create these events. So we're going to go up into our event bus folder here. We're going to right click. We're going to create C# script. And we want to create a script called music events. And I'm going to put all our music related events in here. So let's open that up. And we're just going to select everything and paste this in. So we have two events in here. We have a stop all music event that takes no parameters. And then we have a play music event that's going to take a music group name, which is assigned in the constructor. All right, so let's go back out into our music manager. And you can see that it fixed that compilation error. We still have a couple other errors in here. We need to create our scriptable objects for music clip group and music mix. So let's go ahead and work on those now. So in our scripts folder, we have this audio folder, and we currently don't have anything in there. Let's create two scripts. We want to create one called music clip group, and we want to create another called music mix. And let's go ahead and do the music clip group first. Let's look at this code. So this is a scriptable object. We have our create asset menu. So basically we are going to in our hierarchy, we have assets, project, music clip group. So if you remember, if we go back out into Unity, we've got this music folder, and there's two folders in there, music clip groups and music mixes. So we are going to, in the music clip groups, create a music clip group. And then this menu will show up as Asteroids tutorial music clip group. So we have two serialized fields. We have a group name, and then we have a array of audio clips. Now this guy is going to maintain a queue of audio clips, because basically the way this is going to work is we are going to shuffle whatever these clips are. So if I have 5 or 6 clips in here, I want to play them randomly. And so I want to basically populate a queue with a random list of these clips. And I'm just going to, whenever I want to get the next music clip, I'm just going to pop one off the queue. I'm going to dequeue it. So initially, if there's nothing in the queue, I'm going to shuffle the track queue. So all I'm going to do is I'm going to go through all my audio clips. I'm going to get them in random order by a random value. So audio clips order by random.value. I'm going to iterate through each one of them and add them to our queue. So this is going to build a queue of random clips from our audio clips array. Get next clip is just going to get one off the queue. And then when that queue is empty, we're going to repeat the process, shuffle the queue again. Pretty simple stuff. So now let's look at our music mixes. So again, a scriptable object. This time it's going to put it in music mix, not music clip groups. And we have two serialized fields. We have whatever audio mixer group this mix is associated with, and an audio mixer snapshot. So this is going to allow us to basically swap between two different snapshots. So we have a track A and a track B snapshot that we want to smoothly crossfade between. So this guy has an initialize method. So when we initialize this music mix, we are going to basically create a new audio source for this guy. And we're going to give him a name, which is going to be whatever this guy was called. And we are going to set his parent to be the music manager. So these guys are going to live underneath the music manager. And then I'm going to add the audio source component to this game object. We're going to set its loop to true, play on awake to false. We don't want any spatial blend. And we want to just set the volume of this guy to max, to 1. And then we want to set the audio output, audio mixer group for this guy to be whatever mixer group we assigned in the inspector. The play clip method is going to take the clip, assign it to this audio source, and tell the audio source to play. And then we're going to tell the audio mixer snapshot to transition. And we want to do it in 1 second. The stop is just going to tell the audio source to stop. All right. So when we want to play a clip from this mix, we're going to basically transition to this snapshot play the clip that was passed in. So let's jump back out into our Music Manager, and you can see all of these compilation errors have gone away. So now we should be able to jump out into the Unity editor and select our Music Manager and drag in from our managers folder that Music Manager script. And we want to build our music clip groups and our music mixes. Let's start with our music mixes. All right, so what we're going to do is we're going to go into music mixes. We're going to right click, create, and you're going to see under Asteroids tutorial, music mix. So we're going to create that one, track A, and then we're going to duplicate it and rename it to track B. Now the audio mixer snapshot for track A, let's go ahead and make this a detail view. We want snapshot A, and then the one for track B will be snapshot B. Now we need to create our mixer groups. So let's go up here and go into music clip groups. We're going to right click, create Asteroids tutorial music clip group. And we want to call one game. And let's just go ahead and duplicate this twice. One of them we're going to call game over. And the other we're going to call menu. So let's work on game first, since we're currently testing the game scene. We haven't even created the menu scene yet or handling the game over state. So this group name is going to be game. And then for our audio clips, I had downloaded some clips from Fat Frong Studio. I want this one here and this one here and this one here. So that will give us 3 clips that we can shuffle between when we're playing the game. And while we're in here, let's just go ahead and flesh out the music clip groups for game over. And we're going to use interstellar echoes for that one. Oh, it's Fat Frog. Here we go. Interstellar echoes. Supernova Symphony. And this one will be called Game Over. And we go into menu. We'll call this one menu. And we're going to use a few different clips for the menu mixer group. There's one called Zephyr. And then there's 4 of them that start with the word Atmos. They're basically atmosphere. So I want 1, 2, 3, and 4. Oh, I need to come in here to my music clip group. Let me unselect that. Pick my menu, lock that in the inspector, then go search for my atmosphere clips, select them. Actually, I don't want 2. I want 1, 3, 4, and 5, along with the Zephyr. There, so now our music clip groups are set up. We can test this all right now. For this test, I want to disable the PlayerDirector. And I want to unlock this in the inspector. So I want to disable our PlayerDirector and I want to disable our Asteroid spawner. So now if we hit play and I expand this Don't Destroy Unload managers, I select our music manager. If I right click on it, I can say play game music. And you can see this isn't working because I have not dragged in our music clip groups and so forth. So let's go down to our resources, managers, select our music manager, and then we want our music clip groups and our music mixes. So I'm going to lock this in the inspector, I'm going to go up here to music clip groups. I'm going to drag all 3 of these into our music clip groups. And then I'm going to go into our music mixes, and I'm going to drag both of these into there. And I'm going to unlock this, go back out to our scene hierarchy, hit play, select our music manager, right click, play game music. And if I hit it again, it crossfaded to a different track. And actually, it looks like the snapshots did not work correctly because it's still playing 2 different tracks. So what I think happened is one of these guys is not looking at the correct output. So let me go look at those snapshots. Okay, I did not give these a mixer group. So again, I forgot to assign some things in the inspector. So what I'm going to do here is I'm going to pick that music group and that music group. All right, let's go ahead and try this one more time. And I want to select our audio mixer here so we can see what's going on. Expand our managers, pick the music manager, right click, play game music. You see it crossfaded that one up. Let's try that again. Play game music. You can see it did a fade between the 2. Let's try playing the menu music. All right, so it looks like our music manager is working. The next thing we're going to want to do is actually get the music manager playing the appropriate music at the right parts of the game. So right now, the only thing we can really do as far as music goes is have it play game music when we spawn the player ship. So we're going to want to go into our game manager. So I'll go down here to resources, managers. Actually, our game manager is in the game scene under game manager. We're going to double click that, open it up, and find where we spawn the player ship. Now, when we implement the player death, we're going to want to go ahead and do this. So I guess we can go ahead and uncomment that. Same thing when the game is over. So I just want to have a setting for that. Here we go. So when we spawn the player ship, we want to start playing game music. All right, so let's go ahead and give that a test. Well, actually, before we do that, I want to go look at our to-dos and say, what to-dos do we still have left? So in the Asteroid class, let's see what this one is. Oh yeah, we want to adjust the speed of our asteroids based on the current round. So we can go ahead and uncomment that. And that's all we can do for now. I think the next thing we will implement is scoring. But first of all, let's go ahead and test this and make sure that it starts playing game music when we spawn the player ship. Well, I need to re-enable the PlayerDirector. and the asteroid spawner. All right. It's starting to feel like a game. So we want to be able to start racking up points as we shoot asteroids and then later on the little ships. Let's go into our scripts and we'll look at our asteroid script. And you can see we've got commented out here this scorable interface. Okay, now what we're going to want to do is, first of all, create that interface. And then we're going to want to implement the method from that interface on this class, actually on anything that can score points, but for now it's just going to be on the asteroid. So I'm going to come down here and paste at the bottom of our file, public interface iScorable, and it has a single public property called point value. And what we're going to do is we're going to move this into its own file, add it to source control. And let's jump back out into our asteroid script, and we're going to want to actually implement that property. So it's going to be very, very simple. Up here with all of our public stuff, right after audio settings, let's just add public int point value. And it looks like we already have that on our class. So where do we have a point value? So okay, we actually had already put that property on there, even though we didn't actually have the interface defined. So we are implementing that property here, and all we're doing is returning the points from our settings, which, as you remember, are in asteroid settings. And we have different settings for large, medium, and small asteroids. Now, if we go up to our PlayerShip, right now we have a PlayerShip script, but we actually want to add another script called scorer. So I'm going to come in here, I'm going to right click, create C# script, and call it scorer. Now I could very easily have actually put this logic inside the PlayerShip itself, but as you remember, I wanted the PlayerShip to basically just be an actor that takes directions, and I wanted to handle scoring separately. And then if there's something else in the game that can score points, we can just drop this script on it and it will work. So we're going to take our PlayerShip and we're going to drop that scorer script on there and double click to open it up. And then we're going to paste in this code. So all the scorer does is, if this score points function is called and we're being passed in a collision, we're going to check to see if that thing that collided with us has an iScorable interface, if it implements that interface. And if it does, then we're going to tell the GameManager to add the number of points from that scorable.point value. So that's all that we need for there. And currently this is not being called anywhere. And so if we go back and look at our to-dos, and you have this PlayerShip to-do implement scorer. So what we can do here is when we collide with something, we can basically check to see if we have a scorer and then tell the scorer to score points. So what I'm going to do here is in our awake method, where we're getting our renderer, our collider, rigid body, ghost parent, we also want to get our scorer. And we'll go ahead and create that variable. And that should be all that we need to start racking up points. Now currently we don't have a UI, so we don't show how many points we've scored. But what we can do is in the add points function, we can actually just log out when we get points. So here you can see we're adding the points to our score. We're checking to see if it's greater than our high score. What we can do is we can say debug log, and we're going to use string interpolation, and we're going to say score high score. Okay. And this should log out every time we add points. But this is only going to score points when the player ship collides with an asteroid, which is actually when we're destroyed. If we want to actually score points when we shoot asteroids, we want to add this to the BulletBase. We're going to find our BulletBase. So right here, where we call destroy bullet, we also want to check to see if we have a scorer. And if we do, we want to call score points. So we're going to have to do just like we did with the player ship. In awake, we want to go ahead and get our score. And then when we collide with something, we're going to check and see if we have a score. And if we do, we're going to call score points for whatever it was we collided with. So now if we jump back out into Unity and go to our console, and I'm going to maximize this just a little bit. And I'm going to hit play. And our console is probably going to be spammed with a bunch of stuff. So I've typed score into here. And so you can see it showed our score. And we're not scoring any points. Now, why do you think that is? Well, if we go into our prefabs and we look at player bullet, what's missing from this prefab? If you said the scorer script, you are correct. So I'm going to go into player and I'm going to drag this scorer script onto the BulletBase. I'm going to hit play again and then go back to our console. I had to click in the window so it would receive my input. You can see those points racking up in the log. All right, so we've got the player ship scoring points. So you can see that we are scoring points as we shoot things. So the very next thing we want to do is we want to implement our UI. We want to display the score, the high score. We want to display the number of lives we have left. And when the game is over, we're going to want to display the fact that the game is over and tell the player that they can press a key to play again. So we want to start working on our UI. But before we do that, I want to clean up some of these logs that we're logging all over the place. In particular, we don't want to be logging the score out anymore. So I'll go ahead and delete that. And then where it keeps telling us that it spawned an asteroid, we don't really need to spam our console with that anymore. So let's go back out into the editor and we're going to start working on our UI. So we're going to start with a canvas. So right click, UI, canvas, and we're going to call this --UI --, and I'm going to move it up under the spawners just above the ghost. And we want to change this to be scale with screen size with a reference resolution of 1920 by 1080. So full HD. And go ahead and collapse all of that. And we want to create a scored text mesh pro. So I'm going to right click over here. I'm going to go down to UI text mesh pro. And we want to call this score text. And I'm just going to type in 99999. And we're going to want to use our arcade font. And I want it to, I think 36 is a good size. I want this to be centered. And I want to use cap line. And I don't want it to wrap. All right. Now the score, we're going to anchor it to the upper right. So Alt, holding down the Alt key, I'm going to click up here, upper right, and you can see it put it right up there. And actually, I don't want that to be centered. If I go back down here and look at our Text Mesh Pro, I want that to be right justified. And looking at it in our scene view, I want to just drag it a little bit away from the edge like that. I think that looks pretty good. Now we're going to create another one called high scored text. And we're going to anchor that to the top center. Once again, we're going to want to use the arcade font. But this one I only want to make a font size of 30. I want it to be a little bit smaller. And we'll go ahead and put in the 99999 and move it down just a tad like that. And this I do want to be centered using cap line. Actually, so I'll move it up a little bit more. Yeah, I think that looks pretty good. Okay, so did I say disabled? I did not. So we don't want it to wrap. All right, so I think that's all we really need for our basic UI. We need to start writing a script for it. So in our project scripts UI folder, we're going to create a new script and we're going to call it game UI. And let's paste in this code and take a look at what we got here. A lot of code. Some of this we're going to comment out. And we're going to say to do uncomment when settings is implemented. We're not going to be doing this show again prompt timer yet. We're also not going to be doing our player lives just yet, but we'll go ahead and leave that in there. So we definitely want to subscribe to a scored changed event, and we're going to want to subscribe to player lives changed, and we'll temporarily comment this out. Same thing here. So basically what this timer here is for is when the game is over, we're going to initially just say game over. And then after a certain delay, we're going to pop up the prompt to say press any key to play again. But for now, we can create the timer, but we're not even going to be using it really. For instance, right now the player can't even die, so we're never going to get to this game over state. In our on-game state changed event, we don't need to worry about game over yet because we're not able to get to that state. But we do want to just have this here for when that stuff does get implemented. Delete this extra line. I'm going to comment out all the settings stuff with our little to-do. And I might as well comment out the resume game. Put our to-do in front of it. So we do want a scored changed event, and we are going to go ahead and create this event. So I think that's good to get these compilation errors out of the way. So do we have our event bus open? We don't. So I'm going to hit Control, comma, and type in event bus. And so what were the two events we wanted? We wanted scored changed event, player lives changed event. So down here at the bottom, we're going to say public struct score changed event. And let me go ahead and copy that code. And we'll move that to its own file. Add it to source control. And I'm going to come back in here. And we also want the player lives changed event. Move that to its own file. Okay, so if we jump back out into the game manager, we want to fire that score changed event whenever we add points. Okay, so going back out into our game UI, you can see that we have these serialized fields here. So we're going to drag in our text mesh pro fields for score text and high score text. We haven't created the other fields yet, so we don't need to worry about them just yet. And on enable, we're going to go ahead and subscribe to these events. And then when we receive those events, we're going to call update score. And update score is just going to update the text properties of those text mesh pro fields with the score and the high score that were passed in by that event. And later on, we're going to add our player lives, which are going to be visual representations of the player's ship. And there's going to be a transform up there with a horizontal layout group that's going to display one ship for every player life that the player has. And so basically all we're doing is iterating through all the children of that transform and setting them active if the index into that collection is less than the number of lives we have. So we'll get to that after we get the score working, but let's jump out into Unity. And we're going to pick our UI here. And we need to drag in our game UI script. And you can see we've got all these serialized fields here. So what we want to do is in our score text, we want to drag in that score text mesh pro. And in our high score text, we want to drag in the high score text mesh pro. And I just want to make sure where we're updating the player lives, we don't actually want to do this yet because this transform doesn't even live. I mean, it doesn't exist. We haven't put anything in there yet. So I'm just going to go ahead and comment this line out. Actually, I'm just going to comment out the body of this. And I'm going to say uncomment when player lives are implemented. Let me just go through here, make sure there's nothing. Okay, we don't have this. So I notice it's a little bit tedious. I basically don't want to dereference anything that doesn't exist. I don't want to break our game by having a null reference exception. All right, so I think all of that looks good for now. Let's jump back out into Unity. And we're going to hit play. We should see our score initially be 0. It is. Our ship spawns in. And you can see our score is incrementing on the UI. Okay, so I hope you can see how using that event bus really allows us to very easily decouple our components. So all I have to do is subscribe to the score changed event, and then whenever the score changes, we can update our text with the current score that's passed in from that event. We don't care who fired the event. This is the mediator pattern in action, and it just makes it really clean and easy to wire things up without them even knowing about each other. So the next thing we're going to do is implement the player lives so we can see how many ships the player has left. So let's jump back over into Unity. And in our UI, we're going to create an empty game object, and we're going to call this lives. And we're going to anchor this to the upper left. And we're going to add to it a horizontal layout group. All right. Now, one of the things I want to do is I want to basically drag in that fighter image that we're using for our player ship. I'm going to drag it in here as a child of this guy, And then we're going to just duplicate it so there's enough of them to go all the way across the screen. And then we're going to disable all of them. And the game UI is going to enable the ones that should be visible based on the number of player lives that we have. So let's go into our 2D space kit and ships and stations. So we got this fighter 1 right here. I want to create under here a UI image. And then we're going to drag in that fighter 1 right there. Now that's way too big. And so I think what I want to do in here is set his size to be something like that. All right. I'm going to go ahead and duplicate this a bunch of times. Way more times than we actually probably need to, because I don't think anybody's ever going to get that many extra lives. But we're just going to go to the edge of the screen. And I'm going to select all of them, and I'm going to rename them to Player Life. Like so. And then we're going to disable all of them. Now go back into our script here. And here where it says Player Lives Parent, we're going to drag this guy right there. And then we can go into our game UI text, and we can go ahead and look for all those places that we had disabled that was related to the player lives. Right here. All right, so hopefully when we play the game, it should initially have 3 player lives, and it might immediately change to 2 when we spawn a player ship. Let's go see what happens. Yep, we got 3 player lives. Now, if we can actually handle player death, then we would see it go down when we lost a ship. So we're not dying. All right, so I think that would be the thing to implement next is player death. Okay, I noticed over here in the console that I'm getting some null reference exceptions in the game UI. And it's complaining about this play again text. I had commented out some places where I had not yet added these things, but I obviously didn't comment out everything. Now I could go ahead and comment that out, but I think I'm just going to go ahead and add these things. Even though we might not completely implement them now, I just want to go ahead and get them in there. So switching back over here into our editor, we're going to add a text mesh pro field. And I'm going to call this one play again text. And the text will be press space to play again. And I want to use the electronic highway sign, a font size of 24, centered, cap line, no wrapping. And I want it to be anchored to the center. Let me go ahead and zoom out here a little bit into our scene view. And let's just drag that down a little bit. And it obviously is not quite centered. There we go. Centered and cap line. All right, so now I want to create another one. UI Text Mesh Pro. And this will be game over text. I'm actually going to move that up above there. The text will be game over. We're going to use our arcade font. And I want the font size to be 128. And centered, cap line, no wrapping. Yeah, I like that. I'm going to move this one up just a little bit. Okay, and I'm just going to temporarily disable those. And we're going to want to add a button up in the upper right corner here. And that is going to be our settings button. So actually, I think what I'm going to do is I'm going to go look for, yes, I want this image here. So I want to create under here a UI image, and I'm going to call this settings button. And then I'm going to drag that sprite into it, and I'm going to anchor it to the upper right, and I'm just going to move it down a tad. All right, and then I'm going to say add component button. And then we are also going to add our own script to it called UI button, but I'm going to do that later. Now, in our UI element here, for our game UI script, we've got these fields here. So we have one for game over text and one for play again text. So I'm going to take our game over text and drag that there. I'm going to take our play again text and drag that there. And then jump into our script. And I can get rid of this comment here. Oh, I have not created that script yet. That's why. So go ahead and put all that back. Okay, so don't have that implemented yet, but I can go ahead and get rid of that. Go ahead and get rid of that. Go ahead and get rid of that. Don't have this yet. I need to create a settings scene closed event. All right, got rid of that compilation error. And go ahead and uncomment that. Okay, so we got everything except loading our settings scene when the settings button is clicked, which we have not implemented that yet. And when we create our UI button script, which I can drag and drop on any button I want, we'll uncomment that out. But let's go back out into Unity and see if we can get this to work without a null reference exception. Yep, the errors are gone. So the next thing is to get our PlayerShip damaged or destroyed when we run into something. So we need to look at our PlayerShip and figure out why it is that we're currently not getting destroyed. We have our iCollision parent, we have this collided method here. Can you think of why our PlayerShip is not being destroyed when we flew into the asteroids? Now that you've had a few seconds to think about that, what might we be missing? Well, I'll tell you. We're missing the on-collision 2D callback. So I have our Unity callbacks down here. I have awake, I have fixed update. I'm going to add one down here. On collision, enter 2D. And all we want to do here is call our collided method and pass in that other parameter. All right, so let's go try this again and see if our ship does not get destroyed when we fly into the asteroids. I'm going to maximize, or not maximize, but I'm going to resize our game view here to be a little bit bigger. It looks like it got destroyed, but I thought I saw multiple explosions, and our number of lives did not go down. At least not up in the UI. Yeah, so we are getting destroyed, and it is respawning. but we're not decrementing our player lives, and it looks like we have an infinite number of lives there. So if we jump back into our player ship and we go down to here, when we collide with something, we are telling the game manager that the player died. And if we go look at that, you can see that we're stopping the music. We're checking to see if we have any lives left. If we do, we want to set the game state to player died and then start the spawn ship timer. Now we know that that's eventually going to spawn another ship. So if we go down to spawn ship, you can see here that we had not yet implemented this raising of a player lives changed event where we decrement the number of lives. And we didn't do that because the UI was not implemented. So let's go ahead and uncomment this. And that should, every time we spawn a ship, decrement the number of lives. And that should update our UI. And it should also make it so that when we are out of lives, the game manager, instead of spawning another ship, we'll call game over. Okay, game over is going to set the game state to game over. It's going to play the game over music, and then once we implement our settings, it's actually going to save the high score so that can be persistent between games. Let's just try this out and see. First of all, we should only see 2 ships up here after it spawns our ship. We should see 3, and then we should see 2 after it spawns. And then when the player dies, it should go down to 1. And then when he dies again, we should have none left. And then if we die again, it should show the game over prompt. So we have 3 ships. We now have 2. Boom, we die. We respawn, we have 1 ship. We will respawn, we have no ships. Boom, we die. And nothing happens. Alright, so at least we got handling the player lives decrementing every time we spawn a new ship. So I am 99% sure that it was actually working perfectly, but our text items here are disabled here. And if we go into our game UI script, what we are doing is we are enabling the text mesh pro object with the enabled. We're not doing a game object that's set active. We're just enabling or disabling the text mesh pro field. So what we want to do is we want the game objects to be enabled, but we are going to disable the text mesh pro fields here with the enabled property. So if we go back out and try this again, now that I've turned them on, those text fields should be hidden. All right, and we will fly around and get killed. And there's our game over. And then after a delay, we get the press space to play again. If I hit space, the one thing I notice is that our alpha is not being set correctly when we are invulnerable. And for some reason, our player ship is getting killed when it doesn't seem like it should be. So we have a few things to diagnose there. So I think I know what's going on with this invulnerability stuff. If we look at our player ship, we know that if we set its color alpha, you can see it fade out over there in the game view. We know that that should work, and I'm pretty sure that that code is all fine. I think the problem, if we go and look at the script for our player ship, where we set it to be invulnerable, we're checking to see if the collider is enabled or not, and if it's already not enabled, I just return. But it's possible I could call this function when the collider is disabled. in which case we wouldn't do any of this. And I'm going to do the same thing here. I'm just going to get rid of that because this is all controlled by the PlayerDirector anyway. And so if we go and look at our PlayerDirector where we say if enable invulnerability, we're already saying if we are already invulnerable, just return. And then we set is invulnerable to true, but down here where we cancel the invulnerability, we're checking to see if we're not invulnerable, return, but we're not setting is invulnerable to false. So with those changes, let's jump back out into our game, into Unity, and play it and see if the invulnerability doesn't work. We should show up with 25% of our alpha, so the ship will look kind of faded out. And then as soon as we press some controls, or after 3 seconds, yeah, so now we're at full opacity because I moved. Let's go ahead and die. We're going to spawn initially and be invulnerable. And you can see that we're faded out, but we became vulnerable before the asteroid finished passing over us. And so now we're vulnerable again and we are at full opacity. And I'm not sure what the issue was with our ship. It seemed like our ship was getting hit and dying when it shouldn't have. If I see that again, we'll dig into that a little bit deeper. But for now, I think I'm ready to move on. We know the game over works. If I go ahead and hit space, we can play again. I come in, I'm invulnerable. Now I'm not invulnerable. So all of that stuff seems to be working. I think the next thing to make this Asteroids is to have the enemy ships come in and shoot at the player ship. So for our enemy ships, we're actually going to have 2 different types of enemy ships. We're going to have a slow one and a fast one. And we're going to create an empty game object here. And I'm just going to call this slow enemy ship. And then underneath of this, we're going to create a 2D object sprite square. All right. And then we're going to go into our 2D space kit. And we're going to look at our ships, and we're going to take this Fighter 3 sprite and drag that right into there. And I want to make sure I put all of this on the enemy layer, including all of its children. All right. And I'm going to want to scale this guy up by 2. And just, I'm going to temporarily disable the player just so we can see that guy. And I also want to initially make sure that we spawn this guy off the screen. All right. And I want to rotate this ship 270 degrees on this axis. So if we select this here in the scene view, this is what it looks like now. So he's going to fly either from left to right or right to left. And there is a flag on this sprite that we can toggle if we want to flip it right or left. And we're actually going to do that in code depending on what direction the ship is going. And we need to add a rigid body 2D to this guy. And as always, we want to make sure that we get rid of any drag, linear drag, and gravity on this guy. And we're going to control everything through code, so we want to freeze its position and rotation on all axes. Now on the sprite here, which I'm actually going to put the collider on the sprite and not up on the parent, because we're going to use the polygon collider 2D. And that looks pretty good. And we want to add an audio source to this parent object here. We want to make sure that this guy goes to the sound effects mix. And for the audio clip that we're going to use Saucer Big, which we got from those asteroid sounds that we had downloaded. We want it to play on awake, and we want it to loop, and I'm going to set the volume to be 25%. All right. So this will play on a constant loop. And now the next thing we need to do is create a script, and we're actually going to use some inheritance for this guy. So the reason is we're going to have a method that can be overwritten that's going to determine the direction of fire for this ship. So this slow ship is going to fire in a totally random direction, but the fast ship is going to actually aim at the player. And so everything's going to be the same, but the fast ship script is going to inherit from this base class script, and it's just going to override that get fire direction method. But in our scripts folder, I'm going to right click here and I'm going to say create C# script, and I'm just going to call this enemy ship. And we're going to select our slow enemy ship up here and drag that script onto it. And then we're going to double click this to open it up in our code editor. And we're going to select everything and paste in this code. So let's take a look at this script. So we have this class enemy ship. It's telling us, hey, you've got some virtual members, but you haven't inherited anything from it. We'll fix that in a minute. So we have a number of serialized fields. We have a prefab for the bullet. So we're going to create a new enemy bullet prefab. We have our sprite renderer, and we have the speed for this ship and the initial fire delay and then a subsequent fire delay. So this is how long it will take before it fires the first shot, and this is going to be the amount of delay in between each subsequent shot. And then this is how many points this ship is worth when the player shoots it. The point value is basically this variable returned publicly through this expression body method. Now, the way we're going to control the movement of this ship is we're going to have a series of waypoints, which we're going to define out in the scene. And when we initialize this guy, we're going to randomly pick waypoints from those available waypoints. So he'll start off at a random spawn point. And depending on whether he's on the left side of the screen or the right side of the screen, he's going to move either left to right or right to left through a series of waypoints that we're going to get randomly and populate in this array here. And this is basically our index into that array. And then we have a layer mask. We want to see if we collide it with the waypoint. And then we're also going to need a reference to the enemy spawner, which does not exist yet. To satisfy this, though, actually I'm going to go back into Unity. And I'm going to go into our spawners folder here. And I'm going to create a C# script, and I'm going to call it enemy ship spawner. And we'll flesh that out later, but in the meantime, let's just go back into our enemy ship here, and that should satisfy that compilation error. We're going to use an object pool for our bullets, and we want to have a Boolean that says whether or not we're eligible to despawn this ship. And then we're going to have a timer, which is our fire timer. So in the awake method, we want to go ahead and cache the waypoint layer using this name to layer method that is on the layer mask. So we want to initialize our object pool for our bullets. We're going to have a callback for instantiate bullet on get bullet on release bullet on destroy bullet. We want it to maintain the collection. The initial size is 5 and our maximum size is 10. Our public init method that the spawner is going to call when we initialize this ship will give it a reference back to the spawner, the start position, and the waypoints that this ship should follow as it traverses the screen. And we just save these off to our variables here. We set our transform's position to be whatever the start position we pass in is. We set whether or not we're flipped that sprite based on whether we're to the right of the screen or the left of the screen. So we only want to flip on the Y direction if we're going right to left, which means we're to the right of the screen. We're going to set our eligible for despawn to false. We're going to create our fire timer. We're going to set this game object to true, and then we're going to start the initial fire delay timer. When this guy is disabled, we're going to release that fire timer to the pool. In any update method, we want to check and see if we should despawn. Now this, basically, if this guy goes off the end of the screen, we want to say that he's eligible for despawn and we want to get rid of him, which means he made it to the end of the screen without being hit, without running into anything, and we just want to despawn him. And otherwise, we're going to move the ship. So we have our on trigger enter 2D. So this is similar to on collision enter, but this is basically going to be handled by anything it collides with that has is trigger set on the collider. So our waypoint colliders are not going to interact with physics, but they are going to have is trigger set to true. So if the ship enters that trigger radius, we're going to get called on this function here. And we're just going to make sure that the layer of the thing we collided with is on the waypoint layer. If it's not, we're just going to return. And then we want to check our waypoint index to see have we gone past all of the waypoints already? And if we have, we just want to return. Otherwise, we want to increment our waypoint index. So our move method, our move ship is basically going to start moving toward that next waypoint in our array. And we want to set eligible for despawn to be true. So the reason we do this here is because initially when this guy spawns, he's going to be off the screen, and we don't want to initially despawn him. We want to set this to be true after he's actually reached a waypoint. So now we know if he goes off screen after that, yeah, get rid of him. On collision enter 2D, this is if we actually collide with something like an asteroid or a player bullet or an enemy bullet. We want to spawn an explosion at that position, and we want to tell the spawner to despawn enemy ship. And I'm just going to go ahead have it create a method on that class. We'll implement that later. Create fire timer. We basically instantiate a countdown timer and we subscribe to its on timer stop. That's going to call our fire method. The release fire timer unsubscribes from that on timer stop event and then releases that timer to the pool. Our fire method is going to play the fire clip prefab sound effect clip using our sound effects manager. We're going to get a bullet from the pool, which is either going to instantiate a new one or get one that's already been used and recycled. We want to set that bullet's parent to be our spawner's parent. So all of these guys are going to be populated underneath of our bullet spawner, or actually the enemy ship spawner. So we're not cluttering up our scene hierarchy. We're going to set its position to be our position. So the bullet's going to originate at our position. We're going to get the fire direction for this bullet. And so for the slow ship, it's just going to be a random direction. And we're going to override that in the fast ship script to aim at the player. And then we want to basically start our fire timer to use the subsequent fire delay. Move ship basically checks our waypoints and then checks to see what position that waypoint is and move towards that position. So we're going to move from our position to that waypoint position, and we're going to use this ship's speed times time.delta time. So every frame, we're going to move from our current position to whatever the waypoint position is using our speed, and it's going to be using time.delta time, so it's smooth regardless of frame rate. Check for despawn basically says, are we eligible for despawn? So have we actually moved to a waypoint? And then are we off the screen? So if we're either not eligible or we're on the screen, just return and don't do anything. Otherwise, we want to tell the spawner to despawn this ship because we've moved off the screen. These are all our bullet pool functions. I just put them in a region so we can collapse this like so. We can instantiate a bullet, and we can subscribe to its bullet destroyed method. We can get a bullet from the pool and initially set it to be inactive. We can release a button to the pool, making sure that we set its parent to null and then set it to deactive. So this way it will have that don't destroy on load because it's not under any parent. And then destroy bullet We'll basically set the parent to null, unsubscribe from the bullet destroyed event, and then destroy this bullet. And an on bullet destroyed, which is what we get called back from that event that we subscribe to on the bullet, will basically just set the bullet to inactive and release it back to the pool. So that's it for the enemy ship base class. Now we do want to go ahead and implement our fast enemy ship. So I'm going to come down here to the bottom of the file, paste in this fast enemy ship code, move it to its own file, add it to source control. So this just overrides our get fire direction. We basically ask the game manager, hey, give us the player ship. If for whatever reason that's null, we're just going to call the base class method that's going to give us a random direction. I don't think that should ever happen, but we just want to be safe here. We're going to calculate the direction from our current position to the player's position. And the way you do that is you subtract our position from that destination position, and we're going to normalize it. And then we're going to get the vector 3 for that angle by using the quaternion.look rotation, using our forward axis and that direction, and using the Euler angles property from that quaternion. So this gives us a quaternion, and this gives us the vector 3, which is the Euler angles for that angle. And everything else is going to be the same. So let's jump back out into Unity. And we should see some serialized fields show up here on our enemy ship. All right, and so for the bullet prefab, we actually need to create an enemy bullet prefab. But for our sprite renderer, we're just going to drag that sprite right here. So that's our child. This is all good for the slow enemy ship. We have our speed, our initial fire delay, our subsequent fire delay, and the slow one is worth 50 points. We don't have any waypoints yet. But what I'm going to go ahead and do is I'm going to go ahead and drag this into our prefabs folder. All right. And then I'm going to duplicate this. But first I want to unpack this prefab. Then I want to duplicate this, and I want to rename it to be fast enemy ship. All right. And we're actually going to remove this script because we're going to use the fast enemy ship. So we go under our scripts folder, find that fast enemy ship script, drag that on there, and then we're going to drag our sprite down to there. Going to go ahead and delete this from the hierarchy. Now these parameters are going to be different for the fast enemy ship. We want our speed. I just realized that speed for that slow enemy ship is not right. I want the slow enemy ship speed to be 2. That would have been an incredibly fast ship. So we're going to set that to 2. And we actually want the point value for the slow enemy ship to be 200 points. All right, sorry for the confusion. For the fast enemy ship, his speed's going to be 3. His initial fire delay is going to be 1.5 seconds. And his subsequent fire delay is going to be 1.5 seconds. And I just realized I changed the speed by mistake. And then his point value is going to be 1,000. Okay, yeah, those numbers make a whole lot more sense. So we'll go ahead and drag this into our prefabs folder and delete it from our hierarchy. So the next thing we want to do is we want to create the enemy bullet prefab. And that's going to be pretty simple. We're going to copy our player bullet prefab. We're going to drag it into the scene. We're going to unpack that prefab. We're going to rename this to be enemy bullet. We're going to put it on the enemy bullet layer. And the sprite renderer is going to be the same, but I'm going to change its color just a little bit. Something like that, maybe. All right, and then the parameters on our script, we want them to only last 1 second. And we don't want it to have a scorer script because the enemy ship does not score any points. And so we are going to drag that into our prefabs folder. Let's select our fast enemy ship prefab, and we're going to drag that enemy bullet into here, and then select our slow enemy ship prefab and drag that enemy bullet into there. So that finishes out the prefabs for our enemy ships. The next thing to do is to create our spawn points and our waypoints. So under spawners, we're going to create a new empty game object here. And we're going to call this enemy ship spawner. And I'm going to drag that up above the other spawners. Actually, I'm going to drag it under the asteroid spawner. And I'm going to create 2 more empty game objects under here. I'm going to create one and call it spawn points. And I'm going to create another one and call it waypoints. All right. Now for our spawn points here, I'm going to go ahead and put that on the spawn point layer. We're going to actually add some sprites underneath of this. So I'm going to go just right click here and say 2D object sprites circle. All right. And then I'm going to set its position to be -10, 3.5. All right, and so that will be 1 spawn point. And I'm going to duplicate that 5 times. I'm going to go 1, 2, 3, 4, 5. All right. And so all these are -10. I'm going to set all of these to be 10. And that looks odd to me. That may be fine. I just expected that to look like it was off the screen. I might have to adjust those values on the right side. In the meantime, these 2 guys, I'm going to set at 0 on the y-axis. And these 2 guys, I'm going to set at -3.5 on the y-axis. So that gives us our spawn points, which should be on and off either side of the screen. And I'm going to select all of these, and I'm just going to call them spawn point. All right. And that's all we need for our spawn points. Now for our waypoints, we're also going to add 2D sprites circles. We're going to go ahead and create 3 of these. And these are all going to be at -5 on the x-axis. This one is going to be at 3.5. And this one's going to be at -3.5. Okay, and then we're going to duplicate both of them, or all 3 of them. And this one is going to go to 0 on the x-axis. Okay, I thought I had selected 3 of those. Let's see. I think this guy I want to move up here and here. So I'll take these 3 and put them at 0 on the x-axis. There we go. And then I will duplicate those. And I don't know why it rearranges these like that. So I will select all three of these, and I will put them at 5 on the x-axis. So those are our waypoints. So I'll select all of them and call it waypoint. Now all of those guys are going to get a circle collider 2D. Okay, and that collider is going to be set to isTrigger. And then all of those are going to get a rigid body 2D. And it's going to be set to kinematic. And then we want to put all of these on the waypoint layer. All right, and then what we can do is we can just remove the renderers. Because now that we see how they're laid out, we don't need those sprite renderers anymore. And we'll do the same thing for our spawn point. So now all we've got are transforms at the correct positions, and then transforms with colliders and rigid bodies for our waypoints. So we're going to want to add a script for our enemy ship spawner. We've already created the script. We just need to flesh it out. So we'll go into our scripts, spawners folder, and we'll drag that enemy ship spawner onto here. And then we will double click that to open it up in the editor. And I'm going to select everything and paste in all of this code. So let's go take a look at this. We're going to use our singleton mono behavior. So there will only ever be one instance of this. We have an array of enemy ship prefabs, which is going to use to spawn our enemy ships. And then we have 2 arrays of transforms, one for our spawn points, one for our waypoints. And then we have a serialized field for the initial spawn delay, the subsequent spawn delay, the minimum spawn delay, and then the spawn delay increment. So the enemy ships will spawn quicker and quicker and quicker to a minimum of at least 5 seconds. So the initial spawn delay is going to be 30 seconds, and we're basically going to adjust that so they get faster and faster each time a new ship spawns. Some private variables here. Initially, you only have a chance of spawning a slow ship. There's going to be a increment of our fast ship percentage that we will increment every time you spawn a ship, so you'll get more and more likely to get a fast ship as the game goes on. We want to save off what our current spawn delay is, whether or not in spawning is enabled. We initialize a list of waypoints, and then we have we basically want to save off our slow ship and our fast ship when we instantiate them, and then we have our spawn timer. So a public method here, despawn enemy ship. You remember this gets called by the enemy ship base to tell this guy to despawn him. And all we're doing is setting him to be inactive. So we're not really using an object pool or anything. We're going to instantiate one of each type of ship. And we're just going to keep it around in a local variable, or not a local variable, in a member variable here. And we're just going to reuse that ship over and over and over again. In our awake method, we call our base class, which basically sets up our instance variable. We subscribe to game state changed events. We set our fast ship percentage to be whatever our base is, which is initially 0. We set our spawn delay to be the subsequent spawn delay. This is a member variable we're going to use when we restart the timer. We instantiate a slow ship and a fast ship using those prefabs. We set the slow ships and fast ships parent to be us. So they're going to be parented to us. And then in start, we basically want to instantiate our spawn timer using our spawn delay. So when this class is disabled, we unsubscribe from the game state changed events. We release our timer to the pool. When we receive a game state changed event, we want to enable spawning if the game is not over. So that Boolean will be set based on whether or not the game is over. So enable spawning. If enable is true, if we weren't already enabling spawning, we want to basically unsubscribe and resubscribe to on timer stop. This just makes sure there's no duplicate subscriptions to that timer. And then we want to start the timer. Otherwise, if we were already spawning and now we're no longer spawning, we want to unsubscribe from that timer and stop the timer. And then we want to assign that variable to our enable spawning member variable. Spawn ship, if enable spawning is not true, we just return do nothing. Otherwise, we get a random spawn point from our array of spawn points. And then we get a random ship, and that's going to take into account our fast ship percentage. We're basically going to take a random value, and if that is less than the fast ship percentage, then we're going to basically get a fast ship. Otherwise, we're going to get a slow ship. We will initialize that ship using the spawn point at the spawn point index we got, and we want to give it a series of random waypoints. Starting with our spawn point index. We want to set our spawn delay, which is going to be we're going to take whatever's greater, the minimum spawn delay, or the spawn delay minus the spawn delay increment. So we're going to basically keep updating our spawn delay, decrementing our spawn delay increment, but never go below our minimum spawn delay. And then we want to start our timer using that spawn delay. The get random waypoints, we're basically going to clear our list of waypoints. We want to use for our vertical index, our spawn point index. And then if this is on the left side of the screen, then we want to start with the waypoints on the left and just basically get random ones and add them to our collection here. Otherwise, if we're starting on the right side of the screen, we want to go the other direction. We want to start with the waypoints on the right and work our way to the left. And then we convert that list to an array, and that's what we return as the waypoints we're going to initialize the enemy ship with. And then we just have an enumeration here for the type of enemy ship, slow or fast, which I'm not even sure I'm really using that enumeration for anything, but there it is. So let's jump back out into Unity. And looking at our enemy ship spawner, we've got all our serialized fields here. We got our initial spawn delay, our subsequent spawn delay, minimum spawn delay, and then the spawn delay increment. And then we've got these arrays here. We've got arrays for enemy ship prefabs, and our arrays for our spawn points and our waypoints. So for our ship prefabs, we want to do the slow prefab first. So in our prefabs here, we want to drag in our slow enemy ship. And then we want to drag in our fast enemy ship. And then for our spawn points, I'm going to lock this in the inspector. And I'm going to select all of these spawn points, and I'm just going to drag them right there. And I'll minimize that. And then for our waypoints, I'm going to pick all of our waypoints, and I'm going to drag that onto our waypoints. So our enemy ship spawner is all decked out here. And we can test this if I hit play. Let me unlock this in the inspector. Do I have a prefab sitting there already? That is interesting. I believe I know what's going on here. Our ship prefabs should be disabled by default. All right, so I'm going to pick our spawner here, and I'm going to right click and say spawn ship. right, let's try that again. Okay, so that seems to be working just the way we want it. Now, before we just assume this is all working correctly, I want to give this a good test. So one thing we can do is come in here and set our initial spawn delay to something like 5 seconds. And maybe we can disable our asteroid spawner. We do want to enable our PlayerDirector. And let's just start playing and let's see if it doesn't spawn an enemy ship after 5 seconds. And then I'll shoot it, try to shoot it, and see if we don't get 250 points for it. Oh, and there we go. Oh, 200 points. All right. Oh, here comes another one. Let's wait and see if he doesn't shoot at me. We should eventually get a fast ship. Oh, he killed me. The nerve. Boom, he killed me again. I'm hoping that's just random. You know what? That was a fast ship. And I got 1,000 points for him. I'm just using the wrong sprite. I'm glad I decided to test this. All right, let's fix that guy. If we go into our fast enemy ship spawner, we are definitely using the wrong sprite for him. We want to be using Fighter 2. And we're using Fighter 3. So let's change that to Fighter 2. And let's just double check his polygon collider. Just turn him on temporarily just so we can see him in the scene here. Look at his polygon collider. And that's too big for him. So I'm going to actually remove that collider and add him back. And that's much better. All right, so let's go out and we'll go ahead and try this again. Oh, I want to disable him initially. Okay. And I'll fast forward until I get a fast ship. I want to use a different sound for him though. So you want to keep moving if you're flying against the fast ship because he will hit you if you sit still. Alright, let's fix his sound. So if we go into our fast enemy ship prefab and expand our audio source, we want to use saucer small. Save that and try again. And that worked perfectly. All right. So now I think it's time to actually implement our settings manager, which we can use to save and load settings. We're going to go down into our resources folder, double click our managers object. And under here, we're going to create a new empty game object. And we're going to call it settings manager. And we're going to go into our scripts folder under our managers folder, and we're going to create a new script. And we're going to call it settings manager. And drag that onto the settings manager object. Double click that to open it up in our code editor. Select everything and paste in this code. So let's take a look at this script. It's going to be a singleton mono behavior. There is a public method to get a setting by key, and this will just give us the string value with a default value if that setting does not exist. And one of the things we're going to do is we're going to have a dictionary of settings here, which is just a key pair dictionary, which is going to have a settings key and a settings value. And we do this try-add on the dictionary so that if we didn't already have an entry in the dictionary, then we would go ahead and add one. And then we're going to return that setting. So when they first call and say, I want to get a setting value, they pass in the key and a default value. We'll try and add it to the dictionary with that default value, and then we're going to return whatever value is at that key in the dictionary. So hopefully that makes sense. We also have some type-specific versions of these calls for an integer and a float, which is just basically going to do the same thing, except we're going to parse it into whatever this type is. So we're either going to parse it into an int or parse it into a float. Conversely, we have the set setting methods. This optional parameter here is whether or not we're actually going to save these settings to player preferences. And I guess I should say we're using player preferences to save these settings. And I'll explain how player preferences are saved on different environments. But basically, this one's just going to save the string value. We're going to set it in the dictionary here, and then optionally call our save settings method that's going to write them out the player prefs. And then we have the generic set setting, which is going to be of type, whatever type this is. This might be an integer, it might be a float. And all we're going to do is take whatever this value is, convert it to a string, and then assign it to our dictionary, and then call save settings optionally based on this flag here. We have a settings key, which is going to be preference key. So when we actually save our settings, we're going to create a comma delimited string with all of our keys, and we're going to save that using this key, preference keys. So then when we load settings, so this gets called from awake. When we load our settings, we're first going to look up that settings key from player prefs, and we're going to split it into individual keys. So it's a comma delimited string. We read that, and then we split it using that comma delimiter into a bunch of individual keys. And then we iterate through all of those keys and look those individual keys up, and then we will add them to our dictionary. Save settings, we're going to use the string builder class so that we're not creating a bunch of garbage on the heap. And basically, we are going to iterate through all of our keys in our dictionary, and we're going to append them using the string builder. And if it's not the first one, we're going to prepend it with a comma. And then we are going to have player prefs set that individual key with their value from the dictionary into player prefs. And then at the end, we're just going to use the toString method on our string builder to write out the settings key. And then we're going to tell player prefs to save. Now we also want to raise an event. And the reason we're doing this is there may be some places where we want to know if settings were changed. And a good place to do that is where we call save settings. So I'm going to copy this here. I'm going to hit Control, comma, and go to Event Bus and open that up. Go to the bottom of our file, and I'm going to say public struct settings saved event, and I'm going to move that into its own file and add it to source control. All right, And so now if we come back into our settings manager, that compilation error goes away. And while we're in here, I want to come down here to the bottom of the file and paste in an audio settings class, which is going to be another singleton mono behavior. I'm going to go ahead and move this to its own file. All right, and add that to source control. And so let's look at this script. We're going to have a serialized field for an audio mixer, which we're going to assign in the inspector. There are 3 keys that we're going to use for settings. We're going to use this not only for the settings manager to load and save these settings, but we're also going to use them for our audio mixer to set those keys on the audio mixer. So you remember when we set up the audio mixer, we exposed some variables that we can access through code. Well, this is where we're going to access them. So we have load audio settings, which is going to go out and get these values from settings with default values of 1 each. So if we have not yet saved them to settings, they're just going to have a value of 1, which is the volume turned all the way up. And then save audio settings is just going to write them out to the settings manager. And then on the very last call, so we're going to set these 2, and then when we set the sound effects volume, we're actually going to tell it, save these out to player preferences. And as you recall, that will fire the event, the settings saved event, so anybody concerned with that can respond to it. So let's jump back out into Unity. And on this settings manager object, we've already added the settings manager script. We're also going to drag on that audio settings script. And then for our audio mixer, we want to pick main mix. So now this is good to go. If we were to run this, you would see under don't destroy on load, the managers node similar to this, and underneath of it would be our settings manager. But before we can actually use any of this, if you remember, we had a bunch of stuff commented out. Hopefully we put to-dos everywhere we did that. But for first pass, I'm just going to look at our to-dos and see where we commented out code that we wanted to uncomment when the settings was implemented. So let's look at this one. Implement settings manager. So this is in our game manager. So we can go ahead and get rid of this line and then uncomment this. So we're going to go out to our settings manager and load the high score from settings. Okay, under game UI, we want to have a UI button, which we're going to have to create that script. Here's another place. So we want to initialize our settings button, which again, we haven't written that script yet, but we'll go ahead and do that while we're in here. And this one, load settings scene. Now this one, we can't actually completely implement yet because we actually have to create our settings scene, which is what we're going to use to display the settings dialog. We're going to load a whole nother scene additively on whatever scene we're in, and it's going to have our settings dialog. So I'm going to add a little to do here. Yeah, that's good. And what else do we have here? Are there compilation errors in here? What is this complaining about? Oh, the UI button. So that's annoying me. So I'm going to go ahead and go out into Unity. And it's going to have to do a bunch of recompiling and stuff. But I want to go into our scripts UI folder. And I want to create a folder. I mean, a script, which I just realized I typed the wrong thing. Don't you love seeing how the sausage is made? Okay, create C# script UI button. Double click that, select everything, paste in this script. So we basically have a button, we have an event on button clicked action. We initialize the button, which is basically passing in the callback that we want to call when this button is clicked. In awake, we get that button and save it off to our variable here. In on enable, we subscribe to the on click handler, so that it will call our on button clicked function down here actually, and then on button clicked will call that callback that we got set in our init method. So now hopefully those compilation errors are cleared up. We're probably going to have to assign this in the inspector before we run this, or it's going to blow up. But I think that should solve all of those compilation errors. Do we have any to-dos left here? We do under Game UI, so we know about that one. Player keyboard input. So here is where we're going to load our key mappings. So basically, we're just going to go out to our settings manager and we're going to load the mappings for the rotate left, rotate right, thrust, fire, and hyperspace keys with default values that we've defined. You remember I had assigned those default values here in the inspector. We can probably get rid of these now since we're going to be loading them from settings. I'll just leave them there. Save key bindings is going to be the exact opposite. We are basically just going to write those bindings out to the settings manager. So now in on awake and on all our callbacks, on awake, on enable, on settings updated, and on disable, let's just go ahead and look at all this code. So when we awake, we want to load our key bindings. On enable, we want to subscribe to the settings saved event so that if we change the bindings, we'll know. On settings update, we're basically going to call load key binding. So if these bindings got changed, say in our new heretofore not yet implemented settings dialog, we want to reload our bindings so that they will take effect as we play the game. When we enable, we subscribe to that event. So we load the key binding. So on disable, we want to unsubscribe from that event. And that is pretty much it. So let's jump back down into Unity. And we're going to want to look at our game UI. And you can see it's got this little field here for the settings button. So we just drag that. Well, settings button is missing something. We need to drag our UI button script onto there. So now we should be able to drag that settings button right there. There we go. All right. So now, theoretically, when we play, it should load the keyboard settings and our audio settings, which right now are just going to be default values. And when we quit the game, I believe those settings may be saved. I can't remember if we're saving them or not. They might not get saved until we actually implement our settings dialog. So in the next segment of this video, we are going to go ahead and implement our new settings scene, which is going to display a settings dialog and allow the player to change these settings. Now I mentioned that we're using player preferences to save our settings. And so a little explanation of player preferences is in order. So player prefs is basically a class that stores player preferences between game sessions, and depending on what environment you're on, these preferences will be saved at different locations. Now in Windows, it's going to be saved in your registry. In WebGL, it's going to be using the IndexedDB in your browser, using the IndexedDB API. And there's some information about that if you wanted to look and understand how that works. And I can actually show you a little bit about how that would work. So for instance, if I run my prototype here in the browser, and then I open up the console here, you can see there's this IndexedDB, and the player prefs are stored in here. And you can drill into that and actually see how it's storing those things. But that's a little bit beyond the scope of this video. But you can look at this link here. I'll put a link in the description for this if you want to see where these preferences are stored for the different environments. Now I mentioned in Windows they're stored in the registry. So an example of that would be in my Asteroids tutorial prototype. Here's my preferences keys, which if we were to look at this, and this is just ASCII characters for that comma delimited string. And you can kind of see in here, high score, comma, rotate, left key, comma, rotate, right key, comma, and so forth. You can see how I have created that preferences key, comma, delimited string. And then for each individual preference value, there is a key value pair in the registry. So I think it's finally time to start working on our settings dialog, which we're actually going to put it into an entirely different scene. Now, if I'm going to be honest with you, this is probably my least favorite phase of development. It's just kind of tedious. I am a full stack developer in my day job, but I really prefer back-end work. Now, looking in our scenes folder, we've got 3 scenes. We've got the game scene, which is the one we've been working in. We have a menu scene, which actually I want to rename this to be Start Menu. And then we have a settings scene. And so the settings scene is where we are going to put our settings dialog, which is going to let the player edit the settings. And we're going to load this scene additively into either the start menu scene or the game scene, depending on which scene we're in when we click the settings button. This camera here is just temporary. I'm going to rename it because when we load this scene additively into either the game scene or the main menu scene, there's already going to be a camera. So we're not going to need this camera. But when we're working in this scene, if we want to see it rendered correctly, we do need a camera. What we're going to create first, though, is a canvas. So we're going to go UI canvas, and we'll just leave it named canvas. And for our canvas scaler, we're going to change it from constant to scale. And we're going to use the HD resolution as a reference resolution, so 1920 by 1080. Underneath of the canvas, I'm just going to drag this event system under here because we don't really need it, and it's just cluttering up my view. Under the canvas, we are going to create what I'm going to call a settings panel. It's actually going to be UI image, and then for our image, I'm going to just look up background. And here there is a sprite, which you can see comes from the Unity built-in extra under the resources folder. I'm just going to double click that. And for the color, I just want to make it a little bit of a darker gray, maybe something like that. I'm going to rename this to be settings panel. And that's going to be the panel that our form is going to be on. I do want to change the rect transform to be filled. So I'm going to say Alt and click on this fill button down here. But I want to give it some padding. So I'm going to give it some padding on the left, top, bottom, and right. So that's going to be our settings panel. At the top of the panel, we're going to create a Text Mesh Pro object. So under UI Text Mesh Pro, we're going to call this title text. The text will be settings. We're going to use our arcade font. We're going to set the point size to be 72. We want it to be centered, cap line with no wrapping. And go up to the rect transform, and we're going to hold down Alt and anchor it to the top of the screen. But then I'm going to take the arrow keys here and just drag that down to about there. Now I'm going to put all of our controls in an object which I'm going to call form. So under the settings panel, I'm going to right click and I'm going to create an empty object. I'm going to call it form. And we're going to give it a vertical layout group. And we're going to have to really play around with this group to get the padding, to get the alignment. We definitely want the alignment to be upper center for all the elements, but we're also going to want the children of this to use their own scale. We don't want to be changing the child's size from here. And we're going to play around with the spacing, but we're going to do that after we add our components. And this is going to take a little bit of trial and error, and it can be a little tedious. And this is actually one of the things that I find not so fun about game development. I'm going to start off by giving this an arbitrary size. I'm thinking something like 1060 by 554, something like that. And again, I might end up having to play around with this after we start adding some controls to it. The first thing I want to add is a group called keyboard controls. So I'm going to create an empty object. I'm going to call it keyboard controls. And this is going to have our keyboard mapping controls. And inside here, we want to create a Text Mesh Pro object, which I'm going to call key mappings text. And we're going to call it, well, we're not going to call it, the text inside of it is going to be key mappings. That is going to be the arcade font with a point size of 48. We want it to be centered, cap line with no wrapping. All right, I think that's good enough. Underneath of that, not as a child of that, but as a child of keyboard controls, which would be down below the key mappings text, I want to add another object, which I'm going to call key mappings. So create empty, key, if I can put my fingers on the right keys, key mappings. And again, we are going to add a vertical layout group to this. So a vertical layout group basically will attempt to arrange all the child items just grouped together, and it's going to arrange them vertically. Once again, I want this to be upper center. This time I'm going to leave these checked here, and we will play around with the spacing and everything after we start adding items to it. So we're going to have a number of mappings under this. We're going to have a mapping for the rotate left, rotate right, thrust, fire, and hyperspace keys. So for the very first one, which is going to be our rotate left, so I'm going to say create empty, rotate left mapping. All right. We're going to give it a Text Mesh Pro field, which is going to be the label. So I will just rename this to be label. And the text in here will be rotate left. And that's going to be an arcade font. We can go ahead and keep that font size at 36, but we're going to left align it centered, so that's all fine. And I'll just disable the wrapping here. And we are going to anchor it to the center left. So hold down Alt and hit that there. Okay, and then underneath of label, we're going to have a drop down. So select the rotate left mapping here, right click, go UI, drop down. Okay, so we have a label and a drop down, and we're going to align that to the right. Okay, so we need to get these things scaled correctly. So I'm going to take this guy, the parent, the actual mapping guy, and I'm going to just start increasing the width until we get something that looks kind of decent. And I also want the drop down probably to be a little bit higher on the y-axis, lower on the y-axis, just to get them to kind of line up correctly. All right. And I want to move this guy down just a tad. All right, so that's starting to look pretty decent. So this is going to be a drop down that has the different keys that they can select to map for the rotate left button. And we're going to duplicate this mapping. So we have one for rotate right, thrust, fire, and hyperspace. So rotate right, thrust, fire, hyperspace. And you can see that it's arranging them all vertically, and we're going to play around with the spacing to get them a little bit more reasonable looking. But let's just go ahead and rename these guys. So rotate right mapping, and then we're going to go into our label, and we're just going to change this to rotate right. And then this one is going to be thrust mapping, and we'll go into our label and change that to thrust. Change this one to fire mapping. Go into our label, change that to fire. And then finally, change this one to hyperspace mapping. Go into our label, and we will say hyperspace. All right, so now if we go up to our key mappings, to our vertical layout group, we can start reducing the spacing until we get something we like, which I think that looks pretty good. All right, so we have a key mappings group underneath of our keyboard controls. And that's all we need for keyboard control. So the next thing we want to add are audio settings. So right click here, create empty, audio settings. We're going to add a Text Mesh Pro object, which we're going to call audio settings text. And the text is, you guessed it, audio settings. That will be an arcade font with a point size of 48. We want it to be centered, cap line with no wrapping. All right. And I'm going to align it upper center underneath of this audio settings. So audio settings is obviously bigger than it thinks it is, and so it's currently displaying it up here, but we're going to fix that later. Underneath of our audio settings, we're going to want to have a section called volume settings. So I'm going to right click here and I'm going to say create empty, volume settings. And volume settings, kind of like we did for the keyboard controls, is going to have its own vertical layout group. And we will, of course, play around with the spacing and stuff for that. Temporarily, I'm going to disable our keyboard controls just so we can see what we're doing underneath the audio settings. So under volume settings, we want to create a master volume node. So create empty, master volume, and that's going to have an icon underneath of it. So I will right click, UI, image, and I'm just going to call this icon. And if we expand image here, we are going to select sound, which gives us this nice little speakery thing here. And I want to make sure that preserve aspect is set. And underneath of that, we want to add a slider. So we're going to go down to UI slider, and we're just going to let it be called slider. All right. And we're going to want to position and size these guys. So I'm going to take the icon, and I'm just going to drag it to about there. And then I'm going to take the slider, and we're going to actually increase its size. So I changed it here to the size of scale tool. And we're going to drag this out about like that. I think that looks pretty good. Okay. And we're going to move this whole thing down just a smidge. All right. So that is our master volume setting. Now we're going to duplicate this, and we're going to do the same thing for music volume. So duplicate that, music volume. But for the icon, we are going to use music. All right. And then we're going to duplicate this again for sound effects. So SFX volume. And we're not going to have an icon. Instead, we are going to add a Text Mesh Pro, which we're just going to call label. I'm going to move it up above there. That's going to be SFX. We're going to use our arcade font. 36 is fine. Okay. I think that looks pretty decent. Now we're going to want to come in and play around with our spacing on our vertical layout group here. And I don't like that. So I think the way to fix that is to go into our label and let's make this bottom align like that. Okay, that looks pretty decent. All right, so we've got our master volume, music volume, and sound effects volumes. And if we go back and we turn on our keyboard controls, we've got all of that. And so I think if we go up to these audio settings here and we increase the size, that should start spacing that out. Let's look at this. We want to, I think I was changing the size of the wrong thing here. We want to change this guy's size. What am I missing here? This guy should be anchored under here and move with it. Okay, well, let's go ahead and drag that up. So I've got two groups here. I've got audio settings and I've got keyboard controls, right? Which it is arranging vertically within the form, right? And each of these guys are arranging their children vertically. So now the only thing left to add to this form is something called form buttons. And that's going to have our save and cancel button. So we're going to come over here and we're going to create empty. And we're going to call this form buttons. And we're going to put two buttons under this. Well, actually, this is going to have a horizontal layout group. So we're going to want to arrange these guys horizontally. And we're going to add two buttons here. So we're going to right-click UI button. And we're going to call this save button. And if we come down under the button here, under text, we're going to say save. And I want to use the Oswald bold font. And I think 24 is fine for that. I kind of like the way that looks. And then we're going to duplicate this. And we're going to rename it and call it cancel button. And for our text, we're going to say cancel. I don't want a carriage return in there. All right. Now we want our form buttons. We want them all to be centered. So I'm just playing around with these guys to try and get them positioned. So I should not be able to control these guys' position because they're controlled by the parent layout group. This is why I say this is kind of tedious and I don't really enjoy this phase of game development. So that's very interesting. All I did was resize them a little bit and it jumped all the way down to the bottom. Let me look at this. Horizontal, upper, I want this to be upper center. Let's go look at our form here. Okay, that's starting to look a little bit better. So I think I can make this height a bit taller. Okay, I think that's decent. It's not perfect. You can see how much you could tweak this and play around with it to get it looking good. But I think this is good enough that we can move on to writing the script for this form. Okay, so to get this all wired up and working, over here where I have delete this, I'm just going to disable that. And now you can see it's saying, hey, no cameras are rendering. Yeah, I know that. I'm going to go back to our game scene here. And on our UI, go into our game UI. And we already have our settings button here with our UI button script. We're already calling init on it and passing it in our load settings scene method. So that's all good. But our load settings scene has this commented line out here to load the settings scene additively. And so we want to pull in that reference. So that just pulled in the scene management namespace. So now this should additively load that settings scene, which has our settings dialog on it. So let's jump back out into Unity. And I just want to scroll down here. That all looks good. And our settings scene is already there in the build settings. So let's go ahead and hit play. And I'm going to hit the little settings button. And there it is. There's our settings form. So it has additively loaded the settings scene, which has the canvas and all the fields and stuff that we had added to it. Now, right now, we're not initializing these variables, and there's nothing in there to select from. So let's go ahead and flesh that out. So in our UI folder under scripts, we're going to create a new script. And we're going to call this settings UI. And we're going to have to jump back into our settings scene. And on our panel, our settings panel, we're going to add that settings UI script. So I'm just going to go back into our scripts UI, and I'm going to drag settings UI right there. Okay. Now, we're going to double click this to open it up in the editor, select everything, and then paste in a whole bunch of code. So this is 175 lines of code. So this is going to be one of the longer scripts in this game, but it's going to have all of the UI for our settings form. Now you can see that we've got a compilation error there because it does not like that key map drop-down UI. So what we can do is we can go down to the bottom of our file and just paste in another class called key drop-down UI. I don't want to paste in those namespaces again. And I'm just going to move this to its own file and add it to source control. So I'll go over this one first since it's a little bit smaller. We have some serialized fields here. We have a Text Mesh Pro drop-down field. So this is the first time we've seen that, but you remember the drop-down fields that we added to the form. That's basically what this is here. This is a way we can access it from code. We have a couple of private variables here, static read-only list of keys. So this is coming from the Unity input system, and we're going to use this to actually add the possible values to our drop-down and also to store whatever the selected key was that we selected for that drop-down. So we have a list of Text Mesh Pro drop-down option data, which are options for that form, which are actually going to be the keys that you can select. So in our init function, we have this populate dropdown. So you remember init is being called, we go up to the top of our file. We are going to call init on each of those keyboard controls, which are going to be serialized fields in here, key drop-down UIs. So going back into our key map drop-down UI, we're going to populate our drop-down options. So let's look at that function. So keys is basically a static list of keys. And if we have not populated that list, then we want to go and use the enumeration key, which is from the Unity input system. We want to get all the values out of it. And then we want to loop through all of those keys and add them to our options. All right. And we're adding in basically the string value representation of that key enumeration. Okay. And then we're going to add that key to our list of keys. So if we had not yet populated our list, we're going to do that here. And then we are going to take these options and assign it to the options on the dropdown. So that's going to be the keys that you can select from when you drop down the dropdown. We want to get our initial value for whatever the default key is. And so when we call init, we're going to pass in that default key, and we're going to be getting that from settings. So whatever the current setting for that key is, we're going to pass that in as the default. And then we want a callback that we're going to call when they select a key. And we're going to assign that right here to this key selected action variable. And we're basically going to invoke that with the selected key whenever they actually change a key. So on disable, we're just going to remove a listener to the on value changed. So here we're subscribing to the on value changed for that dropdown. Okay, so when the value changes, we're going to invoke that callback that they supplied us with the key that was selected. So this is going to give us the index into the dropdown, and this is going to give us the key at that index. Because you remember when we populated our keys, we added them to our list, and so they're going to be in whatever order that we got them. That's the order they will appear in the dropdown, and so whatever index into that is, we use that. Okay, so we have serialized fields for all of our dropdowns. We have dropdowns for every control key: rotate left, right, thrust, fire, and hyperspace. We also want to have slider controls for our volumes, for master volume, music, and sound effects. And then we want an audio mixer for the main mix. We want a sound effect clip. So when you actually change volumes, I'm actually going to play a sound effect. We're initially going to be playing music when this form is loaded. And we can, whenever they change the volume, play a sound effect so we can kind of see the balance between the sound effect and the music. And then we also want references to our save button and cancel button. We're going to save off the keys that have been selected for each of the drop downs, and we want to have access to the player keyboard input. So in onEnable, we actually add a player keyboard input component to this instance. We load our key binding. So let's go take a look at that. We ask the player keyboard input to give us our key bindings. So this is the same thing that happens when you start the game. We get our bindings from settings, passing in default values if they had not been yet saved to settings. And then we basically take those values that we got from the player keyboard input and we assign them to our local variables. We subscribe to the button handlers for save and cancel. Basically going to call our on save button clicked and on cancel button clicked methods. This is where we initialize our keyboard controls. So we're going to call their init method, passing in whatever the current key definition is for them. And then we're going to activate this panel. We're going to initialize our audio settings controls. So basically we're using that main mix reference that we got, and we're using that exposed parameter that we exposed for the main mix. So we're exposing the master volume key. We're going to use that to get the master volume that's currently set on that mixer, and we're going to assign that to our mixer, to our slider. Now, this is an interesting function here. Mixer to slider value. What's that all about? Well, the way the volumes work in Unity is they're basically a logarithmic range. And so instead of going from just 0 to 1, we actually go from -80 to 20. So this is like the volume turned all the way down to the volume turned all the way up. And so we're going to use an inverse lerp to convert from 0 to 1 to whatever this value is. So that gives us a slider value. Well, this is going the other way around, actually. This is going to take the -80 to 20, and it's going to give us a value from 0 to 1. We go the other way when we want to take the slider value and then get the appropriate mixer value to assign back. So we do that for all the sliders. And then we subscribe to the value changed for those sliders. And so when the value changes, we tell the mixer to set its current float value for whatever volume that is to whatever the slider value is lerped to the mixer value. We do that for master volume, music volume, and sound effects volume. And then whenever they select something from a drop down to actually change a key, we just take that key and assign it to our local variable. So when the save button is clicked, we're going to save these key bindings to the player keyboard input. We're going to save the audio settings, and then we're going to close the settings panel. So if we look at save key bindings, this is basically just going to save them out to the settings manager. And then when we save the audio settings, it's also saving them out to the settings manager, with the final call actually committing those changes to whatever source those settings are saved to. It would be the registry under Windows. So that's it for the settings UI and for the key map dropdown UI classes. So let's jump back out into Unity and let it recompile. And we're going to have to assign some things here, quite a few things, to our serialized field. So first of all, the panel. Well, that's easy. It's the settings panel. And then we want the different drop downs. So under our form, we want to go to keyboard controls. And then we want to have, for the various control keys, we want to take the rotate left drop down. Oh, looks like I need to expand that. Oh, can you all see what's wrong? What did I miss? I'll give you a few seconds to think about what I missed. All right, in case you're stuck, basically what I need to do is for each of these drop downs, I need to add the key map drop down UI. And actually I need to add those up here at the parent level. So all of these guys need to have the key map drop-down UI on them. And then for each one, I need to actually assign the drop-down to it. So there's that. Oop. There we go. There's that one. And that one. That one. Isn't this exciting? I keep letting go of the mouse button before I've got it over the target. All right, let's just make sure they're all assigned. Nope, so I missed one. Just make sure I haven't misassigned any. All right, I think that's all right. What else do we need on our settings form? We need those drop downs. So rotate left drop down, rotate right, thrust, Man, Windows, stop scrolling on me. Fire. Okay, let me just expand this and minimize a couple of these. Okay, finally. And our master volume sliders. Audio settings. Expand all those. Come back up to our settings panel. Scroll down to there. All right, so we want our master volume slider. Our music volume slider. And our sound effects volume slider. And then for main mix, we can just pick that from that selection there. Then our save button and our cancel button. Okay. I told you in the beginning that this is my least favorite part of game development. All right, so let's go up into our scenes folder and into our game scene. Okay, Greg from the future here. I had to go back and fix a compilation error that I got when I was trying to test. Basically, what was happening is I created my timer, my spawn timer in on start. And then when I got a game state changed event, I was trying to subscribe to the timers on timer stop. And I was getting an all reference exception because this game state changed was firing before this guy's start method. So I moved that into awake to make sure that we instantiate our timer before we could get any of these game state change messages. Not sure why we weren't seeing that before and it suddenly started happening, but that's what's called a race condition, and I have fixed that. And I've also expanded my game window just a little bit, just so we could see this a little bit better. And let's go ahead and fire it up and test the settings button. So music starts when we spawn the ship. I hit the settings button and it pauses the game. The music keeps playing. I could adjust the master volume. I could turn down the music. I could play with the sound effects. That was a little bit too loud. So anyway, we'll go ahead and save these changes. Oh, actually, let's change the keyboard control. So right now we're using Z, X, M, and space. I just realized I don't have my fire button on there. I missed the fire button. But let's go ahead and change this to be something like left arrow. Oop. Left arrow. Right arrow. And we'll just leave it at that. And then I'll hit save. So I'm going to use the left arrow, and that is working. Boom. And if we open up the settings window again, you can see that it remembered those settings. I'm just going to go ahead and put these back. So I want it Z, and X. All right. Okay. So we have loading and savings of settings working. The only thing I need to do is go into my settings scene and figure out why we don't have our fire button. So let's expand our canvas, Well, I see something that's already a problem. I accidentally dragged this out. I bet you when I was trying to assign these to the panel, I actually dragged that guy out. That's pretty funny. So let's put him back here under keyboard key mappings. And then we want him to be up above thrust. That looks good. Now let's go back to our game scene and give that a shot. And there's fire. It's currently M. Let's change it to C. Yep, and that works. Okay, so that is loading and saving settings. So the next thing we want to work on is our start menu scene. So we're going to go into our start menu. All right, and you can see we've got a main camera. I'm actually going to create an empty game object, call it camera, drag this out, drag the camera in, and I'm going to collapse that. And we're going to create another empty game object, and I'm going to call it background. And in this, we are going to add a 2D sprite square, and we're going to pick background 1, that guy. And I think that looks pretty. I like it. Okay, that's our background. Now we want to create a UI. So we're going to create a canvas. I'm going to call it UI. We're going to make sure our canvas scaler is set to scale with screen size using 1920 by 1080 as our reference resolution. And I'm going to drag this event system into there. And underneath of our UI, we're going to have some title text. So a text mesh pro called title text. And what do you think the title is going to be? I don't know about you, but I'm kind of fond of Asteroids. And we want this to be our arcade font. And actually, you know what? I think I want to use a different font. I think I'm going to use the Bangers font. And I want it to be big. So 256, centered, cap line, no wrapping. I don't know. What do y'all think? I kind of like that. For the color, I think I want to go with kind of an orangey color. Not that orange. Let's see. Kind of yellowish orange. Something like that. I think I want to give it a bit of a border, an outline. Yeah, I think that looks nice. And let's see, we are going to go ahead and anchor that. I think it's fine anchored there, but I want to move it up on the screen somewhere around there. And then we want to have a press to play button. So add another text mesh pro, press to play, text, press to play. And for this one, let's try a different font. Let's try Oswald Bold SDF. I think 36 should be a good point size. Actually, I want it to be press space to play. We want it to be centered, cap line with no wrapping. And we're going to move it up somewhere around there. I also want to add a group under here. which I'm going to call controls text. And this is where we're going to display some help for the player. So we want to create a text mesh pro called controls. And that's basically going to be the heading. Controls, get my fingers on the right keys. Controls. Let's try an even different font. Let's try this electronic highway sign. And about 48 point size, centered, cap line with no wrapping. All right. And then we want to have rotate controls text. And we're going to say Z, X, rotate, left, right. And we're going to make that one also be that electronic highway sign, but only 36 point size. All right, so we want it to be centered, cap line, no wrapping, and we're going to move it down just a smidge. And let's go ahead and duplicate that twice. This one we are going to call thrust fire controls text. And we will say NM thrust fire. And let's see. Just move it down. Cool. This one we will call hyperspace controls text space hyperspace. And I think that looks pretty decent. I just want to move this whole controls thing down, something like that. Now we also want to add our settings button. So let's go back into our game scene. So I hit Control S to save this scene. We go back into our scenes, into game. We've got a settings button under our UI. I want to put that into our prefabs folder. I want to create a prefab. So let's just drag that right there. And then go back out into our start menu scene. No, I don't want to save the game scene. I didn't change anything. All right. And so we want to basically drag the settings button under our UI here. So go into our UI prefab folder, drag the settings button, put it right under the UI, and look at that. I'm just going to move it up a little bit to be about like that. Now we're going to want a script. Oh, there's one more thing I want to add. One more thing. I want to add another 2D image. Actually, I want to add a UI image. So here I'm going to right click UI image, and I'm going to call this fade panel. And for our image, I'm just going to pick background. All right, and we're going to make that black. And we are going to fill the entire rectangle. So open up our rect transform and then hold down Alt and click that. And that will cover up the entire screen. And so what we're going to do is by code, we're going to take this guy's color and we're going to fade him out. So when the game first starts, we're going to fade in this screen. And then when you press space to play, we're going to fade this out and then load the start scene. Pretty cool, huh? So we want to create a script for this start menu. So we're going to call it Start Menu UI. We're going to put it on this UI item here. Let me just collapse all these guys and drag Start Menu UI onto there. Double click that to open it up in the editor, select everything, and we'll paste in the code. So let's take a look at our Start Menu UI. A number of serialized fields. We got our Fade panel. We have our Controls panel. That's basically the help text that we're displaying. We've got the individual Text Mesh Pro fields under the Controls panel. So we're basically going to overwrite this text with whatever we have saved in settings, so that if the player goes in and changes their mappings, then we want to use their mappings in the help there. We don't want to display the default ones. And then we also want to have an audio source. I need to add an audio source, and I did not add that. So what I can do here, actually, I'm not going to do. I was going to add a required component, but since I'm going to want to assign that audio source to a mixer, I'm going to go ahead and just do that in the inspector. I could do all that through code, but I'm just going to go back and do it in the inspector. And we want to also have our settings button so that we can, when that settings button is clicked, load the settings scene, just like we did in the game scene. So first of all, let's jump back out into Unity. And on our UI here, we want to add an audio source. So we'll say add component, audio source. Okay. And then for our audio clip, I'm going to use a song called Zephyr, which I think is a pretty cool song. And for our output, it's going to be music, like so. We want it to play on awake, and we want it to loop. And I'm going to set the volume to be at about 75%, give or take. All right, now let's go ahead and assign all of these variables, and then we'll go back and look at the code. So first of all, our Fade panel. Our Controls panel. The Rotate Controls text. Thrust Fire Controls text. Hyperspace Controls text. Our audio source we can just drag from right here. And then the settings button. And let's go back and look at the code. So we got all our serialized fields. In Awake, we also do like we did in the settings screen itself. We add a player keyboard input component. In OnEnable, we set the volume of our audio source to 1. We fade in the panel over 1 second using doFade. So this is a tweening function from the doTween library, where it's basically going to fade this panel's alpha from its color from its current value down to 0. Then we are going to initialize the settings button just like we did in the game scene. So we have a load settings scene function here. And we want to subscribe to the settings button on settings update so we can update our controls. So update controls text, we're going to initially call it when we first enable. And let me show you what that does. So we don't want to do this as if we're on an iOS or Android device, which we haven't added any mobile controls yet, but this is going to be different if there's mobile controls. So we want to initially set that control panel to be active. We want to set these variables for the rotate, left, right, thrust, fire, and hyperspace keys from the player keyboard input. And then we want to just set the text on each of those Text Mesh Pro fields to be whatever the actual keys are, followed by the help text. So M, N, rotate, left, right. You get the idea, right? Or X, Z, X, M, N, space. But whatever they map it to, that's what's going to display here. This is basically what's called string interpolation. So when you have quotes and you have a $sign in front of the quotes, you can put some curly braces in here with a variable name. And so that's going to use the value from that variable, and it's going to stuff it in there in that string. So that's really cool. When we start the game, so when I press space to start the game, we actually want to fade the audio source out over 2 seconds. So we're just going to do a smooth fade and turn the volume down on our audio source. And we're going to fade in our fade panel over 1 second. And when that completes, we're going to load the scene, the game scene. So this gets called when they click the settings button. This gets called whenever the settings change, like when they save the settings. And this updates our help text. So that's pretty much it for the start menu UI. So now if we go back out into Unity, and we are on our start scene currently, and I just want to go into our build settings, and I want to make sure the start menu is the first scene in the list, and it is. So now if I hit play, we should hear that Zephyr music playing. And you see that it kind of faded in because the fade panel faded out. And now if I hit space, it fades out, and then we come into the game scene. All right? Let's try that again. This time I'm going to bring up the settings screen from the start menu. And that's not working. So let's diagnose why that isn't working. Was there anything in the console? Any errors? No errors. All right, so we have our settings button. Let me put this down below the fade panel. There it was. So it wasn't getting hit by the raycast when I was clicking on it. So the UI didn't know that I had actually clicked on it because it was basically being covered up by that fade panel. Even though the fade panel had been faded out, if I was to fade the fade panel in, it was actually covering up that button, and that's why it didn't work. But you can see we can access our settings from here, just like we could from the game scene, right? And then if I hit space, there we are. Okay, so we have our start game menu working. So now that we have a working game, the next thing we want to do is we want to build this out and publish it up to itch.io. So right now you can see that we're building for Windows, Mac, Linux. We're building the desktop version. If we go to our build settings, you can see it's set to Windows, Mac, Linux, with our target platform currently being Windows. Now, when you installed this version of the Unity game engine, you had the option to install different platforms. Hopefully, if you are intending to publish this to itch.io, you installed the WebGL platform. So we're going to select that. We're not going to override any of these things, but we are going to want to go dig into our player settings. All right, so let's just drag this out a little bit so we can see it. So you're going to want to put in a company name for your company. I'm just going to say Midnight Oil Software LLC. We're calling this Asteroids. Version 1.0 is fine. Now you can see that it's selected this tab over here. So these are like your Windows, Mac, Linux settings. These are if you're making a dedicated server, an Android build, an iOS build. So these are our settings for WebGL. So you can have, with the same project, we can build versions of this game for different platforms. Under resolution and presentation, we want to use 960 by 600. So that is a good default for itch.io. And they even give us a template here that we're going to use for WebGL. If we come down here to other settings, I think we're probably good with all of these. Now, for publishing settings, this is currently set for Brotli compression, but itch.io is a little bit finicky about their compression formats. They have to be able to detect the type of compression you're using. So there is a link here, which I will put in the description, for creating HTML5 games. And if you go down to the compression link, you basically see that they need to be able to detect the type of compression that's being used. So if you do use Brightly compression, you're going to want to make sure that your compressed file has a .gz extension. You could also use the gzip compression. I'm just going to select no compression. That just means it's going to take longer to download, but I'm just going to say disabled. And for all the rest of these settings, I'm just going to leave them the way they are. So now all that's left to do is actually build. So first we have to switch to the WebGL platform, and this will take a little while. Okay, so it has apparently finished switching to the platform, and now it is compiling scripts. All right, so we have switched to the WebGL platform. Now I'm just going to come up here and say save project, just to make sure everything is saved in case this crashes. It shouldn't crash. And then I'm going to click build, and we need to pick a destination file for the build. So I'm actually going to, I don't want this to go under our source folder here, because all this stuff gets put under source control. I mean, I could add to my git ignore, I could add to tell it to exclude the build directory, but I'm actually going to come up here under tutorials, and I'm just going to create a folder. I'm going to call it builds, and I'm going to create a folder called WebGL, and then I'm going to create a folder called Asteroids. And I'm going to select that folder. And so it's now building out the WebGL version of our game to that folder. And this will take a little while. Windows Defender. You may or may not get that pop-up. Okay, so here it is, my Asteroids game. What we're going to do is we're going to compress all of these files. Now, I use 7-zip. You can install it free for Windows. I'll put a link to that in the description. But basically, I'm going to create an asteroids.zip file. And this is the file we're going to upload to itch.io. So we're going to go into our browser and go to itch.io. Now, if you don't already have an account on itch.io, you're going to have to go create one. So I'm going to just log out temporarily. So basically what you'll do is you'll click this register button, go through that whole process and create an account. It is free. So now I'm going to log back into my account. And as you can see, I've got a bunch of games on there, including Asteroids. I have an Asteroids prototype, which was the prototype that I made for this tutorial. I'm going to add a new game. So I'm going to show you the process by which you would do that. So if yours is blank, you won't have to scroll down nearly as far as I am, but you come down here and there's a button that says Create New Project. And we're going to give it a name, and I'm just going to call this Asteroids. And then it will give you a URL that's going to be based on whatever your itch.io name is, plus the name of the game. And then you can give it a short little tagline. So this is going to be Asteroids. Oops, got to spell that right. Asteroids game I wrote for a Unity game dev tutorial. All right. So we are uploading a game. That is correct. It is not going to be downloadable. We want to change this to HTML. And then the status of the game can be whatever you want it to be. You can say, oh, it's complete, but might receive some updates. I think that's fine for me. You could also say it's in development, it's on hold, it's a prototype. I'm just going to say released. And then if you want to sell it, remember, if you're using those Asteroid sound effects or that arcade font in your version, you don't want to sell it. So just going to make that 0 and 0. And now we want to upload our zip file. But before I do that, I want to set some other settings here. We do want to embed in page, and I want to manually set the size. And my size that I'm going to set it is 1024. That's interesting. It only takes one character. 768. 768. Okay, 1024 by 760. I think itch.io needs to fix their web controls there. I will have an optional full screen button. And then for details, I can just say this is a remake of the classic arcade game Asteroids that I wrote for a Unity game dev tutorial. And I'll probably put a link to my tutorial in here too. I'm actually going to delete this game after this video, so I already have Asteroids out on my dashboard. I don't need another copy of it. I'm just showing you how you would do this. For the genre, you could add some tags if you want to. Anything else I need to change on here? I'm going to say that this is public, so anyone can view the page. Actually, I'm going to make it restricted. Draft in this case. So I can do draft, restricted, or public. Public, anyone can see it. Restricted, only the owners and anyone I authorize can see it. Draft, only those who can edit the project can view it. So only I will be able to see it, but that's going to be fine. So this way it won't go out publicly to everybody. You can upload an optional cover image. You can upload some screenshots. You can give it a link to a video trailer. That's all fine. And now we want to go to upload our file. So we're going to go into our tutorials, builds, WebGL, Asteroids, and we're going to pick our asteroids.zip file. So it's uploading that. And then I can click save and then view page. So it says we're loading the game for the first time. And here we got, this is a remake. So this says download now, but that should not be available because there's nothing to download. But this is the key right here, run game. So if I click this, it's going to load our game in the browser, show our logo, and there we go. We've got our start screen, our settings menu that's not working. I hit space, it starts to play. And we can actually play it in the browser. And the settings screen is working from here. So we can go and diagnose later. I'm going to hit F5, which will refresh the page and just take us back to here. So that is how you build a WebGL game and publish it to itch.io. And you can pretty this page up a whole lot more if you edit the theme. You can come in here and you can change your background color. You can also tell it how you want to arrange your screenshots. You can upload a banner image, background image, and so forth. If you just go into edit game, you can upload some screenshots, you can upload a cover image, and so forth. All of those things you can do to just kind of customize your game. I'm actually just going to delete this game because, like I said, I already have a copy of it on the dashboard. Okay, so the next thing we want to do is we want to add some on-screen touch controls. So I'm going to go into our game scene. And you'll recall that we have our UI node here, which has our canvas and then all of our UI controls underneath of it. We're going to start by adding an empty game object under here. And I'm going to call it PlayerTouchInput. Now, Unity does provide some built-in controls that we could use. And I'll show you those, but we're not actually going to use them. We're going to roll our own, and I'll explain why when we get to that. But we want this guy, this input here, to be anchored to the bottom and stretched across the screen. And if we were to go into the scene view and zoom in, you can see that's kind of what it looks like there. So underneath of this, we're going to create a rotate control, which is actually going to be a on-screen joystick. And so to do that, we're going to create a UI image. And I'm just going to call this rotate. And then underneath of that, I'm going to create another image. And I'm going to call it handle. Now, both of these guys, for their image component, I'm going to use a sprite that's built into Unity called knob. All right. And we want to do the same thing for our handle. And I want to make them a little bit, oops, it looks like I did not actually select that. There we go. I actually want the color for this to be kind of a darker gray, not a super dark gray. Let me turn the handle off for a second. So yeah, I don't want this to be a super dark. I think something like that looks pretty good. And then the handle is going to be a little bit darker. Okay, and let's show that. Okay, that's why. So a little bit lighter than the other one. And for its size, we're going to basically make it half the size, half the size of the parent. So basically we just have sort of a round target area, and then inside of that we're going to have the stick that we can drag around. All right, now, like I mentioned, Windows has a built-in component that we could use, and it is called on-screen stick. All right, and so if we were to actually add that component to our handle, and then go ahead and hit run here, you're going to see that I can grab that little stick and drag it around. Right? But it's not actually doing anything to control our ship, but that is a built-in component that Unity gives us. And if we were going to use that to control our ship, we would create some input actions. You know, I'd come in here and I would say create input actions, and we could call it something like mobile touch controls, or we could just call it Asteroid input actions or something. And then we could edit that, and we could essentially create new actions, so like Asteroids, I don't know, and then for a new action we might have a binding. You know, we could come in here and, you know, we could rename this action here, for instance, and we could call this rotate. And then we could add a binding where we would come in and we would bind it to like joystick. Oh, and this is a bug in the input, the new Unity input system code. There's actually a workaround. You could go and edit a file that came with this. I think if you manually install a newer version of the input system, it would also fix this. But basically what we want is stick. Right? Now it's not letting me select that for some reason, but it doesn't really matter because we're not going to be using it. I will show you, if we go in and look at this guy here, we can set the control path just like we were trying to do there. And that, boy, that UI bug is really, really bugging me here. Here, so it lets me set that there. And then it tells you that if we were to use that, it would basically call I pointer down, on pointer down, on pointer up, and so forth. And we would just add those methods to whatever class we wanted to handle those inputs. And then in addition to an on-screen stick, they've also got on-screen buttons. So like, let's say I wanted to remove that on-screen stick. I could add component on-screen button. But just want to show you that there are some built-in components that Unity provides. They're really meant to work along with these input actions, but that's not what we're going to use. I'm basically going to show you how to roll your own, and they're actually going to be a lot lighter weight. If I was to drill into the code that's behind those on-screen controls, I mean, it's doing a ton of stuff we just don't need to worry about. So we don't need to use that. We're going to roll our own, and it's actually going to be a lot less code than you might expect. Now, I do want to rearrange these controls on the screen. So for the rotate control, I'm going to anchor it to the middle left, but then I'm going to move it over some. And I'll probably move it up just a tad. And you know what? I think I want it to be a bit bigger too. So I'm going to come in here. I'm going to make the scale double on the X and Y axis, just so we have more to grab onto. And so if you imagine this is a phone that you're holding in your hand, your thumb would come here pretty easily. I think that would be really easy to use for your thumb. Now we're also going to add a couple more controls. We want thrust and fire. Now we could make this stick rotate and thrust. And that's certainly a way you can go. But what I'm going to do is I'm going to limit this guy to only the X-axis, which is another reason I'm rolling my own. I didn't really see a way to take that on-screen stick and limit it so you can't drag the stick vertically. I only want to drag it back and forth. If anybody knows an easy way to accomplish that, you can post it in the comments or over on my Discord. I'd love to hear that. But instead of having this thrust, we're only going to rotate left and right, and then we're going to have three buttons. We're going to have thrust. Actually, we're going to put hyperspace as far away from the edge as possible because you don't want to accidentally hit hyperspace. So we'll have hyperspace, thrust, and fire over on this side of the screen. So what I'm going to do is I'm going to add another image. So UI, image, and we're going to use that same knob, image. And I'm going to take the color from our rotate button, and I am just going to apply it to that one as well. We're going to rename this one to be hyperspace. And we also want to anchor it to the right middle, but we're going to position it kind of like we did for the rotate. We want it to be at the same Y height. So I'm just going to make this an even 112. And I'll come over here and make this an even 112. And we want to double its size like we did the other one. And for some reason, it is not using the knob. So again, that's the second time I've done that. Knob. Okay, why did it not work? Knob. Okay, double click it this time. There we go. So now I'm just going to move it somewhere around there. Now I'm going to duplicate this twice. I'm going to call this one thrust. Oops, I'm going to capital T on there. And we're going to call this one fire. I'm going to select both of these and I'm going to move them over. And then I'm going to just pick the fire one and move it over. So those are our three buttons. Obviously, that's not the image we want to use for any of those. So for hyperspace, we want to add a child image. And I'm going to use Actually, I want to use this refresh image, but I want it to be a little bit darker gray. Something like that looks pretty good. So this is hyperspace. You're basically going to go away and come back. I don't know. There isn't really a perfect image for hyperspace. I'm going to duplicate this, and I'm going to say paste as child. And then we're just going to change the image. This is where I want to use arrow up. Like that. So that's thrust. And then for fire, come over here and say paste as child. And the reason I copied and pasted is because I want the color to already be assigned for me. And so this guy, we're going to use turret small 1. So I think this guy. And that's obviously not the size that we want. So one thing I think I want to do is say preserve aspect. And then I'm just going to drag this down a little bit. In this one, we actually just want to take the color and make it all the way white. So there we go. So we've got our joystick for rotate, hyperspace, thrust, and fire. Now we're going to want to add scripts to those. And we're going to start with the rotate. And the script that we're going to use is called MobileJoystick. Actually, I think I'm going to call it MobileJoystickInput. So if we go into our scripts folder, into UI, we're going to right click here and say create C# script MobileJoystickInput. And let Unity think for a second. And I'm going to collapse all these things. And I'm just going to drag MobileJoystickInput over to there and then double click to open it up in the editor. Select everything. We're going to paste in this code. So let's walk through this code. We're going to have some serialized fields, and this is kind of redundant. So we have this axis control, and this is an enumeration that I've defined, which tells us whether we want this joystick to work on the horizontal axis, the vertical axis, or both. And so we are only using the horizontal axis, so I set that here. We have rect transforms for the background image and a rect transform for the handle. We're going to be using the handle to basically, we want to move that around as the player grabs it and drags it. We have a public property, it's a vector 2, which is going to be our direction. So this is basically going to be -1 to 1 for both axes here. And if you're only using one axis like we are, the other one will always be 0. We're only going to set the one that we care about. This input we're going to set basically if we detect that the player has grabbed it and dragged it. So that's going to be set when we handle that. And then because we want to handle multiple touches, so you want to be able to rotate and thrust at the same time, we want to use this touch control, and we want to find the touch that applies to this specific control. And I'm going to show you how we do that. And we're going to cache off the touch, basically, for this control. And we're also going to be caching off the ID for it. So the first thing we want to do in update, if we have not already cached a touch ID, then we want to check for drag start. So let's go and look what check for drag start does. We're going to use that touch screen, and if we can't find the current touch screen, we're just going to return null. Otherwise, we want to find all the ones that have the touch phase of began. So when you grab it and start dragging it, there's going to be a touch in here in this touches collection with a touch phase of began. And we want to iterate through all the ones that say touch phase began, and we want to find the one that our control, this over our control. So we're going to use this rect transform utility, and we're going to check rectangle contains screen point. We're passing in the background image, the pointer position, which is coming from the touch position. So from this touch in here. And if it's not within the bounds of our background image, we're just going to go get the next one. If we have grabbed a control within the rectangle for this image, then we want to save off that touch ID and we want to save off that touch. All right, so that's handle drag start. And if we handle that, we're just going to return. Handle drag stop. We're basically, if we haven't cached the touch and the touch phase for that touch is not ended or canceled, then we just want to return and do nothing. If it is ended or canceled, we want to call an on pointer up method that we've added. We want to clear out our touch ID and our cached touch. And we want to return false otherwise. So if we did clear that touch, we want to return true. So we've handled drag stop. All right. Well, I guess we should go look at that on pointer up. So all we're doing here is we're setting the anchored position of that handle image to be vector 2.0. So we're going to snap that handle back to the middle because you stopped dragging it. And we're also going to set the direction to vector 2.0. Now, if we have not handled drag start, we have not handled drag stop, then we want to handle drag. So we are dragging a control. So basically, we want to first make sure, hey, have we cached off a touch? And we only want to do this if it's been moved or stationary. We want to call on drag. So on drag is basically going to read the pointer position from our cached touch. And then we're going to calculate the position by taking the vector 2 of the background image's position, which this should be the center of the sprite, which will be basically vector 2.0. And we are going to subtract it from this pointer position. We're going to clamp that to our max handle range. So one of the serialized fields that we added was a handle range. So we only want to be able to move it 20 in any given direction. So we're going to clamp that direction by 20 in either direction. And then if we're only caring about the horizontal axis, we're going to set the input.y to 0. If we only care about the vertical axis, then we want to set input.x to 0. And we're assigning the handled anchored position to be this input. So we're going to move the graphic for that handle appropriately based on where we dragged it to. And then we're going to set our public direction property to be our input divided by the handle range. And this is going to be a value between -1 and 1. All right. So that is it for the mobile joystick. Now, similarly, we're going to want to create a mobile button script. So I'm just going to come down here and I'm going to paste at the bottom of this file our mobile button code. All right. And we don't need these extra using statements. And I'm just going to select this, Alt, Enter. It's going to be Control period probably, or Alt period. I think it's Control period in Visual Studio. And I'm going to move it to its own file and add it to source control. So now we're in our own file here. Let's look at this code, mobile button. We have one public property called isPressed. And it's a Boolean. And then we're going to save off our rectangle for our button. And we're going to use that same touch control that's provided by the Unity input system to cache the touch that's associated with this control. In awake, we get our rectangle. So in update, we want to first say, have we started touching something? Has somebody started touching this control? So check for touch begin. If we've already cached the touch ID, we're just going to return false. If touchscreen.current is null, we want to return false. And this should only happen if you don't have a touchscreen on your device. So we want to do the same thing we did before. We want to look at all the current touches and find any that have touch phase began. When I iterate through those, find the one that's over our rectangle. So this code is exactly the same as what we saw for the mobile joystick. The only difference is we're setting isPressed to true. So if we started touching this control, we want to set isPressed to true. Now, if we didn't start touching something. We want to see if we stop touching it. So I could have extracted this out into check for touch ended, but it's just handling it here in update, same thing. If we don't have a cache touch, or the touch phase is not ended or canceled, just return and do nothing. Otherwise, we've stopped touching this control, set is pressed to false, clear out our cache touch ID and cache touch. That is it. Very, very simple. I got to tell you, if I was to drill into the code for those on-screen controls, in fact, let's on-screen control. This is coming out of the Unity input system. We go to the bottom of this file. This is 300 lines of code, okay? And this doesn't include the on-screen joystick and the on-screen button. So if we go and look at that, on-screen stick, there we go. 497 lines of code. So I'm not saying this is bad. I'm not saying it's wrong. If you want to use this, my friend Manny actually has a video on his channel. I guess it's Monty. Sorry about that, Monty. I have the great pleasure of being in a mastermind group with Monty, and he has a tutorial on how to create an on-screen joystick, or how to use the built-in on-screen joystick. And so I'll put a link to that in the description. So if you do want to use the on-screen joystick and want to see how to wire it up into your game, you can go check out Monty's video. I personally prefer this very lightweight approach, and it's very specific to what we're trying to do in our game. Nothing wrong with using the built-in controls. In fact, another option you could do is go up to the Unity Asset Store and get somebody else's mobile controls that are already plug and play, ready to drag into your game. I just thought people might be interested in seeing how you could roll this sort of thing from scratch. So we got this code here. We want to go back out into Unity, and we want to apply this code. So we've already got the mobile joystick here. I'm going to select hyperspace. I'm going to hold down Control and select thrust and fire, and I'm going to drag mobile button onto here. Okay, so that's it for those. For our joystick here, we want to grab our background image, which is just basically going to be rotate itself. And we want to grab our handle and drag that into here. And so that's all our serialized fields for mobile input. Now, none of this is going to work until we actually implement our player touch input. So as you recall, we already had player keyboard input, which is what we use to implement the keyboard controls. And that class is derived from a class called PlayerInput So we're going to do the same thing here. I'm going to create a new C# script, and I'm going to call this player touch input. Let Unity recompile. And I'm going to drag that right into there. And open it up, select everything, paste in our code. So let's walk through our player touch input, which implements the player input base. So basically there are those override methods for get thrust input, get fire input, get hyperspace input, get rotation input. So we have some serialized fields. We have our mobile joystick input, which we just wrote. We have our mobile button, 3 mobile buttons, which we implemented here. We have overrides for any input this frame, and any input this frame will be true if we have a non-zero value for rotation input, or if any of the other button inputs, thrust, fire, hyperspace, are true. We have private backing variables for thrust input, fire input, hyperspace input, and rotation input. And then we have our overrides themselves. So the rotation input is going to look at our rotate input control, which is that mobile joystick input. And if the x-axis direction is, well, basically we're going to assign that value to rotation input. So whatever this value is, which is going to be -1 to 1, we're going to assign that to our backing variable here for rotation input. All right. And same thing for get thrust input. We're just going to look at the thrust button. Is it pressed? We're going to assign that to thrust input, fire input, hyperspace input. So jumping back out into Unity, we need to drag those controls in. So here we want our rotate input. We're just going to grab rotate, drag that there. We're going to drag thrust, put that there. We're going to grab fire, drag it there. We're going to grab hyperspace and drag that there. Now, one thing that I ran into when I was testing this is I could only interact with one control at a time. And part of it is there's a maximum number of touches that your touch control is going to respond to at a time. And any other UI elements that are on your screen, you want to make sure that unless you absolutely need it, you don't want raycast target to be set. So for these Text Mesh Pro controls, I expanded extra settings, and I'm just going to uncheck raycast target. Most of the things that were eating up my touches were all these player life images. So for these, we want to go into our image, and we just want to find raycast target and uncheck it. Now, one thing you may have noticed is we are currently still targeting WebGL. So we're going to want to come in here. Let me just save our project first. And I want to make sure we save our scene first. Go ahead and collapse all this. What I want to do is go into File, Build Settings, and we want to select Android. And we want to say Switch Platform. And this will take a little while, so I'll just go ahead and fast forward through this section. Okay, now we are going to change some player settings in here. Oh, it's not done yet. Unity, you tricked me. You done? Go into player settings. And I'm going to move that over here. I'm going to change this to Midnight Oil Software LLC. So under other settings, where it says active input handling, we want to change this from both to input system new, and it's going to restart Unity so that these changes will take effect. Okay, so that's done. I'm going to go ahead and save my project again. Well, it's already saved because it just restarted. There is some more code changes that we need to do. We definitely want the PlayerDirector to select the correct input. Now, we had put in these preprocessor directives, and you can see that even though we switched to the Android platform, these are grayed out, and that's because I actually made a typo here. This should be Unity iOS or Unity Android. And we don't need this to be commented out. And you can see that it is basically trying to add component for player touch input. And I realized when I started implementing this that this is not going to work. And the reason it's not going to work is because this control that we've added, it's in the scene and it has serialized fields that need to be assigned in the inspector. These are dependencies that aren't going to be available if I just add components. So what we're going to do, I'm going to actually copy and paste a whole new version of this file with some minor changes, and we'll walk through them. Don't need this. So we have our if Unity iOS or Unity Android, we want to find object of type. So essentially, this object here is always going to exist in the scene, even if it's a Windows build or a WebGL build. It's going to be here in the scene. But we're only going to use it if we're on an Android or an iPhone. All right. So jumping back out into the code, let's continue walking through that. I'm going to go ahead and get rid of this debug statement that I was using to debug some stuff. Let's see, is there anything else in here I put in that is specific to the Android? It does not look like it. So then the next thing we want to look at is in our game UI. So in game UI, we're going to want to turn those controls, basically enable them or disable them. And we want to subscribe to listeners and so forth. Well, that's another thing it just reminded me of. We actually want to add a button to our Android version. So press space to play again is not going to work on the Android. So we want to make a little bit of a UI change to handle that. So under our UI here, underneath of our player touch input, let's add another button. So we'll say UI button text mesh pro. We'll call it play again button. And for the text, we're going to say play again. And let's try that Oswald bold font and make it like 36 points. Okay, and we're just going to select that, grab our move handle and drag that down to about there. Let's double this in size. So we want to do 320 by 60. And maybe I'll move it down a little bit more. It doesn't have to be pretty. Okay, so now jumping back into our game UI text, I am going to paste in our updated game UI code. So first of all, we now have a serialized field for our play again button. And so what we want to do is in our on enable, if we're on an Android, we want to subscribe to the play again button click handler, and we want to unsubscribe from it when we disable. And here you can see we're checking to see if play again text is enabled or not. One thing I want to do, play again text is now a serialized field as well. So when we enable, we want to initially set that to false. So that click handler is going to call a method we already had called restart game, and it's just going to basically call the GameManager's instance and tell them to restart the game. Another place we need to modify is our settings UI. So we'll go ahead and paste this new code in. So when we enable, if we're not an iOS or Android device, then we want to load the keyboard input settings. You know, those were our keyboard mappings, and we want to turn on those controls. We don't want to do that if we are on an iOS or Android because there are no keyboard controls. So we're basically just turning them off. Okay. And then nothing else really needed to change in this class because the other things that are specific to the keyboard controls are not going to be called if, like, you know, we're not calling them. I could put this inside of a preprocessor directive, but there's really no reason to do that. Let's take a look at our start menu UI. And we'll paste in our modified code. Go ahead and get rid of that. So basically, we're going to add a button to our start menu to play. So that will be a new play button serialized field. If we're on a Unity or we're on an iOS or Android device, we want to turn on the play button and disable the press space to play text field. And conversely, if we're not on an Android or iOS, we want to use we want to disable the play button enable that press space text control. And we want to add the player keyboard input component. All right. And on enable, if we're not an Android or iOS device, we want to subscribe to the on settings saved event. The only reason we care about saving, responding to the on settings saved event in the start menu is if they change the keyboard mappings. And since there are no keyboard mappings, if you're on an iOS or Android, we don't need to subscribe to that. Same thing with on disable, we don't need to unsubscribe. And we were checking to see if the spacebar was pressed and update. We don't need to do that on an iOS or Android. And then since we're not responding to on settings updated, I just wrap that in here. In our update controls text, I basically, again, wrapped anything that was specific to keyboard mappings inside of a preprocessor directive. Okay, so I think there's just a few more. I think that might be all the code changes that are required. So let's go back out into Unity. And we want to put in our play button. All right, so that is that. Let me switch our scenes and look at our settings scene. Okay, doesn't look like there's any new serialized fields there. So now let's go and look at our game scene, at our start menu scene. And we're going to want to add a button here. So right now our fade panel is covering up our screen. So I'm going to temporarily disable that. And we're going to add a play button. So under UI, I'm going to right click, UI, button text mesh pro. We're going to call it play button. And we're going to go into the text for that. And we're just going to call it play. Use the Oswald bold. 36 points. And we want to double the size of it. 320 by 60. All right, and then up here, we're gonna now, since we want to be able to turn that press space text control off, we're going to want to drag that into here. And of course we want our play button. Okay, so that is all of that. Just go back into our game scene here. Yeah, so I think all of that looks good. The next thing we're going to want to do is build this out to an Android build. So I'm going to save my project. And I'm going to say build settings. And we're going to browse. We're going to click build. And then we're going to browse to a folder. So yeah, we got here under our tutorials folder, I have builds. I have WebGL. I'm going to create a new folder. I'm going to call that Android. Double click that and click save. Oh, I got to give it a name. I'm going to call it Asteroids. And that's going to take a while it builds. All right, so that finished building. And there it is. It's an APK file. Now, I am going to copy this to my Google Drive. And then I'm going to boot up my Moto Z2 Android. I'm going to download it from Google Drive, and we're going to test this out. So that one didn't work. I was just trying to test it on the Android, and for some reason it didn't recognize the play button. And I think it might have something to do with this event system here. So yeah, it's basically yelling at me and saying I'm using standalone input module, which uses the old input manager. So we don't want to do that. We want to replace that with this one. And I'm going to probably want to do the same thing in my game scene. Okay. But I'm going to go ahead and try and build it again, and I'm building it to a folder. Under my tutorials builds folder, I created an Android folder, and I'm just going to put it in here. Okay, so that build finished, and there is an APK file. I am uploading it to my Google Drive, and then I'm just going to download it from Google Drive onto my Moto Z2 Android. So I am screen recording on my Android. I'm going to go to Google Drive, and there you can see Asteroids.apk. Looks like that has not, there we go, now it's refreshed. So I'm going to go ahead and download that and then install it. And yes, I want to install it. Now here it looks like the install froze, but only the UI froze. It's actually done installing. So if I come over here, I can actually close that package installer. And then you can see Asteroids there on my desktop. So I'm going to click that, and you can see it's automatically opening up, rotated in landscape mode. I hit play and it switches to the game mode, the game scene. And there, I am using my stick to rotate. My stick is backwards. I need to actually go change that. But I can thrust, I can fire. All right. So as you can see, I have mobile touch controls working on my Android. Well, I think we have reached the end of this video. This was a long tutorial. If you hung with me, good on you. I hope you found it useful and interesting. And if you did, do me a favor, click that like button. Every time you click like on one of my videos, you're telling YouTube that this video is worth watching, and they're going to put it in front of more people. And be sure to subscribe to the channel as well. And if you want to be notified the next time I post a video, be sure to click that notification bell. If you have any questions or comments or suggestions, you can always drop a comment in this video, but even better, go over to my Discord channel. I'll put a link in the description. You can post more detailed questions there along with code snippets or screenshots, and I or somebody else may get back to you and help you answer those questions. Finally, be sure to check out my buddy Monty's channel. I'll put a link to his channel in the description as well. Thanks so much for watching, and good luck on your game development journey.